Senhores, bom dia.
Ladies and gentlemen, good morning. A very warm welcome. If you can all take your seats. We will begin the activities the second morning of the program of the 17th National Meeting in Research into Malaria. We'd like to ask for those here to take your places and keep your cell phones on silent mode. We also tell you this event is being recorded and the videos will be made available in the official channel on YouTube. For those who are watching us remotely, please feel equally welcome. Ladies and gentlemen, we will begin now our next conference. As found in the program, we would invite the researcher Daniel Youssef Bargieri from the University of São Paulo to preside over the activities. So just a correction. Good morning to everyone. My name is Daniel. We will continue today with our programming, and we have today, it's the second day, the second day of the conference. We're going to be talking about innovation approach to soluções equitativas. Our words will be in English. It's a pleasure to introduce Kevin Tesk, who will be our speaker. So if anyone needs any interpreting equipment, you can go pick it up outside. The presentation will be in English. I'll be introducing it in Portuguese because maybe some people still have Portuguese in from here on out. Kevin will continue in English. So Kevin, please come to take your place here at the front. Kevin. É prazer introduzir Kevin Test. Kevin is a graduate in applied biology from the University of East London, and a doctor in molecular parasitology and biochemistry from the Edinburgh University. He's a director of the fever and malaria program at FINE since January 2023, bringing more than 20 years of experience in infectious diseases, academia, industry, and biotherapeutics. Previously, he was an associate professor at London School of Hygiene and Tropical Medicine, where he led initiatives and research in Eastern Africa, Western Africa, and in Southeast Asia. He combines this technical expertise with innovation for promoting solutions in diagnostics and equitative solutions. He also works as a member of the faculty of the Ghana University and mentor in the IAVA program, Mentor. Então, é um prazer apresentá-lo aqui.
Floor. Thank you very much.
Thank you very much.
Bom dia a todos. Did I get that right? Okay. Okay, so thank you very much for the introduction. I'd like to start by thanking the organizers. It has been a fantastic experience coming to Belém. I really enjoyed the FIOCRUZ NIAID events, and this has been equally as good. So thanks to the previous speakers, and I will try and work this device. So, thank you. So I'm going to go and give you a bit of an overview, and so the project is really going to focus on some key points within my portfolio that I think would be of relevance to this meeting, on how we go about developing diagnostics, what we do in terms of that support pathway, and how we can go from, and some of the questions we're now having to ask based on some of the changes that are coming in the community. Okay, I'll declare I have no conflicting interests, not being paid by anybody. Okay, so as I mentioned, FIND is what's called an end-to-end PDP, and that's a product development partnership. We're a not-for-profit NGO targeted with our main remit is trying to develop accessible diagnostics to everybody who needs them. So what this is showing you here is, oops, oh, here we go. Okay, right, try that again. Okay, so what we hear is this is supposed to represent the pathway that we can engage in. So we can start right from the research development. We can sit with you and help you design the projects if you have an idea that is that you think we can develop. And then we can go through to support the manufacturing process right through to the regulatory element. So I'll talk about a project where we support developers in being able to access the sort of regulatory requirements to access WHO PQ. We're a collaborative site partner with WHO, so we tend to work very closely with them in terms of developing the type of instructions that are useful to developers in terms of developing the diagnostics that we need. So things like the preferred product characteristics, which is a sort of loose framework in terms of what the device needs to try and address, up to a target product profile or a TPP, where what you're doing there is setting out the minimal and the optimal characteristics for any particular test, depending on what that test is trying to achieve. If I can go into a little bit more detail, what we try and do is, what we have done is we engage at the pipeline. So as I said, we can engage with you at the beginning to help you develop your device or your product. We can also evaluate those tests, so really make sure that the tests that are hitting the market are fit for purpose and are doing exactly what they said in the information for use, or IFUs. We really focus on scale up and sustainability. FIND, as I said, is a not-for-profit, so what we tend to do is we engage with our partners, make sure that the structures are there in place. We work with communities, work with MOH. What we really try and do for all the projects under my portfolio is the initial step is to work with MOH, to at least let them know we're aware of what we're trying to do within the country, and then we kind of try and work with them to address the needs that they have rather than the needs that we think they have. We do a lot of raising of awareness and advocacy. So we do a lot of landscapes, we work with partners, we work with funders, we discuss what those gaps are, we identify those gaps and we try and plug them. And if we can't address them, we try and create the narrative that allows others who have the skills to either work with us or to take the baton and run with it to be able to develop those tools. As I mentioned previously, we work on the sort of regulatory elements where we're sort of looking at supporting evidence generation and really trying to make sure we support partners to get from one phase to the other, that they're doing the right steps at the right time to be able to address these sort of regulatory concerns. So some of the submissions to WHO take quite a lot of time, and it's quite expensive to develop that data. So understanding what you have to do at the beginning of that process is a much more efficient and cost-effective strategy. We've helped develop policy. A number of the organization work with WHO. We've been on WHO panels and other panels, helping with essential diagnostic lists and helping with other sort of aspects. Recently, we've represented the organization at G20, the G20 Health Working Group, but also, for example, recently I was at a WHO UNITAID convened meeting where we're trying to understand what the impact of the healthcare system is on the procurement pathway. So pretty soon there's going to be some directives or some information coming out from WHO really talking about how we can try and limit that sort of the pressure that healthcare and laboratories exert on healthcare. Examples being changing the use of plastics in RDTs, and I'll talk about the numbers of RDTs that are being used and how we can change that impact. It's about 5% of healthcare impact in terms of climate. And so being able to address that is quite a first step, and it will actually guide the rest of the community in how we can reduce that impact. And of course, there's really no point developing the diagnostic to put in somewhere if we don't have the ecosystem for that to work in. So being able to support laboratory strengthening, really capacity building, working with partners to develop that is kind of core to our mission. So it allows us to be able to support everything beyond just providing a diagnostic, to be able to create the ecosystem that leads to that efficient running, efficient deployment of those tests. So this is just an overall summary of some of the tests that the organization has been involved in. This is looking across the entire health program portfolio. I'm just highlighting 3 of them here. And so in terms of the tests that FIND has been involved in supporting all the way from development right through to market, that's not really the core mission, at least not within the malaria and fever program. What we do more of is really focusing on evaluating those tests and then make sure we can make sure those tests are fit for purpose to get into market. And that's where we feel we had real value and real impact in that space. So this is a summary of the portfolio products, really focusing on the malaria and fever program. So what it's doing here is we really wanted to get an idea of what the impact was in terms of reduction in disability adjusted life years, a measure of the impact diseases have on life expectancy, disability, etc. And also on costs and what we're doing, what impacts are we having in the healthcare system. So what we did was looked at malaria tests, focusing on rapid diagnostic tests and molecular tests, and we used a comparator being clinical diagnosis. And then the outcome for that would be focusing on the direct clinical benefit, and we also defined a DALY measure for each test. And so looking across from 2014 to 2023, what we had been able to do was show that we had reduced dailies to the number of about 13 million over that period of time. And when you attached a dollar value to the amount of money that was saved over that period of time, then the number gets quite large. We calculated this to be around 26 billion. And when you think about the amount of money national malaria programs or countries are paying per year on their different diagnostics, then you can see that this tracks quite well with that over that period of time. So what I'm going to try and do over the rest of the talk is really try and give an indication of the evolving needs of diagnostics. So the diagnostics we have now are not going to be the diagnostics that we're going to need down the line. And listening to some of the talks that had come beforehand over the last few days, you can see that once you've gone from near elimination to elimination status, the kind of tools and the kind of approaches you need to change to be able to address that change in demand. So crudely, you're going to need to go from tests which are doing something now to something that's much more sensitive down the line as you start looking in periods of declining malaria. So the kind of tools that you're going to need when you're looking at trying to look at control versus those that go along that spectrum to pre-elimination are going to need to change. And so what I'm going to do is touch on a light touch and hopefully spark some discussion after this is over around some of the areas that we're working on. So I'm going to talk about a project that we've just wrapped up called the Innovation Project. And this is going to give you an idea of some of the sort of evaluation processes that I talked about that FIND is particularly good at. I'm going to talk a little bit about what we're doing in the VIVAC space, where we're thinking about where we've been supporting partners and delivering novel tools to be able to address hypnozoic carriage and really trying to think about how we can really address that untapped reservoir. Naturally, we're going to talk a little bit about G6PD, but there were some excellent talks yesterday which really touched on the G6PD, so I'm not going to go into too much detail around G6PD or VIVACs. I'm also going to touch on non-invasive testing. So this is something that we've been really excited about. Unitate have been really interested about it in the past. Gates have shown an interest in the past. And this is really looking at tests that don't require any kind of invasive procedure. So moving away from taking a blood draw to maybe going for scanning or saliva and tests like that. Then I'm going to try and wrap up looking at what we call the diagnostic network optimization and how these tools can be used to really make it an efficient approach to the deployment of our tests. So whenever a test is developed, where do you target it? Where's the best, most efficient way to target it? And how can we really make sure we're targeting all the hard-to-reach places? And at the end of the talk, I'm not going to go into any detail about this particular aspect, but I put it here unshaded just to mention it so that hopefully it sparks some discussion after I'm done. And this is using spent RDTs or RDTs that are about to be discarded as a kind of surveillance tool. And so there's been a number of papers from the London School, from Swiss Tropical Institutes, Swiss TPH and others looking at using these spent RDTs as you would a dried blood spot, extracted material and then being used in a sort of cheap, accessible, sustainable surveillance method. It doesn't get rid of the plastics that you're using, but it gives a secondary use, which can give you some sort of measure as at least it's not going straight into a landfill. We think this is quite powerful because it allows you to first investigate malaria, looking at potential drug-resistant changes, looking at prevalence, any shifting patterns. But the real excitement is that beyond malaria, it has utility across other blood-borne diseases for which we can look at DNA. So I said I wouldn't talk about it, and then I did. So that's about it for now, and then I'll talk later on if anyone wants to know more. So this is looking at the pillars that FIND are interested in, and I'm not going to go through all of this. We're just really trying to think about how we can address the gaps for climate-impacted diseases, those that are falling under climate-resilient health systems, or how we might be able to support that, but also how we might be able to develop the type of test that can change, that can adapt or can be used that are more heat-tolerant, that can with increasing temperature. So what we're finding is that with increasing temperature, it changes the longevity of your test. It reduces it. So that impacts on the amount of waste or the efficacy of those tests over time. So we're thinking about how we might be able to address that, and we're happy to talk to partners about this moving forward. So I hope this is not controversial, but one of the things we've been thinking about within FIND is to really look at climate change as one of the problems we're having to deal with and not the problem. So climate change is having a massive impact. You know, as we're sitting around, we're watching the world drown or we're watching it burn. But it's not the problem in infectious diseases. It is driving some of those problems, but it's not the problem. Again, there were some talks over the last few days talking about the impact of deforestation, and I would argue that deforestation and changing land use is a much bigger issue in terms of driving climate change. I'm not saying we shouldn't focus on climate change. I just think that when we're looking at this, we need to think about the narrative when we're thinking about trying to engage partners. So some partners don't really want to talk about climate change. So being able to change that narrative slightly to still work on climate change without really, but approaching it from a slightly different angle means that we can still keep that narrative going on. So, you know, it's particularly exciting with Brazil coming off of the G20 and then moving to take on the COP30 in 2025, that, you know, we can come together as a community to think about how we can identify the gaps and close some of those gaps, be it climate only or climate and deforestation or change in land use. And this on the right is really just to remind me to talk about the WHO UNITAID meeting, which I already did. And really what we're trying to do is look across the entire procurement pathway to think about how we can limit the impact that we have that is contributing, even in a small way, towards driving climate change. And just to finish on that point, on the change in land use versus climate, just showing here some work we're doing now where we're trying to develop a novel test for Plasmodium knowlesi. Now, we and others have shown that Plasmodium knowlesi really is driven by changing land use, deforestation, reuse of the land, and bringing people in proximity to the vector species and the macaque, pigtailed and long-tailed macaques. So that's really driving that sort of aspect here. So we can get the right button. So you know what? On the left, you can see the forests before deforestation. On the right, you can see that change. And what we're arguing and what the data shows is that that is driving that sort of transmission of from the macaques to humans. We have identified a number of biomarkers, some novel biomarkers, which we have shown can give an indication of what the risk measure is in terms of regions that have an increasing risk due to change in land use. And we're trying to address WHO and community requests to really try and think about how we can approach elimination now that WHO has stated that one of the criteria for elimination in regions that have knowlesi, Southeast Asia, that they need to also show control of knowlesi. So I'm showing this knowlesi in Brazil, but it's really just trying to think about how rapidly we can respond to changes in diagnostic demand when the gaps present themselves. So such a test will obviously be looking at case management, but also looking at surveillance. Okay, so I'm going to go into the next section is going to touch on the innovation platform. And so the concept behind this is really to build a partnership of collaborative sites that have clinical trial expertise and also clinical trial sites already in place, with the idea being to support the rapid evaluation of novel tests. The key objective in that is really to address some of the technical and operational demands of new tests, with the idea being to address things like HRP2, speciation, and also be able to provide the type of tools that will help us address some of the surveillance demands. And as I'd mentioned at the top of the meeting, this is really to drive the kind of things that enables organizations or companies to be able to approach pre-qualification submissions, help with design lock, and this is where you develop your test to a point where it's pretty much ready to go. So you lock that design, and then from there on you're looking at trying to evaluate it as a final product. And this is really important, being able to evaluate that point, because if you have to make any changes about that, you have to start the process again, and that's a very long and expensive process. And then, of course, we're looking to improve digital and the use of digital and AI algorithms to support diagnosis. And I'll talk a little bit about specific examples within the VIVAX sort of scenario. Okay, so just very briefly, 1990s HRP2 was discovered. By the 2000s, we had products being developed. Big game changer in terms of supporting engagement and diagnosis of malaria. But around 2010, we began to see the presence of HRP2 deletions, and later on HRP3. And now we're having quite high prevalence around Africa and parts of South America. The graph on the right, or my right, is showing you the manufacturer sales and the take-up by national malaria programs. And I'm not going to go into the granularity of this, just to say in blue is the manufacturer's sales, and in yellow is really focusing on national malaria program purchases. And you can see that right from 2000, sales were around just under 100 million for manufacturers, with focus on national malaria programs really coming out to about 50 million. By about 2021, you can see that we're looking at around 400 million sales from manufacturers, and just over 250 million cases for national malaria programs, and that figure is growing. And so the implications of the HRP2 deletions, and I know most of the audience will know this, so I'll be quick, is the fact that it impacts on the diagnosis. So it leads to false negatives, impacts on the misdiagnosis of patients, potentially impacting on AMR, but definitely leading that under treatment is then driving the maintenance of those mutations in the environment. And then in 2019, WHO came out with a recommendation, and the main points of that recommendation were that in any region that had greater than 5% of negative results associated with deletions, then you needed to swap from an HRP test to a non-HRP test. So when I was talking about our evaluation partners, what we tried to do was look across 4 sites, so Peru, Indonesia, Sudan, and Rwanda. And as I said before, the idea was we picked sites that had expertise in clinical trials and had clinical trial setups, but also had sites with contrasting endemicity, so with falciparum and or with VIVAX, so we can really test the utility of those diagnostic devices. And so I'm going to show you 3 sets of tables which are just giving a bit of an overall summary on what we're able to do under this innovation project. So in the first round, first phase, we looked at tests, all tests, no HRP2 tests. So we ignored all HRP2 only tests and focused on all other types of tests. And what we tried to do is engage in the far right column, in the diagnostic development pathway column, we engage with different aspects of that process, so different development stages of those tests. And what we try to do is really try and get an understanding of evaluating those tests on the clinical conditions to be able to then generate data that supported whether or not those tests would have utility in the field. For phase 2 of round 1, what we then did was we looked at tests which were focused on HRP2, on LDH or HRP2 and LDH. And then what we're trying to do is again address the recommendation that you needed a test that could take over from HRP2, HRP2 only tests. And so we've evaluated those tests with a view to generate the data to help them go towards WHO pre-qualification submissions. And then for round 2, what we tended to do was then to look at, again, engaging from the early stages of development right through to further down that development pathway, looking at tests that were a bit more novel, looking at tests that were moving into other biomarkers like hemozoing, or looking at the release of volatile compounds from skin. And so as part of all of these phases, what we then did was built up a large bank of, a large biobank, and that biobank had not just blood-based products, but also volatile signatures. So the air from around your skin was then stored in specialized vials. We looked at readouts from infrared diagnostic devices like the nervous scan, and I think it's Gabriella had a poster on that a few days ago, which is really exciting to see. And so the idea is really trying to push the boundaries of the type of diagnostics we can get into the market. We don't want anything that's overly complicated, because really where we're trying to engage with is at the primary healthcare level. So we want something that has utility across the healthcare spectrum, but primarily at the primary healthcare level. Yeah. And so, sorry. And so the next steps for that is really looking at trying to secure another round of funding to be able to run the next round of the innovation project. Because it worked exactly as we hoped, which is a rapid evaluation of a lot of tests. And we've just shown here the tests that we were able to get through to the next phase of development. Right, so I'm going to talk briefly about Vivax. I think I don't need to go into too much detail with this audience, so I'll be brief, but you can quiz me later on if I've skipped anything too quickly. So really what we're trying to do is we're supporting partners who are trying to develop tests to be able to identify hypnozoic carriage. So this is really building on work from Eva Muller and Michael White, and is continuing with Michael White and Chris Drakely over at Institut Pasteur, with the partners shown at the bottom. You already know that the hypnozoite stage really, leads to relapsing fever or relapsing infection, and there were presentations yesterday talking about that percentage being around 80–85% of cases being down to relapsing cases. So there's a real drive to really try and understand and trying to get a diagnostic in that space to really address that untapped reservoir. So what was done here was really so what Michael and Eva did was identify a panel of different biomarkers, which they narrowed down to 8. And those biomarkers gave you a good indication that positivity to those biomarkers gave you a good indication that the person had infection with Vivax, and thereby potential infection with hypnozoite. It doesn't guarantee that the people that came up positive had hypnozoite infection, but the probability was that they had, so testing them reduces that sort of reservoir. So the idea was to develop a novel serological test, so looking at almost like a microarray approach of multiple spots, which then requires a reader to be able to read. Validation studies, both at the laboratory and early phase, had shown that it works, that you can identify, or gave the indication that it works, that you can reduce the hypnozoite carriage statistically. And so what FIND is doing in this space is supporting this approach to really try and develop this tool so that by the time we finish the 2 rounds of funding, that we have a viable functional tool, both in terms of the RDT, but also in terms of the reader that's necessary to support it. So FID's role under the 2 different projects, the current role is really supporting the development of a digital algorithm to support the reading of this novel RDT. The next round, which has been awarded at least by the EU, is to really look at furthering the development of that digital device, supporting the regulatory output, and then really trying to think about how we can look at the operational aspects of how this might work and how it might be deployed. Okay, so I'm going to touch on the glucose 6-phosphate dehydrogenase sort of testing and G6PD. Again, others gave really good talks about this yesterday, so I'm not going to go into any very much detail about this, apart from to say that in order to use tafenoquine and primaquine, you need to be able to know whether people have the mutation in their G6PD enzyme or gene, which means that they can't process. They lead to drug-induced hemolysis, and that drug-induced hemolysis can be quite high. So what was shown yesterday in a number of the presentations was this device here, was the fact that you can use this device to be able to detect what that readout is. The higher the readout, the intact their ability to process the drug, the lower it is, the less likely it is, and the more likely they are to be able to lead to hemolysis or drug-induced hemolysis. So what we've been doing here, we've supported work in this space, been able to develop this SD biosensor device, and be able to sort of manage, get it out into market and bring it to its completion. And I really should commend Brazil and being able to drive this within the country, in terms of really sort of pushing forward and trying to get this forward in terms of supporting tafenoquine and primaquine use within the country, and also the testing moving forward. And I know Marcus isn't here, but there's a lot of the, oops, oh, come on. I'll get this right at the end. These papers are just really showing some of the work that's gone on to support this, to really support the use of primaquine and tafenoquine, and also the adoption of testing and use of the drugs in Brazil. And so what we've been doing really around this is focusing on costs, on stakeholder engagement, on training, developing evidence that the biosensor was working, and also being able to map as to where these tools could be used most effectively. And so in terms of next steps, find are pretty much done in this space. So there's no more that we're going to do in terms of the current existing run of G6PD. Okay, so now I'm going to move on to building evidence supports non-invasive devices. And by non-invasive devices, I'm talking about devices that allow us to be able to measure infection without having to take a blood draw. And there are already a lot of non-invasive devices in the medical community. We look at X-rays, MRIs, ultrasound, you name it. They're all pulse oximeters. Yeah, I think I got that right. So there's a lot of those tests out there that allow you to be able to look in a non-invasive way, in a non-communicable disease fashion. But what we're trying to do, and I've given the Unitaid report in this space as an example, is really trying to be able to address that gap. Because what that will allow you to do is really allow you to be able to screen large numbers of people that current diagnostics can't touch. So we're not trying to replace diagnostics, we're not trying to replace RDTs, but we are trying to plug the gap that RDTs can't touch. And accessing that asymptomatic reservoir is exactly what we're trying to do in that space. So what we did was we ran a comprehensive landscape to understand what the landscape was in terms of what available tests were. And then we ran a number of semi-structured interviews to really get a feel for what people were thinking in that space in terms of understanding how that test would land. We then just recently completed a series of studies where we expanded our biobank in terms of what we contained and how we could help developers train their algorithms to understand whether or not these tests would work in the manner that we hope. So really trying to understand whether this will work in the way that we hope. And then and I've already talked about that, so collect the biobanks, use them to really train the tools, and then really think about doing these stakeholder interactions to be able to think about what people want in terms of the entire spectrum, from the hospital managers right down to the community health workers and to patients, to understand what is needed in that space. And so we're looking at the accessibility and feasibility of the test. We're looking at what the barriers and facilitators are to be able to deploy these tools. I already mentioned that we looked at these focus group discussions and also the semi-structured interviews. And also we conducted these tests across 3 sites of contrasting sort of diagnostic need. So Peru, Indonesia, and Rwanda. And so I'm not going to go through all of this, just to highlight a couple of points in terms of the perceived benefits. A lot of it was the idea that there was a lack of pain, that there was no more pain from injections, that you were able to, it was easy to use, user-friendly, with quick results and minimum training. That when we're looking at skin scans and odor, that there was ability to look at mass screening. and the fact that saliva tests were similar to tests that people were already familiar with, like COVID and pregnancy tests. And then in terms of disadvantages, people were worried that you would not be able to tell the parasite because you're not looking down a microscope, you can't detect what the parasite is, that speciation would be a problem. They were concerned about the safety in terms of using UV, so some of these devices use lights across the UV spectrum, so near infrared, infrared. It's a 5-second read, so it just gives you an indication of the kind of messaging that we would need to do if we were to try and deploy these devices, assuming that they were to work. So in terms of next steps, what we would need to do in this space is to think about how we can align the technologies with user expectations, and giving you a snapshot of the kind of feedback that we got from the semi-structured interviews and the focus group discussions means that we've got a little bit of work to do. It's not much different to having any other type of diagnostic in the space. We always do this kind of work to make sure that we're delivering the tool that the community actually needs. And then, really trying to understand the potential and really the power such a tool will have in addressing asymptomatic carriage. So this is really looking at the bottom half of the iceberg, if you like, that we don't normally address with conventional tests outside of research. Okay, so how am I doing for time? All right, doing okay. So coming now to DNO, or Diagnostic Network Optimization. So this is really work from my colleague Heidi Alberts, who's based in South Africa. So it's based around a piece of software called DX GeoMap, which allows you to put minimal data in and then be able to plan and really try and target the populations that you need to develop to target your diagnostics tools to. So up until now, I've talked about developing the diagnostics and supporting of those processes. But now what I'm going to talk about is really thinking about how you can deploy those tools in the most effective manner. And so what we really want to do is to say that, when you're looking to develop these or to deploy these tools, you're looking at a complex situation. Each country, each region is going to be different, and so you really need to understand the needs of each region, each community, before you can effectively deploy those tests. So understanding that and understanding the geography that you're having to encounter is going to be key. So one of the things we want to do is really trying to use this sort of tool to devise our diagnostic strategy. To really think about how we can derive the local insights. So one of the things I didn't touch on right at the beginning, I meant to, was the importance of partnerships. And everything that I've talked about really is building on the importance of partnerships, either working with funders or working with partners in country and working with MOH. And that is critical because it's not a one-way process, it's two-way. So when we're working with partners, we learn a lot about what we need to do in terms of how we need to deploy those tests, what tests are actually needed, and how to integrate with how to interact with the community in terms of deployment of those tests. So really getting that local level insight to really understand how we design and implement those tests will be critical, how we track it is going to be critical, and how we understand what the community and primary care level interventions are in terms of how we engage in terms of malaria and other infections. And so, what this is now showing you is looking at work that's been done in over 30 countries, where we've been looking at supporting Global Fund and PEPFAR investments, and really trying to use the DNO approach to try and address this kind of gap. And so what DNO allows us to do is really provide geospatially powered assessment. So you can put in your coordinates and certain other very minimal parameters, and it gives you this readout which tells you what the community makeup is, where you need to be targeted in it, and then, despite my comment at the beginning about climate change and land use, you can combine those two aspects to really think about how best to drive that aspect. So you can think about where land use is taking place, where flooding, where changes in rain pattern are happening, and how that might be impacting on disease, and then say, this is where we need to target the diagnostics and the resources in terms of people, reagents, etc. So the questions that we're trying to ask here are, what are the gaps? How can we achieve equitable coverage of testing? How many devices do we need, for example? How many devices do we need in a particular facility? And should we add more devices to establish a sample referral system? And how can we change the way that, or support the way that system works? and how can we best integrate those devices into healthcare. This example is looking at deployment of GCPD tests in Indonesia, and where Indonesia is aiming for elimination by 2030. So, what we're trying to do in this space is really trying to map up where all those facilities are, trying to understand where those health facilities are, and trying to understand where those tests would need to go, so that you're able to think about the best way to be able to access, to provide community access to those tests, to make sure we get in the coverage that we need. It's not simply a case of saying we've got hard-to-reach communities here, we're going to put tests there. It's really trying to understand how communities are using those facilities and how best to engage with them to make sure we get in the best coverage. And so, again, staying with Indonesia, we're looking at accessibility to essential diagnostics at the PHC level. And how you might want to plan for procurement. And so that's the other aspects that we're trying to do, not just once you've got the test, but how do you go about buying those tests, and how do you go about deploying those tests. And so using this DX GeoMap tool, you can then map out those regions to think about where the need was greatest, and then target your interventions based on that. I'm mindful of time. Okay, and so here we're looking at some of the key features. So it's a very simple test, and some of the key features that you can get out of it are really trying to understand, what the strategic network is, what the sample referral system is, performance management, quality and the human resources, and really trying to understand what you need. We recently completed a test in Kenya, using a slightly different system, and what that allowed us to do was get a complete overview of the healthcare facilities, which allows you to understand what the diagnostic ecosystem is. So you know what's available, where the people are, so you can even think about moving resources in terms of people, in terms of reagents, in terms of expertise, to make sure that you are targeting the regions which have the highest incidence of non-communicable diseases, or the highest incidence of malaria or dengue. So one of the main aspects about this compared to the system we used previously is this gives you a continual interaction. So it's giving you a continuous map. So the information you get is on a daily basis or a monthly basis, and it allows you to really be flexible in terms of how you manage your facilities and how you manage access to those diagnostics and to those healthcare interventions. What am I forgetting? Oh yes, it allows you to track trends in the trends in the network over time, and also to look at what-if scenarios. So if everything's running fine, you can still interrogate the software by putting in different parameters to try and think about what-if scenarios, which allows you to prepare for something coming down the line. So it allows you to look at these sort of potential mitigation scenarios. So if this happens, then we're going to do this. So if that happens, now we can do that. So everything's already in place for you to execute should that scenario happen. Right, so to conclude, climate change is incredibly complex, and I don't think we fully understand it. We know a lot, but there's still a lot of gaps in there. And what we're finding is when we talk to funders in this space, some of them come back to us and say, yeah, it sounds really interesting, but there's not enough data, there's not enough evidence. I mean, it's a bit galling when you think of the data we have now, but you kind of get what they're saying. If there's not enough evidence, then it's on us to try and plug those gaps and make sure it's really incontrovertible that climate is having that impact. But at the moment, I don't think we have all those gaps closed. We know it's part of the problem. It's not all of the problem. So I think when we have these conversations, that it's really good to have that discussion in that context, because some funders are switching off if you just talk about climate change. But if you talk about climate and you talk about some of the other parameters, the impact of poor health, air quality on lung health, deforestation, changing land use, then I think it allows you to change that narrative and still access the same question or the same point, but from a slightly different angle. I've already mentioned that partnerships and collaborations are essential. We cannot do our work without them. It's essential for us to have these partnerships and to maintain them. Yes, we're talking a lot about the non-invasives, and I talked a little bit about that, about how we feel that non-invasives have the potential to really contribute to the impact that other diagnostics and other control measures are having in the community. And then I hope I went a little bit quick in the last stages because I was mindful of time, but I hope I managed to convince you about the use of these sort of approaches, these diagnostic network operational approaches, which some of the other speakers talked about in the preceding days, and how useful they are and able to guide and target at the interventions that we need so that we're doing this in a more efficient and more cost-effective manner. I wanted to make sure I left time at the end maybe to thank all my funders and partners. There are so many. I've just decided to look at the institutions mainly to say thank you to all the funders, all the institutions, all this. I've labored the point about partnerships, and I think it's a point well made that we really need to make sure that, I think it's telling me to be quick, that we acknowledge our partners when we do these sort of presentations. So the first one was really looking at, oh, come on. The first one was looking at the innovation project, thanks to the partners there. The next one looking at all the work we're doing under VISMAX and find us a supporting partner in this space. And then talking about non-invasive diagnostics and all the partners that have been helping us gather all the data that we needed. And also to the rest of my team with the climate and health and what we're doing in this space. And obrigado pela vossa atenção.
Thank you very much, Kevin, for taking us through this challenge of develop a new diagnostic device from the present to the future, right? That we have microscopy that has served us for so many years, and in a lot of people here in the labs are used to PCRs or the molecular parts, but we have something in between that we're gonna need for different scenarios, and you can see that looking at this challenge, the things that the level that we're gonna face in different approach for different levels of elimination in different scenarios, and some very approach that can be used by the government for the public service for how to use in the primary care. This is something very important to many of people here. We have people in the crowd that is part of the surveillance in the government, and it's important to understand. This session is not set for having a discussion with the people here, but Kevin will be around, have been with us for all these days, and you can find him and, to discuss a little bit further. Thank you very much, Kevin. Thank you very much, everyone.
Agradecemos pela participação dos senhores. Vamos ao nosso registro oficial, com foto. Nosso pessoal da foto não está aí hoje. Alguém que puder ajudar. Pronto, muito obrigado. Iniciaremos agora a mesa redonda diagnóstico da malária na perspectiva do
Diagnosis for malaria from the National Pacto for Elimination. So this is the researcher from the Evandro Chagas Institute, Nogueira, Chamma, Siqueira. And to moderate the activities, we invite the researcher from the Oswaldo Cruz Institute, Foundation, Rafael, Maciel, Freitas. Good morning, everyone. First, I would like to thank the organizers and to invite me to such a relevant topic and such an important roundtable in the context of elimination. So then to make up the panel, which is diagnosis for malaria and the perspective for the elimination plan. we will call in 3 specialists whose contributions enrich our perspectives with distinct focuses and highly relevant points. So invite to be part of this panel our first guest, Dr. Cena, who is adjunct professor for the Institute of Physics of the Federal University of Mato Grosso do Sul and a researcher in biophotonics. He has vast experience in photodiagnosis and use of artificial intelligence. He's been working on innovation and the spectroscopy, optical molecular spectroscopy, bringing technological contributions for diagnosis. Thank you very much, Doctor. Next, we will hear Dr. Patricia Alvarez da Silva Batista, who also can join us. She works as a specialist in Bio-Manguinhos at Oswaldo Cruz Foundation, coordinates molecular diagnosis processes for the Ministry of Health. Dr. Patricia has a vast experience in biotechnology, leading development and standardization of the diagnostic assays for different tests. She's a national reference in the area of automation and molecular biology. And finally, but no less important, we will have Dr. Ana Paula Salles Morena Fernandes, titular professor for Federal University of Minas Gerais and researcher level 1A from CNPq. She has a vast trajectory in the areas of molecular biology, parasitology, and immunology. Dr. Ana Paula co-founded the National Center for Vaccines and has been coordinating the virus network of MCT, Ministry of Science and Technology. She's internationally recognized and nationally recognized and has been awarded the Peter Moring Prize as an example. So please, Doctor, you can take your seat. And Dr. Rafael. We will then begin the text. Just to remind you, we're in a round table. And each panelist has up until 20 minutes for the presentation. And then we will open up a space for discussion that will be led by Dr. Rafael Freitas. And we will prioritize the questions considering the time. So then I would like to ask everyone, keep within the established time so that we can ensure this proficuous exchange of ideas and to meet our timetable. So with this, I start off the panel number 4 and invite Dr. Cícero Cena to begin and make his presentations, give us his words. Thank you very much. So then, thank you for the invitation. I'd like to thank the Organizing Commission, Gisele Viana, who provided this invitation. Thank you very much, partner. So let me just test out here. If I move forward, can I go back? Yes, I can. Good. Great. So then I'll try to provide a general analysis to present to you what would be this photodiagnostic method. I don't know if you're familiar with the area, but I would like to be a little bit more, so excuse me if I'm just repeating things you already know about, but I think it's important for us to focus on and put everybody on the same boat, in the same wavelength. And so the idea of photodiagnostics is to use light to access properties of the materials, ecological materials, and to use these data to do your diagnosis. So then why are we invested in photodiagnostic methods? You probably know that the traditional methods have several limitations, including the high cost, the need to have trained officials, laboratory infrastructure, so on. So then if we do an analysis, a quick analysis, if you get a health unit and try to apply molecular tests, rapid molecular tests, these quick tests, at the end of the day, it's a cost of around $1,000 per day. So it's relatively high cost when you think about scaling up at the level of Brazil and Latin America. So then we will, if we substitute these type of tests, like a screening tests, with equipment. Equipment is a fixed equipment operation. It can be operated about 10,000 hours before doing the first maintenance. So this considerably reduces the cost the method will bring, besides the time. And data are obtained very quickly, and you can then direct better your next test that you're going to do, gold standard tests, and so on. And the cost, obviously, when you operate for 10,000 hours and doesn't need preparing samples, doesn't need highly trained people, this considerably reduces the amount, the cost for the test. So then the idea basically is to characterize biofluids, so blood, germs, saliva, urine, all these. So inside there are several molecules that have vibrational modes that are active. In other words, they absorb light. They interact with light in different ways, depending on how this molecule, depending on the concentration it has, and so on. And the most important thing is that they are sensitive. These vibrational modes are very sensitive to small variations, very subtle variations. And in concentrations, sometimes even the equipment is not able to detect, but the perturbation, they can show it when you're working with data analysis. So then what we do, we will get a drop of this biofluid, and we will get and analyze the molecule that's inside it. If you have an isolated molecule and you show some light, shine light on this molecule, the response you'll have is a range of absorption. And very roughly this, quick and dirty, it would be this, but in the detail. So in my fluid, you don't just have one molecule, you have several molecules. So when you add a molecule, you have an effect here of adding signals. We have a signal from a molecule A plus B. If these molecules are together at the end, what you're observing is a contribution of everything. And when a new molecule comes into your biofluid, what you will have as a signal is a different signal from the group where this molecule was not. So if you come into the biomarker or some molecular change in the composition, this can be noticed. Besides that, you can also have the presence of other molecules that will contribute towards deformations in the wavelengths. They can work with stretching, displacement. There are several things that can happen depending on the confusion that's happening inside there. So that's why it's a very sensitive technique. The changes, the subtle changes happen when you're in a process for immune response, end up being something that will drastically impact my signal. So then the basic idea is that besides this, we can also think about these molecules that when they interact with lights, like a balance, a harmonic oscillator. So if you have a child in the swing, for example, if you can push a child in a swing, if an adult comes in, you can see that you have a greater resistance to pushing the swing. Try to swing a child and then try to swing a child in the water, air and the water. So sometimes the molecules that come in the fluid do not interact with light. But the fact that they change the medium means that your oscillator is not able to assimilate in the same way. So then you change again the response of interaction with light with the fluid. And all of this will show changes. So basically what we're going to do is use a spectrometer, put in the difference wavelengths for light wavelengths, and we get signals from two groups, one control group and one infected group who have the disease of interest. And then these data, what can we do with these data? These data, first of all, need to be analyzed so that I can show what is the greatest contribution or the greatest variance that you have in them. One way of doing this is the main component analysis, where I get all the data that I have about my material and throw away everything that's very equal and try to show what's quite different. And each sample shows up in my scatter plot here. So if I have two groups, I have two groups that are defined like this. If they are well separated, they'll be fine. You can classify, you can have a decision. What's on one side and what's on the other side. It's another group. So you can, but you don't always have these boundaries. Sometimes you have a situation that is more complicated with data variance, where you have a low data variance, and these groups then a little bit jumbled up here. So we'll show this farther along. So then I can have a situation like this, where my component, the data I have, do not contribute to separation. And so then, fine, then I'm going to have to find a way to do a projection that will facilitate this, visualize how I can separate these groups. And then here come the algorithm, for machine learning algorithm, to see boundaries that make it clear what's one group, what's the other group. And I can also move around some parameters so that my algorithm increases the sensitivity and specificity and accuracy. I can manipulate this in the data analysis. But everything has a reason. So what I want to do, I want to leave this data, and there's protocols for a diagnosis, but I have to do this, I need artificial intelligence and machine algorithms. So for human health, we need to see these potentialities for application. So I can work with tropical disease, neglected disease. These are easy to implement, these methods. They are very low cost. And I've brought a photo to show you a proof of concept photo. The first proof of concept that we did in this project was the Chagas disease. Here's the liquid spectrum, typical spectrum for blood serum, which is deposited directly.
And you collect that data, and so you have two bands of protein, and you have contribution of our carbohydrates and lipids in this set. So you have a control group and one that is infected, and in the beginning you just can't see any difference, and that's why I need data analysis. So when I do PCA analysis, two PCs carry more than 80% of variance of all of the data sets. So it's a more raw analysis. So you can see that the group in blue or red have a tendency to separate, but it's not quite clear yet. So this is a proximity that is rougher. So there's a correlation between the spectrum in infrared, which is that previous set of data, with loading, which tells me what is the molecular contribution that is contributing for that separation between PC1 and PC2. And then we advance to take a look at PC3 or PC4, which is where we have the greatest difference among groups. So if it's more related to the protein bands, and it's got a little bit of contribution of phospholipídios. So this is a process to have the algorithm, and when you have a stage for training and another for validation. So in the stage of training, you have 4 spaces in PC, so you have a 4-dimension space, and then he will have a function to discriminate these samples. So when we're training, we can get to 91% of accuracy. So the classification is demonstrated by this matrix. Sorry. Now this matrix here on our right. So after I do this here, I have a predictive model, and then I'm going to test it in blind samples. So we have an external validation. So we have a decrease here, it's normal. We have here 87.5 because you have unbalanced numbers. The number of samples trained was smaller. So the power of generalization of the algorithm is not validated, but the potential to have a diagnosis is high. Now, regarding malaria, since 2012, we have a number of publications, 34. I had a systematic review demonstrating the potential for diagnosis of malaria in different stages of the disease. So here on this corner, there is a QR code for the paper. We have a group in Australia working with it. So you can see that we have these groups are well separated here according to the stage of the disease. So you can see that the technique has potential to be applied to this case. And so the intention is to have an algorithm that might do the classification of a number of infections and diseases and that have similar characteristics, and we can have this first stage of evaluation in a quicker way. The problem with those papers in the literature, we can discuss it later, but what we're proposing is a much simpler way to prepare the samples, to make the measure of the samples with the most accessible tool. So just so you have an idea, in this work I mentioned, they're using neural networks, so the accuracy is above 90%. So it's something that has got a lot of potential. So now, just to finish, I would like to thank the collaborators, especially Gisele from Evandro Chagas, the sponsors, and here we are open for discussion now. Good afternoon, everyone. I'd like to thank, really, the organization of the event. It's beautiful, it's extremely welcoming, and there was the invitation that came from Gisele. It's a great honor to be here and to share with you the tests, the NAT+ tests, and how malaria was incorporated in all of this context. I don't have any conflicts of interest regarding the topic. In the molecular diagnostic in Brazil, we start to think it began 20 years ago, extremely dependent on purchasing of imported assets. So we could see that during the pandemics especially, and during these 20 years, I can talk on for FIOCRUZ and Bio-Manguinhos that Brazil has developed into this independency. So FIOCRUZ has incorporated new technologies and has developed new practices of construction, of fabrication. And so we produce assets for biomolecular assets in Rio de Janeiro. And so we have this robustness of technological development and implementation of products. So what we do in Bio-Manguinhos at FIOCRUZ. So we received the demands from the Ministry of Health and the secretaries of the states, and we developed these diagnostics models based on good practices in the labs and fabrication, manufacturing. And we have these parameters of Anvisa. Okay, no, let's go back here. Please, can you go back a slide, please? Yeah, you can go back, please. We have all of these parameters of performance, evaluation, and during these 20 years, we could reduce the configuration of assets with a proposal of, we have just one control, positive, and there's the negative control and a tube with the mixture of PCR. And we have been working with this company with production at FIOCRUZ, and there's a fourth tube with a set of primes and probes that allow the diagnostics. So we have a viral particle that has a patent of FIOCRUZ, and it's a virus, an HIV virus. And we add to this genome of HIV all of our targets of our diagnostics. So it was very important for Bio-Manguinhos to incorporate SARS-CoV, and we have it in the general region of malaria, and panels of respiratory diseases such as adenovirus, Zika, dengue, chikungunya, Oropoche, Mayaro, and all of a potpourri of detections that we have in the development of our diagnostics products for SUS. So here are the curves of amplification. It's the same particle, mimetic particle, that generate these positives. So we do not have correlated situations related to biosafety. So it's related to all of this capacity that NAT Brazil has brought, so we could attend to SUS demands we have registered at Anvisa this set of products where we have, they are related to blood banks and for epidemiological surveillance of the Ministry of Health, and we have the incorporation of malaria in testing RNAs, and the first registration was in 2010. These were the highest demands, and this came as a demand from the Ministry of Health asking if FIOCRUZ accepted the challenge to develop a test with a good cost, implementing it in 100% of the network of SUS and in the national territory. So in 2010, we could have the registration of the first diagnostics where we could diagnose HCV and HIV at the same time. So then we could incorporate together with the vaccination of hepatitis B and C, and we had this registration in 2014, and we discussed a lot about the transfusional risk and if it would be dengue or chikungunya in that moment that we had a possibility of pandemics. So the northern region always had the emergency for testing blood for HIV, for other diseases, and then we could have the registration of Anvisa in 2022 on a second generation of Kitchenachi with another aim for identifying malaria, and we could have 366,000 immunologic windows, and so the Nachi test is complementing the serology and its aim is to reduce this period of detection of the immunological window, and it increases the transfusional safety. So we have this development always together with automation. So the first review of the product, it's used Minipool with a updated and automatized platform using a real-time real-time tool together with Bio-Manguinhos and together with connected to a data bank of the Ministry of Health, and Bio-Manguinhos manages FIOCRUZ since 2010 ininterruptedly, and making the transfusional safety in Brazil an example for other places. And then the fourth goal was malaria, which is the focus really of this event. So I want to tell you that the data are very surprising. So since the beginning, the goal was to reduce the time of inaptitude. So when people used to travel to an endemic area, when they travel from a non-endemic area to an endemic area, they used to be for a period of time in quarantine. So the detection of the Nachi test with the target malaria began in partnership with the lab of Dr. Paulo Ribeiro. So the first concept proof made with samples from IOC, where we tested primes, thousands of primes and probes, and it's one of the greatest groups to research malaria in the country. So we are trying always to be in connection with referential labs. So in the proof of concept for these regions, the greatest challenge was the cost-effective goal. So we find these viruses in plasma, malaria in the blood. This was the greatest problem found here. So we had to have a proof of concept, And because there was a new extraction from blood, a blood sample would lead to a cost-effective situation that we didn't have to implement NOT. So we can have better CT and higher extraction of blood. That's not what we're talking about. The thing is what we lose if we extract things from plasma, and what is the benefit from this extraction. So we could see that the model of extraction would have an impact on it. So we applied a specific extraction that was standardized with the best parameters to extract RNA from HIV and DNA from malaria. So the study demonstrated that if we changed the model of extraction and adjusted the extraction to these parameters in LISI, temperature, and tampons, and if we extract specifically for NAT+, we would gain in sensitivity. So we did a concept proof with a center in Manaus. So it's possible to detect plasma in the plasmodium of malaria. So from then on, we started to work to understand what would be the implementation of this Brazilian NACI. So if we detect it in plasma, it's more sensitive, less sensitive, but yes, we can identify it. So we began to propose NACI Plus, which is a triplex for identification of malaria. So we had 5,000 blood donors in the Hemo Center of Manaus, and we could identify positive malaria for a blood donor, which was asymptomatic. So from these 3 detectable ones, from 2018, we could tell the Ministry of Health that it was important to implement this detection of malaria. So this detection was the beginning of the consolidation of a concept. So we identified that in plasma and in asymptomatic patients in an endemic area. So from then on, what we did was we optimized and developed the platform NAT+, being able to do all of this. So this was a robot specifically created for Brazilian NACI, where we have this triplex identification, malaria with this identification with a variation of the mimetic sample. So the result of these 14 years of Brazilian NACI, we identified 182 samples. So within a immunological window for HIV, we have 123 for HPV and for malaria. With the detection began in 2022. It began in the blood center of Rio de Janeiro, and then we implemented it in the network. It's not possible to change all of the machines at the same time, but we have this number of asymptomatic blood donors and positive cases, and this says that it's important to the problem of malaria so we can have a help to eliminate malaria with this kind of detection. Out of these 600 million cases, we can observe that in the northern region, we detected 17, 5 falciparum. We only identify falciparum in the northern region in asymptomatic patients, and we can see that it's curious. This is an unexpected way to detect malaria in the southeast and south part of the country. We didn't expect this amount. So when we observe this data, so they present as 51% for the species Malaria's 37 Vivax, and 11% falciparum. So this map translates a bit of these data. It's not represented state by state because Brazilian nati is found now in 14 or 13 laboratories throughout Brazil, where this network is centralized. So these samples are very special. We have been working with Paulo Ribeiro and Fatima to understand sequencing and understand why we are identifying this amount of malaria. So we are opening different possibilities for studies, and so the Ministry of Health brings these regulation. So we reduce these inaptitude period for 1 month, and it's important because to donate blood is very important, and we have only 3.7 million donations per year of blood donation in Brazil. So it's important to have the Brazilian nati. So when we think about all of that, we begin thinking that we want to go beyond with malaria. So if Bio-Manguinhos can have this proposal, then we have to advance. We have to advance to have diagnostics. So we have been developing together with the EAC and EAC a multiplex
the species circulating around here where we can then detect the general goal of malaria and differentiate the malaria vivax and falciparum with the internal controls. And with this, we have been seeing what you do in the diagnosis for malaria. A test, an assay, a sensitive assay which no more longer based on plasma, but now based on the extraction of blood. So now we've switched to topics, and we'll see how the Brazilian Brazil was a pioneer in identifying and detecting malaria in blood bank samples. Today, large companies like Roche and Milpas have been incorporating this malaria text in their blood banks because of the example that we've given in Brazil. And based on this experience that you have, it's been consolidating with Bio-Manguinhos. We'll now go into the topic of development for detection of malaria, for malaria detection. So we already, together with the EC, we have already tested blood samples from DTAs for specificity and DBS. EDTA and DBS, we have specificity of 100% in our prototype. We've been working a lot with also digital PCR and Manguinhos, just abstract quantifications of samples, and from that, work on defining the sensitivity of the tests, the batches of the tests for all the ones that we test, to show you here the linearity then in general for Plasmodium malaria, and see how this test is really, it's a very large range of concentrations. It's quite specific and sensitive. So in terms of the values obtained, I'll run because of time, but later we can be talking more in depth. In terms of the malaria target, we have the capacity for detection of 8 hits and 40 copies per ml. So then when we go to multiplex discriminatory test, then we're also evaluating the Vivax species. We can also see here an excellent linearity detecting highs and lows and parasitemias. And with this, we're able to have a very interesting sensitivity and very satisfactory sensitivity of around 80 copies per ml. So then we've always looked at the batch, the general and the specific target for the species. In terms of the falciparum target, falciparum, we also are seeing here this linearity with this sensitivity for loads and replicate detections in different concentrations. The last point, I don't know, we detect 8 replicates for this specific test for patients, samples with patients, 66 copies per ml. This quantification is done by digital PCR to show you. And we have also been testing this proposal for our tests in the Acre expedition we were a part of in 2023. We had the opportunity of testing 214 tests from volunteers, and for which we detected in the general test for malaria 65 samples, and the rapid test only 4. So this shows that The molecular area is much more sensitive. We can know, obviously, it's got problems related to be able to get out of the field and carry out the methodology. And with this, we need to make adjustments to migrate to that's more looking at the molecular. And these same samples, we also detected one dengue. When we're talking about assays, we're also talking here about continuing this evaluation with IEC, with your malaria group, and Evandro Chagas at different moments where we evaluated the first moment 139 samples from the sample from IEC, both from slides and also BRS, where we had agreement with expected results. And now a second moment where we are evaluating these 90 samples where we also had expected and satisfactory results for performance of the test model. At the moment, what are we doing? We're talking about technology. We've been bringing this to say that we're prepared not only to deliver the Brazilian system for malaria, to have a multiplex system in real time based on for lab extraction in a lab you need infrastructure, but we're working on ready detection with MPOC where we can go to the field and take this chip, which has a battery. You don't need to even put it in the plug. We're talking about remote areas to be able to aid in this program for eliminating malaria, because you're not going to have molecular labs set up everywhere or transport samples, which is very difficult. For the Brazilian gnat, we have a tube with a much higher cost, which is PPT, and gel, which allows you to stay more than 4 days waiting for a process. So there are some locations where you have 2 days by boat for the samples to even reach a center. So we have to take the diagnosis out to the area, and then MPOC is bringing this. We're separating extraction, amplification, detection. The amplification and detection of MPOC is the proof of concept is ready. We're just adjusting the extraction very simply to be done in the field. Once this is 100% ready, we're evaluating with the IEC and also with IOC, Dr. Claudio Ribeiro and Maria de Fatima, so that next year we can bring this proposal ready for point of care. So then we have the data here, which is a mixture of detection in real time, which will in the field then be able to bring a health professional then to do a simple execution and to results very objectively to be able to treat the patient or not, and identifying what are the species. It's multiplex as well. And at the end, I'd like to thank the whole group, not only the lab that we're bringing here, that we've been here for so long in this front developing, but also to the groups that have been making up all these data not just from the lab. It's a set of efforts both from Gisele and Dr. Claudio, Maria de Fatima, Marcos Lacerda, and really without this unity of researchers it would be impossible to be sending all these achievements in molecular diagnosis that has been doing. So thank you very much. So, good morning, everyone. It's a pleasure to be here today, and I just wanted to especially thank the organizing committee and for this honorable invite through Gisele, especially our coordinator, Nathália. And if you can please, are they going to put this up on the screen? Yes. So I'll present here today a work that is still being constructed. We're still building it to bring this proposal to debate and discussion with people who are here dealing on a day-to-day basis with the cutting edge out in the problems and diagnosis. And the focus of our development here of our work are the rapid tests for detection of antibodies against antigens from Plasmodium vivax. This is all thinking about the context of elimination and later of monitoring, future monitoring of this condition. So then I represent, in fact, team that has been working together in this project for some time. We have here Ricardo Gazinelli, Gregorio Almeida, who probably you already know, Alisa D'Antonelli, and Soares, who's here with us here, Dalio as well, and Dr. Alstuda, Julia Sampaio, who's also with us. We will present a poster where we are able to better detail a series of others results and to develop a test. Here we have a declaration of conflict of interest. There are no conflicts of interest in this case. And as I said before, we are working on an effective or rapid test in a scenario of control and even of elimination. The perspective, the question that we're dealing with, sorry, I was not supposed to go yet. The question of Plasmodium vivax. We have here the question is with hypnozoites with a time between these relapses and within can be asymptomatic. But we can demonstrate it also in a work that I will detail a bit more next from Gregorio Almeida. We show the importance of these individuals, asymptomatic individuals, how they are important in perpetuating and transmitting the vector and perpetuating transmission of Plasmodium vivax. So then, considering that we have the objective in the national plan for eliminating malaria, we want to diagnose and treat all the cases. We will need then, in a context of low transmission, we will need to monitor the areas under control and identify. I'm avoiding to go here, my pointer, because I think it's not really able to show us here the details, right? But so then in the regions with low prevalence, which would be the scenario for the future, we hope, and then after the presentation from yesterday from Alda, we left us very optimistic with more recent results, and then we have in this context the fluctuation of parasitemia from asymptomatic individuals and considerable limitation of the current methods, diagnostic methods, both the rapid tests for detection of antigens from Plasmodium vivax or falciparum, but also Gregorio has demonstrated that even persons who are symptomatic with PCR negative, they can support the transmission through the vector with a work that was published in 2021. And in this panel, then next to, we have the follow-up for 6 weeks of 49 individuals, all of them initially positive in the PCR, and then we accompanied Gregorio also. Gregorio has been following this up also for a test which simulates xenodiagnosis MFA, and then we noted a major fluctuation both in positivity in the PCR and also in the capacity of infecting the vector from these asymptomatic individuals. In this context, we need to have new tools for diagnosis, obviously to monitor this future scenario, and the serological methods for detection of antibodies against the recombinant antigens has been growing in terms of the amount of data, with several groups here working with this type of methodology. And we would like to add here the question that besides being a sensitive test and based on these characteristics, it has to have accessibility. But these have just talked about the challenge here from the molecular portion, that they're trying to reach a point in terms of molecular, this is very important, low cost, quick results, real-time results, and the possibility of shared data and monitoring results in real time by public health authorities for the purpose of surveillance. And here we see the levels of IGs are more stable. We have data from different antigens for this. They rise quickly in recent infections, and they have a rapid decline after treatment, which is extremely desirable for us to monitor the populations of this scenario. So then we are facing this challenge. So then the first question is what antigens to use. We have here several groups researching different antigens, both in Brazil and outside, overseas. And we can also observe that some of the antigens really have this potential where the levels of antibodies rise very quickly. First infection, but also after treatment, we can see that some antigens meet this profile. They drop rapidly in a question of weeks, of days even, in this interval above around 2 to 3 to 4 months. And then our option was then to start to work with antigens that have been described. We've been describing it for some time. These are antigens, in fact, with the use of samples here in the country, in Brazil, which is another important question, in our population that have been developed. We've been developing this work especially from Irene Soares, and Irene and our group also has demonstrated that the antigens, MSP1 antigens, which is the surface protein from neurozoites, and AMA1 are antigens that meet very well these characteristics that we have listed as ideal to make up diagnostic tests. And so then we also did an evaluation with a very well described panel of samples of symptomatic and asymptomatic individuals and the controls from non-endemic areas. And in fact, there are 3 possibilities that we included here. The DPP2 protein, and we can show here with this panel that these antigens have a high sensitivity, but they won't detect in isolation asymptomatic individuals especially, but that when we make an association of these antigens, we increase the sensitivity of the test. And then considering the data for DPP and the difficulty of working in this moment with this protein for assembling a diagnostic test because of the characteristics that we have, chemical, physical, we then have initially associated with ELISA for validation of this hypothesis, the NSP1-19 in the AMA produced there by Irene. And so then what did we observe is that really with the association of the 2 proteins, we have an increase in sensitivity both for symptomatic and for asymptomatic individuals. And we also have here, including in this panel, we've included individuals and controls from endemic areas, and as expected, even because we've done this to describe this panel, we did a PCR in these individuals. So they will go and present some of them, and we'll have a positive index, an index above 1 in this panel, and this ELISA using these 2 proteins. But then we followed and associated the 2 proteins after validation of ELISA, and so then to evolve towards prototyping the rapid tests. In our Vaccines and Technology Center, I'll leave you an invite for all of you to go to Belo Horizonte, and when you're there to see us and get to know us, we have all this very well-structured platform from the conception of the antigen and identification through bioinformatics, proteomic, an analysis of what would be the best epitopes, the production of the recombinant protein, the validation of these proteins in ELISA, and based on this point then, we have all the infrastructure for R&D and development of the rapid test. So this is still very little exploited. There's not much infrastructure like this. We have few types of areas, facilities like this in Brazil are available for this type of prototyping, but we have a very complete, in our sector, and we have a very good setup. So this Delta hepatitis helped multiplex hepatitis B and delta that we've developed for both the single for hepatitis D and the multiplex. These are, this is the first time around the world we now have an important partnership with the people from the World Health Organization, WHO, to produce and register these tests and validate this in other regions. But then, besides the structure of R&D that we have that's available in the CT vaccines, we also have a manufacturing area, a small certified factory, but registered with the surveillance agency that allows us to provide batches of registration, preparation of documentation, dossiers, and submission to our National Health Surveillance Authority. So we hope to soon advance as soon as we define the final prototype with this question of the malaria test as well. So then this is the work from doctoral study from Julia, and here we have a prototype. In fact, it's the third prototype associating the two proteins. We've done several rounds of prototyping. We go at the field in Porto Velho. They've helped us. And then we can see what we need in terms of optimizing. We go to Belo Horizonte. And now in January, we'll go out one more time to Porto Velho for this field validation. But we believe that we already have a prototype that we presented, presented with a very well-described panel with a high level of sensitivity. Sorry, people. And it's quite significant. I'm not able to go back now. And that the test is working very well with plasma and serum tests and blood samples, especially because we need to have it with digital. The digital test needs blood to operate with this type of sample. So then, so far, we have a rapid test prototype based on recombinant antigens that is very well described to be validated out in the field with a potential tool for a low-cost tool that's accessible and coupled to a monitoring platform in real time, as we will show to you soon, of the areas in the process of control and elimination of malaria vivax. We still consider that even because of evidence of the literature that can be necessary to.
But since the prototype is very robust, we don't see it'll be complicated. We have already approved, tested recombinant antigens, and lots of labs have partnered with us, and with the possibility of adding new antigens. We wouldn't like that because with a new antigen, the cost of the test is higher. So we have to we want to work together with the epidemiologists and statistics team to build an algorithm to incorporate this test to a new protocol for diagnostics and monitoring. So regarding real-time monitoring, inspired by what we have seen with COVID, there's an importance of not losing data in terms of public health and data from rapid testing. So people begin to do tests at home. We have this perspective. So together with another company, a company that is in the technological part together with us, there is an equipment that they use, which is the DLS, with a mechanism to do the reading of the intensity of the signal in the rapid tests, and this can be applied to a computer, to a cell phone. And I wanted to show you a quick video. It's a homemade video of how this test is working together with this equipment. So as a first example, we will have a simple reading test. And afterwards, we can do the reading of two tests. And so with the reading, and we can open the equipment. And we can click on capture. And so this is the negative control. One pick up the negative control. Afterward, we can have this reading with a simple test that measures intensity. We click on capture, and as a response, we have a one peak demonstrating that the reactivity of the test. And when we use a high intensity test, as a response, we will have one peak of reactivity that is higher, a lot higher, which is compatible with these data. So this topic eliminates a little bit of the subjectivity of the reading. We know that sometimes a little shadow should be read as a positive test, and sometimes there's a difficulty to train the people, the staff, on a field, so this reading can become a little difficult. So it eliminates the subjectivity, and from capturing these data, we can generate reports to the patients immediately, and we have to take these data to the Secretaries of State of Health and the Ministry of Health so that we can have a surveillance system that is well informed in real time of the real situation of the individuals in endemic areas. So I guess really we have finished. I hope that I didn't pass the time. I was not over my time. And I would like to thank my partners in this project, Ricardo Gazzinelli, Lisa Antonelli, Delio, Irene, Gregorio. I would like to invite you once again to go there to the post with me. People from CEPEM Rondônia, the collectors, people from FIOCRUZ Minas, all of the people from CT Vaccines, and Miller in Australia that has given some of the antigens we have been testing. Thank you very much. Well, thank you once again. I'd like to congratulate the organizing committee for inviting such brilliant researchers that could bring this important topic. Everyone using their approach, we can contribute to it, and we have been dealing with a lot of different groups of researchers that are already consolidated in the field, showing that the capillarity of the advances, we have been seeing. And also, thank you for the researchers for fulfilling the accuracy. So all of you have presented your slides on time, so you were very educated about this, and I would like to invite the audience to ask questions. So please, you can identify yourselves and you can say where you are from or where you work. Good morning, my name is Maria Nozales from the Federal University of Rio de Janeiro. My question is to Patricia. In your test, have you also tested Plasmodium of monkeys? And could you say, is it something that you can also use in the Mata Atlântica, or you just had samples from those places? So, Mariano, for testing and diagnostics for animals, it's not Anvisa, it's MAPA institution. So at Bio-Manguinhos, we only work for diagnostics of humans with human samples. So Gisele has made that question for us as well, and so we will do those testing, but the registration of a product at Anvisa does not count for testing in animals. No, yes, in research. No, not in research. Yep. I would just like to ask you about research, and because we have to discuss this Mata Atlantic situation. Yeah, we are going to check that after the development of the product. And for the rapid tests as well. Hello, my name is Erika. I'm sorry, just to answering your question. I'm sorry, Mariano, we haven't done that yet. As you're using Vivax, I'd like to understand if there is a cross reaction with monkeys, with macaques as well. I know that falciparum, no, but maybe if we understand a bit more of the sequencing of antigens, maybe it can contribute to this matter. But yes, you can advance, Erika. I'm from the Federal University of Minas Gerais. A question to Ana Paula. You have talked about falciparum, but I would like to understand how these recombinant antigens, are they not well recognized by blood samples infected with falciparum? And how much of these antibodies how these antibodies are maintained after the treatment? Was that evaluated? Yeah, we have been trying to do this evaluation, but we have limitations because of the need for a set of samples. And these patients were accompanied for some time after treatment, and this data from some time ago, which came from Irene's work, we can see that there is a significant decrease 2 months after treatment. We have other data from a cohort in which we evaluated some time ago, and really, with 6 months, we have an expressive decrease, but we have to accompany them for a long time. So maybe without other researchers might have this serum library. So maybe we can have a deeper evaluation of this longevity. And what is the activity with falciparum? Yeah. MP1 is very specific, and with MSP1 we have data from a previous study that we developed to continue with this evaluation. Good morning. Thank you for your presentation. My name is Gabriela. I am from FIOCRUZ, Minas. I'm supervised by Luzia Helena, and I have a question for you. Now, regarding to Erika's question, which is about this persistence. So when you were presenting, we got to think that we do a longitudinal accompaniment in Rio Pardo, in Amazonas. So this study has lasted for 15 years. So we can see that antigens like MPB1 and 2, the response is maintained for a long time, 15 years. Even in an area where we don't have any transmission of malaria anymore. And even like that, some individuals continue with this persistence of response. So we can think, how can this test be applied in those areas where we have no transmissions, but the antibodies response is still high with those antigens, and we have individuals who are high responders as well. So actually, with that graph that I have shown you, it's not our data, but people work with different antigens that come from Miller, which are not the ones that we are using, and we can observe that the antigens vary in relation to this parameter. So even in the tests that have been developed with this antigen, we are worried about this matter of longevity and to being able to identify after treatment an individual that is not a carrier anymore. So we decided to work with those two antigens. I don't know, I guess Lucia also works with MSP1-19, and I don't know if from those data that you have for a long time, maybe we can have an evaluation of this longevity. But a very interesting aspect that is a difference between ELISA and the rapid test is that in the rapid test, you can adjust the parameters so that you can have, so that it has a smaller sensitivity, let's say. So you can adjust the parameter of the test so that you can establish a limit from which the intensity of these levels of antibodies, you will have sensitivity or not. So it's a very important topic, this one you were discussing, and we have to advance until we can combine with this panels of serum and the data from this new device. Thank you very much. My name is Gisele. I'm from the Tropical Medicine Institution of Manaus. My question is to Patricia. You said that there is a reduction of the inaptitude period in the patients. So what is the percentage of these donors that are inept in these endemic areas? And can we have studies to increase these donors using the NOT test, really, instead of trying to increase the number of donors that do not donate because they are inept? Yeah, so the amount of inept individuals in the non-endemic areas, I don't know about this information, but I can send you later, maybe. Any endemic areas? No, I don't have access to this data, really. It's a data from the Ministry of Health, but then we will have a workshop, a NATI workshop, and maybe I can check that data and tell you later. So regarding NATI being used for what you said, this is the idea. So the coordination together with the malaria program have been working together. So the idea is that with the NOT testing might lead to this natural proposition. So, Cícero, now, in what stage your study is? So, is it gender specifically for malaria? So we haven't tested it for malaria yet. We have been using samples of Chagas disease, leishmaniasis, and paracu, but the idea is to begin these studies with malaria in the beginning of next year. Good morning. My name is Maísa from FIOCRUZ, Rondônia. My question is for Cícero as well. I'd like to know if you already have a study or other groups for detection in mosquitoes, which is a limitation as well in the area of entomology. So as you have shown, you have different stages in the blood phase. So would it be able to be made in the different stages with the vector? Yeah, we have it for identification of phlebotominius, so to identify the biome in which it's inserted and species. But if it's carrying the protozoa or not, we don't know. Is it identification of species in the phlebotominium? For Dr. Fernandez now. The new kind of test. What are the conditions to use it on the field and regarding temperature, humidity? Can we use it 200 or 300 times simultaneously? the rapid tests are, in general, very stable. So our platform that we use for detection of antibodies, IgG, so for this test and for others that we have developed using the same model and format, we have data for stability on the environmental temperature of 2 years, so it's quite stable. How about the antibodies after treatment? How long you're going to detect it? So with the use of the testing, of the test, we do not have this data. I guess the important is we know from the literature that 2 months after treatment, there is a high decrease for these antigens we're working with. So with the tests, we haven't had the opportunity because we're still in a process of optimization. So I guess maybe going out to Porto Velho, we can finish that stage to tell you, so these are the conditions, this is the prototype, and we are pursuing samples and in a panel that can accompany the patients, and sometimes they can have relapses, so it's got to be a panel that can lead to a good evaluation, and we are searching for it. We're trying to do that, and Luzia has been working with that kind of patients for some time. Yes, the last question: what is the inferior limit that detects the falciparum? So from the molecular point of view, I wouldn't know, but we have been, our reference is ELISA. So we work with positive samples from ELISA, and we have an index of reactivity, which is based on the average and 3 standard deviations from cutoff, and from the negative samples, knowingly negative samples, and we are always referring it regarding ELISA, using ELISA. So normally the rapid test has a limitation with the samples that have an index of reactivity in ELISA lower than 1.2, but we can always make this adjustment because the platform of the rapid test is quite user-friendly to make these adjustments. Let's go. This is the last question because of the time. My name is Rafael. I'm from the Federal University of Maranhão. So I work making diagnosis and treatment. Malaria is a very specific disease from the clinical point of view, and evolutionary point of view, and epidemiological point of view. That is based, of course, on the direct exam and the test. This is a slight doubt I have, and sometimes to answer some questions. So the rapid tests measure IgG. So isn't it a risk that on the field, on the countryside, you are going to test somebody that doesn't have any disease but has a positive result? Congratulations on your presentations. Well, I guess the rapid test is a tool, especially for those cases. For other diseases, not necessarily, but it's a screening tool and of monitoring of areas. So we're not proposing that isolate. We're not proposing it to be a diagnostics tool. So it can complement diagnosis. I have a question here. I know it's the last question, but I have a question here in this sense. In which scenarios it can be used or not, but we are not proposing it to be used as a unique tool. And for asymptomatic individuals, you have other tools, such as the clinical practice and thick drop. In general, they're going to be positive in a PCR or thick drop. We are talking about an additional tool to detect asymptomatic individuals that in a context of elimination, they are negative in most of the tests, but they can perpetuate the transmission. So I guess your question is important for us to contextualize what is the tool and its application in different conditions and scenarios. Thank you, Professor. Can I?
Hi, I'm Ana Carolina. From Dr. Gisele is my advisor. I have a question for Dr. Patricia. We know that, and you showed us also that the target for malaria currently is 18S, and that other targets are being tested as well for species-specific targets. I'd like to know if you are testing several targets for Plasmodium vivax and others for falciparum, and what would these be? What would be these targets specifically? So then there's a lot of questions involved in your question. Really, for detecting Genera, we're looking with, we've had reviews, as I said, we did more than 17 designs of different regions. And when you develop a diagnosis, especially based on PCR in real time, you have to really be concerned with the kinetics of the response. And multiplex responses, they have a greater complexity, and you have to be checking the interactions with dimers and other sequences, such as, for example, in this multiplex that I presented, we have sequences not only of genera, of genus, but also specific questions. So then you are still in the same well in the PCR plate in real time. Sometimes you may have more than 10 distinct sequences and probes, and you have to ensure that this multiplex has specificity and sensitivity that is compatible with the prerequisites you have for diagnosis, and also with the expectation of detection of the different species. The performance and amplification, for example, for malaria is quite different from the performance for vivax and falciparum in terms of for dengue. When you develop an assay for the genotyping of dengue, not dengue 1 has a different genotyping than Gen 2, 3, and 4 dengue. So sometimes we mix different regions that are target regions to gain sensitivity and specificity. So then there's not a single response for your question. This depends on an analysis based on what you're seeing in terms of response and testing from different sequences and different targets. So this mix in single and multiplex is different from the answers, different fluorescences. It's not quite so simple. It's not just a question of what target is being used. Thank you. Just a question. No, just because it was obviously the tool, the NAT tool for malaria shows that we're able to detect individuals that should not be donating blood, but I ask myself, is with this question of Plasmodium vivax, of the asymptomatic and epizoites and everything, wouldn't it be interesting to couple a rapid test? Because when we started to work with the rapid test, we started working with MSP1 with a view to blood donation questions. So that's how we kind of got started. So I'm asking myself, would it not be worthwhile in terms of blood donation for you to have a marker that is more stable than the molecular test? The idea is that the blood donation is not simply a diagnostic test. It's not just processing. And the molecular screening, it starts before that in the interview with the donor. So then a large part is only going to reach donation, people who have been through the donor interview. And the Ministry of Health has very strong work in how they do these questions. There's a very lengthy work to create a questionnaire and train professionals that have the capacity to screen before going to donation through this questionnaire, not just related to HIV and other tests and HPV tests, but also malaria. So you have this moment beforehand. These are not samples that are simply put to be tested from the donors without any prior assessment. The testing in blood banks is not simple. You have to have a high capacity for processing. We're talking here that saying that in one day in São Paulo they process more than 1,000 samples per day. And this result, because of the plaques, blood plates, you have to result in up to 48 hours. So if you increase very much this question of adding tests and blood tests, screening, you're going to, for example, the blood bags are going to become unviable. They'll lose their validity. So it's very complex to evaluate this, how you can add new tests to expand the blood transfusion security, safety. So what we're seeing is, of course, that we could be discussing detection of malaria and blood. It would be much more effective than donating blood in Brazil and the world, but you would make it unviable because of the processing time that's needed. There's another question here. So the question is, did you have today the detection of these 53 samples that it would not be detected of donors who've been through this triage, this screening before donation, actually, and also donors in endemic regions that have other criteria related, and that this was also added, and that detection of malaria and blood donors in Brazil is being constructed. This is what I think is the beauty of this topic, is for us to imagine that we went from a theory and today we've implemented 100% all the dirty blood, as it were. We just test for malaria. And it's a nationwide malaria test that we developed, researchers in Brazil, and that we were pioneers in the world. Ministry of Health had this prerogative before any other country. So then, based on that, we've been working on this data so that we can be bringing together, adding tools and possibilities that will add to the safety for transfusion without making it unviable to carry them out, because a question of viability of processes, but a question of viability of costs. And if we want to turn this detection into something much larger, you're going to make it unfeasible. So we have to balance it. It's a balancing act. It's a topic for us to reflect on and for us to be constructing, seeing what we do with data, what we do with the samples, what can we do, extract and bring out together. It's blood and derivates together with a program for malaria to converge the data and do research with researchers and other research that we can have these samples and ask questions. What would be the best target? Do we have the best target? Then currently it's the best target. It's not the single target. We have others. We can improve the substitution replacement of targets as we get ideas, because it's national development. It's not fixed. It's not one size fits all. So, okay, we need to close out this panel, even though the topic is extremely relevant and of interest of a large part of the audience here, including people who want to continue to debate. But just to close out, at the end of this panel, we observe that the great question here is to perceive that for development we need to be sensitive to the different conditions and needs so that we can, as Dr. Kevin and Tetteh said very clearly, we need to see what is the need within each scenario. So I'd like to thank everyone who made up this panel, which was a great honor for me to participate in as a coordinator. And we close out here to continue what is being programmed for the event. Thank you very much, and a good day to you. So we close out the activity this morning. We'd like to thank researchers who were part of it, and we'd like to ask you all to organize for our official photo. And next we will have our quick coffee break, and we'll be back in 20 minutes. Thank you very much.
We'll begin with the round table. We invite the researcher of the University of São Paulo, Marcos Bolos. And now we will have treatment of malaria, challenges and solutions. And as moderator, we will have the director of the Hospital of Juruá, Rio Grande do Sul, Suani Negreiros do Vale.
Very good.
So with an emphasis on transmissible diseases by vectors, he is master in epidemiology, and it has a vast experience. And he works with different topics on health, leishmaniasis, malaria. And so he will do the first presentation, Dr. Alejandro.
So is he here? Is Dr. Alejandro here? Good. And next, I think we can have the first introduction, then later I'll present the other ones. Or have you said already been introduced? No? Okay, good. So then later we'll have Dr. Aniele Costa, who's a master's and doctor's in clinical research and infectious diseases from INE of FIOCRUZ Foundation, postdoc in tropical medicine and specialist public health, also from FIOCRUZ, with courses in extension and Johns Hopkins and American Tropical Medicine Society, and an adjunct professor at Federal University in Fluminense Federal University, and a member of the Technical Committee, the National Program for Control of Malaria. And the third presentation will be made by Dr. Stefan Dupac, who's a doctor with 15 years of experience in developing anti-malaria drugs in the pharmaceutical industry, director of the Department of Synthesis and GlaxoSmithKline, World Development and Medical Consultant in Africa and with SmithKline, and manager for clinical research at Honpolonc, and currently is responsible director for medical and safety related to medicine being developed also by MMR. So welcome, Doctor. So the first presentation, as we've said, Dr. Alejandro will talk about mass treatment experience in Peru. Alejandro?
Recording in progress.
So thank you for the invitation. I'm very happy to be here and to have the excellent symposium and the presentations. We are learning very much, especially por... Acho que é português, então. Okay, so then I don't have any conflict of interest and with this topic, and I would like to say that to refer this FLING project. However, I will not present results because this study is just beginning. We are admitting patients in the field, and probably in a couple of years we will have information. So what I'll tell you is quickly is about what is this project FLING is doing. Many of these things you have seen yesterday in the situation in Peru, We've had 2 programs for malaria control in the 50s and in 2005. In both cases, the incidence dropped to less by 1%, but another one came back. So the history of this is ups and downs, in other words, an emerge from malaria emergencies. And so for that reason, we are concerned. This is what we have to do so that we can have in this permanent program. So then this is the PAMAFRO program in the 2005-2010, which almost dropped almost 80% by falciparum and FIOCRUZ with 4 years of intervention. So then you can see what you had. In 1 minute it disappeared in 2011. And then with this flood that we had, that you had in Loreto province, and the Ministry of Health themselves said, well, look, we didn't have the conditions to continue to support the project, but this is a mea culpa. I think this was an excessive mea culpa. What happened was that we did not recognize that the problem basically was PAMAFRO forgot what was its role of symptomatology. What is the roles of symptoms in malaria? So this is a problem. So then based on the lessons learned, and the questions we had with, as you see here, 3 scenarios. And red was what was we were permanently, we had the resurgences, but then we need to have, this is extremely expensive to maintain. The third in green, you see there was the technological knowledge, it's a paradigm. And with this meeting, we gathered the people from the Ministry of Health in Peru and international experts to have support, political support, policy support, because public health is, in public health, you have to have political support, policy support. So we started propose a proposal. We wrote up a program. In 2017, we had the approval as public policy, health public policy in Peru, not just a program. But this changed a bit the history of malaria by making it a policy and not a program. So as we see, as yesterday, this has 3 phases. Phase 1 of them, especially in the symptomatic questions, for the purpose of reducing transmission and reducing it in the intensity. Phase 2 is here, is where you will look measures such as mass treatment, and phase 3 is the elimination of malaria. So then, what differentiates phase 2 is exactly the treatment of asymptomatic people. It's what we want to do to treat the evidence, the reservoirs, because we didn't have evidence at the moment. So what was the situation in Peru of the Malaria Zero plan? There was a reduction in malaria and a small outbreak again. So then, but it's happening. But this led to about a 62% reduction. So then also in the last few years, here we have like to note note that the curves tend to flatten out in terms of transmission when you're working with interventions. And this gives us the conditions so that we can work, because in a treatment can work better with a lower level of endemism. So then to summarize, we have Vivax. Vivax is the main malaria strain in Latin America, a high rate of asymptomatic and subpatient malaria, and rural communities, 30 to 90% of the population in the rural communities. The recurrences are due to mainly to relapses. The migration time is the main factor for mobilizing and reinfection of the communities. We don't have any MDA studies for Vivax in Latin America. And then the results of the current malaria program are unstable. So then this is the design for treatment of the project. The FLAME project, this is a study, an open study and randomized cluster study, an open label cluster, which is 3 years of intervention in the field. They're being done in the Loreto department. That includes 30 classes, 15 per each arm, and about 1,500 people. And each cluster has approximately an average of 251 people on average. We're located between 2 to 8 hours distance from Quito, and there's an incidence of 2 cases in the last 2 years, with an incidence of less than 250 cases. So then this includes 1 arm. We're in a program for malaria control, and all the communities are receiving interventions. So 1 arm is control. We're not intervening. We'll just do the control. And the other one, we will add intervention, therapeutic intervention. So then the objectives here is to determine the effectiveness of the focal MDA in reducing VVEX transmission, assess the safety and tolerability of mass treatment, measure the cost effectiveness and acceptability of this type of mass treatment. So then open cluster, open label, as we said. The hypotheses are that first, the focal mass treatment will reduce the cumulative incidence in the communities where before the endurance, but reduce it at least 50% in these communities. And the serious adverse effects, especially related to immunity, will be rare, and we expect that they will be less than 1 per 1,000. Always when the patients have been measured previously with a glyphosate, and the patients who were the deficient patients do not receive the treatment. So, and the third hypothesis is that mass treatment will be more cost effective than the current treatment scheme that is being administered by the ministry. So these are the areas that we selected in Peru in 3 districts and in various river basins. And so we had provided a database of 3 communities, of which 30 were selected. And this here we had an incidence of 65% per 1,000. So then, since how did we do eligibility? First is that the patients will follow as the ministry set up the passive form, but then we'll also do an active search for cases. So then if you detect the cases, high risk areas, so all these houses that in the last 2 years have had 1 case of malaria at least. And this household includes the population of the household and the neighbors who are 200 meters or less and using the system of reactive cases. Annually, we'll evaluate how you have the reactive case system, and we expect that in the first year, you'll have about 7% of the population coming in. The second year, we think that we'll develop to reduce to 60%, and the third year, we'll have it reduced by 40%. This is the same. That are the 30 communities randomized and applied in 2 arms, a control arm and an intervention arm. And in the intervention arm is what was mentioned here, the requirements for the admission requirements. And then we ended up having standard interventions with the industry in the plan for malaria. So there's a high coverage of impregnated of impregnated mosquito nets, and also management of the case and active detection of cases when treated mosquito nets. So then we're planning here to have annually an annual round of 1A, 2A, and 3A rounds. And so the people who have age 16 of over the age of 6 and have glucophosphate normal do not receive treatment. They do receive 3 days of chloroquine and the usual doses, fluoxetine in 2 sessions. Those who are between 6 months to 18 and to 6 years who also have a glucophosphate normal have received 3 days of chloroquine plus 7 days of primaquine, and so 0.5 milligrams per kilo per day. And those who are intermediate level and are equal to or greater than 6 months will receive the scheme also of 3 days of chloroquine plus 1 day plus 7 days of primaquine. The rounds are 1A, 1B, 2D, and 3B will be administering 2 or 3 months afterwards. They have received round A. They will have then similar schemes, but will only be with single doses of chloroquine and scantamiquine, or own single doses in chloroquine plus primaquine. Why this single dose of chloroquine? These are studies that were included, Peruvian communities, and where you can see that the population is asymptomatic, and they usually have fewer than 100 parasites. So in other words, this is the level that they have, and the phenoquine is enough to control this type of patient, and the level that those that have the chloroquine with 1 dose, also it's sufficient because they have an average time that will be up to 30 days. So then from our point of view, this would not justify a new scheme, but to have the same one that we had in the second round that comes 2 months after the first round. So then this is again the protocol with measurement of leukocytes, where it's critical that the people have been appropriately trained so that they can effectively measure the glycophosphate levels. So those who are deficient are excluded from the treatment. So the outcomes, the most important is the measurement of the cumulative incidence. That's all the prevalence, 0 prevalence, then genetic diversity, not only the parasites, but also that the typing and those leukophosphate deficiencies, also those who are deficient in Cytochrome 450. The same thing happened for falciparum. And the second aim would be reduce the severe adverse effects, the incidence of severe malaria or any other incidence or grade 3 or greater, and tolerability to the study drugs. This would be a measure of the aspects, the economic aspects. So then the initial detection will be through microscopy. People who are treated with the ministry treatment system, and also will collect filter papers with blood to do the studies, PCR laters, and serology and sequencing. This will be the baseline, and each year and at the end. Here it says that we'll authorize microtimers. We're not going to be authorizing them right now because they're complicated and expenses and the conditions that the health industry, we prefer to manage everything on filter paper. We just decided to prefer that. So then a study here, you see the prevalence of the glycophosphate. And so then the validation of serological markers to exposure, and also the question of mobility and the doses of PMDA. And in terms of the size, the sampling size, we calculated with the power of 80% and a reduction of at least 52%, and also here in the classes. In this, in fact, there's also a scenario when you have a decline in the incidence that doesn't appear in the scenario where we're building. Here we have the timeline starting with administration of the drugs between December and January. The second round should be, so then later you'll do the follow-up in 2026, and that will be in March of 2026, and November of 2027, and finally the final event of the evaluation in January of 2028. So we'll be monitoring the adverse effects, SAEs, with administration of the drills will be followed up by specific personnel on the project for 7 days. So then all these people will be followed up and will be monitored in terms of urine and up to 30 days to see if they have hematuria. And in the people where you have suspicions, they will measure the hemoglobin. So then whenever you administer these medications. So you have the pharmacovigilance, pharmacosurveillance, it's active surveillance. Our major concerns are hemolytic events. That in this study of the PES study, it was like 900,000 patients. We haven't detected it. We hope that it continues like that. So then here, this is the group here, the working group for the field. So thank you. Thank you, Alejandro.
Thank you, Alejandro. This panel is very important for us on a basis, especially on a basis of elimination of malaria, and we're going towards that way. So this will be a mandatory strategy. So he talked about some doubts, but specifically what medications we're going to use, how we're going to use it, and so on. So the presentations we have next are related to adherence to treatment, which is another problem that we have. If we use a medication but we don't have adherence, we won't be able to control and eliminate malaria. So one is related when we talk about primaquine and tafenoquine. We are talking about that, and when we have higher doses, we have a higher adherence. So it's important to talk about it in this stage we are, to evaluate these stages of treatment and how to do it. The next presentation is going to be of Aniele Pinacosta from the Fluminense Federal University, and the topic is adherence to treatment, the evidences of research network Abracamal. I haven't said, but every speaker will have 20 minutes of presentation for their presentations. So first, I would like to thank you for the invitation to be here. I'm representing Abracamal, and we have research in 2 different centers. And our goal is to understand the contribution of recurrences of the epidemiology of malaria in Brazil. So we want to understand these multifactorial aspects, understanding what can be retransmission. And so I'm going to present some data from Abracamal, and just so you can understand this new mechanism, how this mechanism affects our epidemiology and of not only the adherence to treatment works. So we have made a work with different collaborators, and I'm going to show you the differences that we have in each one of the centers. And so we are going to bring this to the Ministry of Health and more information about it. So the Abracamal is divided into Vivax and Falciparum. So we have two different projects that recruit participants in two cities, Boa Vista in Roraima, which is our main recruiting center, and Porto Velho in the team of Adélio, Alex, and Michele. You have heard a lot about him because they do a lot of studies on malaria. So speaking about Plasmodium Vivax project, we have a multicentric work, and we try to understand the transmission by Vivax and trying to understand the relapses, the reincidences. So every result we're going to show you is rough data, and at first we opted for recruiting, and then we're going to analyze the data. So we don't have data from all of the samples. So everything I'm showing to you are rough data that need to be better explained and detailed. So as I said before, we want to understand these various components of reincidences. It's a multiple process that has to be related to the parasite and the host and the medication that that person is receiving. Our initial goal is to understand the initial rate of these reincidences in 12 months, but we understand that we have to extend that period. Now regarding, just returning. So our follow-up is composed by 10 visits, and we understand that from then on, the risk for that individual to be reincident is higher. So when we talk about Plasmodium falciparum, we can detect the kinetics of the presence of the parasite and the deletion of PFR1 and 2, the impact on this therapeutic response and parasitology of 22 days. So we have these topics. From those, we want to answer what is this process like and what is the problem with reincidence in Brazil. So we work with pharmaceuticals, epidemiology, quality of antimalarials, and a repository and analysis ex vivo. So speaking about what we have so far, and thinking about the two centers, we have 2,000 inclusions with diagnosis of malaria, 514 with diagnosis of malaria falciparum in Boa Vista, and in Boa Vista we collect falciparum because we have an important circulation of Plasmodium falciparum in this city. When we talk about Vivax, we have 1,142 individuals, and the individual can be recruited more than once. When he has malaria, he is included. So 1,000 and more than 1,000 in Boa Vista, predominantly male, with an average of 36 years old, and from 18 to 72 years old. And when we see our sample, we have more than 5,000 collected samples, and we work with filter paper because it's easy and because of storage, but we have samples with necessity of a different storage, which is harder work because of the location. And this is what I wanted you to pay attention to. We compare two centers with different profiles, epidemiologically speaking. So when we analyze Boa Vista, almost 90% of our participants are travelers, especially to mining sites in the countryside. And more than 55% of our cohort is related to mining activities. So we talk about mining-related activities because it's not only the miner, it's the diver, the pilot, everybody with an activity related to mining. And for illicit drug use, we have 21%, and this data comes from interviews. So as the majority of the recruited people come from mining sites, they make use of the psychotropics. So in Porto Velho, we have a different historical, so a different history, and less than 5% are related to mining activities. And about segment, about follow-up, it is quite different. We do a follow-up with 360 days, and the adherence to this treatment is different from Boa Vista because in Boa Vista the population is migrant. So they have malaria, they go to Boa Vista, and they treat it, and they go back to the mining sites. So we have a higher segment, more follow-up in Porto Velho when we compare to Boa Vista. Another important aspect is that we implemented the plate with D3, which is important for this clearing of D4. And so the visit from the health staff to the houses of the participants is very low. Here is Plasmodium falciparum. So we need a follow-up in D7. So 50% of our cohort is in this follow-up, and less than 30% of the individuals do the follow-up until D42. I was talking to Cassio before the presentation. When we talk about Boa Vista, we are talking about field work, right? Right on, and we are seeing what is really going on about malaria in Brazil. This is the frequency of recurrence, reincidence. So I'm not talking about relapse, recrudescence. So we're only going to be certain if it was a reinfection with all of the lab data that we are going to gather. When we analyze our reincidence, in Boa Vista, it's 23%, and in Porto Velho, it's 11%, with different times as well, different periods. So the minimum period in Boa Vista is 17 days, an average of 75 days, and a mean of 56 days. And in Porto Velho, minimum time of 30 days, and an average of 83 days. So we have to take a look at different stages and different states and regions differently, so that we can have data for each state. Well, this is our new frequency of recurrence, and for some participants, we haven't got to 1 year of follow-up, so we have 200 participants that were included, and they came back with malaria. 2 participants had the first episode and had recurrence in 2 other moments. So we had 3 points of malaria. And 1 participant had 3 infections of malaria in less than 1 year, and 7 participants with 5 episodes of recurrence in a period less than 1 year, inferior to 1 year. And this is to talk about falciparum data. We are used to talking about reincidence for Vivex, but we are accompanying the reincidences for people diagnosed with falciparum. So until we know, this is the bigger cohort of Brazil. So out of 514 participants from 19 to 57 years, we have 13% of recurrence with Plasmodium vivex. Different phenomena can explain this, of people that had falciparum, and after 29 years, they had an infection with vivex. So this diagnosis was initially a mixed malaria case, and it was not observed on the plate. So Marta Mook's study worked with 207 samples, and 40% of those had a molecular diagnosis of vivax. The treatment was for falciparum, but they had a Plasmodium vivax in that infection. And 9 participants of this cohort came back in 32 days after with falciparum diagnosis. And this is a new alert for us. So is it a new infection, or is it risk for recrudescence, or maybe a resistance to the derived of artemisinin? So now we worked with Flavio Costa. If you have any doubts about this, you can ask those too. I cannot explain in details, but we are observing the molecular aspects, molecular differences in patients with recurrence of malaria vivax. Examining the proteomic profile, when we evaluate, this is a bigger study conducted by those people, and Abracamal is part of it. So specifically for the cohort of Abracamal, some molecules that are involved in the production of xenoids and lipidic. So if something is happening, and these are data from the cohort of Boa Vista, something is happening when we talk about the proteomic profile, and the results decrease. So here we evaluated the genetic variability of genetic enzymes related to bromocrine, and here I'm thinking about, we studied 75 samples, and we observed that 20% had some alterations in the activity of CYP2D6. So some were metabolizers of the intermediates, and others had a reduced activity. And with we are evaluating the susceptibility ex vivo of Vivax to the chloroquine antimalarials. We included, and we had data from 20 participants, and what we have observed is that the isolated are sensitive to each antimalarial tested. We have lots of data to test yet, but until now, these isolates are sensitive to these antimalarials. Also, in partnership with Carol Aguiar, we are now evaluating the susceptibility ex vivo of P. falciparum to antimalarials derived from artemisinin. So it's important to understand. We have samples from 70 patients, and Carol has been working on 11 isolates. So we don't have the data if they're sensitive or not, but Carol can talk more about this if somebody has an interest on it. And so we analyzed HRP2 to understand it related to diagnosis. How was its deletion in our cohort of Boa Vista? So 21% of the samples tested had some deletion of HRP2 and 3. And now, to talk about this policy of distribution of tests in Brazil, so together with the malaria program, they could give us rapid tests to test people in Boa Vista and Porto Velho, cases of malaria. So in Boa Vista, with 1,600 tests, we observed disagreements. So we had the thick drop was positive, and then but the test of the the rapid test, the result was negative. So we had disagreements in 24 samples, less than 5% of disagreements. And just to finish, this is the best, in which we are very interested in. So we are trying to understand the blood concentrations of pharmaceuticals used in the treatment of malaria, and we want to correlate this blood concentration with the possibility of a therapeutic resistance. So before they began treatment, we had a collection, and we try to understand if there is an anti-malarial in that blood sample. So we make a question in our report if they received in the last 60 days treatment for malaria, to understand if we don't have any pharmaceuticals left in the bloodstream. So we identified, we analyzed 179 samples, and we saw a high concentration of lumefantrina, which means that these participants are using this medicine even before the diagnosis of malaria. And this called our attention because it's exclusive. This distribution is exclusive of the Ministry of Health. And then we investigated and we understood that there is kind of an illegal distribution in the border areas, especially in the city of Boa Vista. And analyzing the concentration of chloroquine, and we collected blood in the beginning of the treatment, and we had 6.8% of our participants with high concentrations of chloroquine, also pointing out to a high concentration and distribution and access to this medicine. So I understood that there is a phenomenon called incubate malaria. So when a person has symptoms of malaria, they take some pills of anti-malarials so that it can reduce a bit of those symptoms, and so that they can continue working, especially in mining sites. So we understand that it's very hard for those participants to leave the area, and there is an illegal commerce of anti-malarials in those border and mining areas. So they face exhaustive doses of anti-malarials, and so that they can continue working. So talking about primaquine and carboxyprimaquine, we analyzed a higher number of participants, so we understood that there are high concentrations of these two substances, and this individual doesn't know what he's taking. He's taking a drug for something that is circulating in his bloodstream. Well,
so as a complement, we have worked with his NCQS, which is the National Institute for Quality and Control of Pharmaco from FIOCRUZ. In partnership with the Ministry of Health, we collected batches of anti-malarial drugs from different municipalities: Boa Vista, Malaria, Pacaraima, Barcelos, São Gabriel da Cachoeira, Santa Isabel do Rio Negro, Jacareacanga, and Itaituba, and from a series of areas for indigenous-based Yanomami areas, indigenous areas all in the state of Roraima. What we thought about was that the quality of this drug is associated to temperature and humidity and good practices and storage, and not necessarily in these regions. There's a possibility of ideal humidity and ideal temperature, and in other words, good practices for storage. And so in partnership with the Ministry of Health, we work with these pills. We take out a sample from the batch of the drug dispensing center in São Paulo. Then later, this batch, a smaller piece of this batch, is sent to the municipality. It stays under normal conditions. The municipalities stockpiles this material, and then we make a spot visit, a surprise visit. We go and make spot visits to check these batches to see the municipality. They're not going to know that we're going to make a surprise visit. So then we analyze the samples containing at least 100 units of capsules in each batch tested. We analyzed the chloroquine, primaquine, artemisomegafloquine, and intermeticon, and all the batches evaluated were in conformity with expected. So we did tests with the aspect, identification, contents, average weight, disintegration, and content uniformity. And so far, everything that we've analyzed, there's no problem with the anti-malaria drugs that are distributed by the National Program for Malaria Control of the Ministry of Health. So to close out, talking about the impact, global impact of agar-mal, which we observed so far, without all of our lab data to show that we have a high proportion of mixed infection, which is not detectable in slides or thick smears. We have a high rate of recurrence of Plasmodium vivax between individual students who also have falciparum, who are treated individually. In other words, only when they go to the treatment. We've also been observing the indiscriminate use of anti-malarial drugs in the population that's involved in the gold mining.
Recording stopped.
And so we know then that this traffic of drugs and this pattern involves what's happened to the Asian cities in the Pacific of an emergency in the need for unified treatment that Plasmodium vivax and for falciparum. Just to call attention to those who are not really noticed, when we look at Roraima, we're talking about the triple frontier at a moment when Venezuela is facing a series of political and economic difficulties. So our next steps are expansion of the objectives based on the results that we've obtained and a broad discussion with academia and the malaria program to follow up these cohort studies with a broader segment, extended segment, and sharing of our samples with other researchers involved in the network, or work with open science, and seeking for funding and financial and partnerships. There's an enormous studies with findings from Bill and Melinda Gates and the Ministry of Health funding. And any doubt that you have, you may access our networks and our website. Thank you very much. Thank you, Daniele, for your instigating presentation. And now we'll invite for the last presentation Dr. Stefan Duparc, who will talk about studies underway on the daferquin and primaquin. Please. Good morning.
So I would like to thank the organizer for inviting me to give this talk on the different studies that have just been finished or which are ongoing with primaquin and with tafenoquine. It will be better with that. Okay, so that's the program of what I will present. So first I will start with feasibility real lab studies. After, I will speak of the PAVE program, which is a united program. After, I will speak of the initiated studies. And finally, I will give you a few words on the study, phase 3 studies that we are doing in India. So first, regarding the feasibility study, I think you are aware of these studies, in particular the TRUST study that was done by Delio Pereira and Marcus Lacerda. In this study, so we were using tafenoquine 300 milligram, which is a dose registered by the FDA, by the TGA in Australia, and by the different countries where the drug is registered. Then I will speak of the Arctic study, which is also a feasibility study. And in this study, we were using the same drugs and at the same dosage. So for the TRUST study, like for all the studies and the way tafenoquine has to be used, and it was also shown in the first presentation by Dr. Alexandro Llanos, we have to follow this table here regarding which drug can be given depending on the level of J6PD enzyme in the patient. So when patients have a normal J6PD enzyme, they can receive tafenoquine or also pramaquine at 0.5 milligram by kilo and by day. Tafenoquine cannot be given to pregnant women and to lactating women, and also currently it can only be given to adults from 16 years of age or adolescents from 16 years of age, but soon we hope tafenoquine will be widely available for children from 2 years of age. So in patients with intermediate J6PD level, in this patient you need to give only pramaquine at 0.5 milligram by kilo and by day. And for the deficient patient, you have to give pramaquine at 0.75 milligram by kilo by week during a period of 8 weeks. So in this study, which was the first implementation study to assess the operational feasibility of providing appropriate radical cure after J6PD testing, it was a retrospective observational study, and the data were extracted from routine surveillance forms. So it was coming from the CVEP malaria. The linkage of malaria and hospital e-records was done, and the patients were identified in case they were hospitalized because of hemolytic anemia. So this study has supported the adoption of the single-dose tafenoquine and the usage of the standard J6PD test for the treatment of relapsing Plasmodium vivax malaria. You can see at the bottom of this slide the two publications which are available regarding this study. So regarding Arctic, which is a study done in Thailand, so the objectives were the same. We were looking at the appropriateness, usage, and non-usage of tafenoquine and daily pramaquine based on the J6PD activity. And we were also regarding safety, assessing the frequency of acute hemolytic anemia. So what has been found from this study is that all patients treated with appropriate Vivax radical cure, TQ or PQ, were in line with the J6PD activity. We had a high follow-up rate for patients treated with tafenoquine at day 5 with 98%, and also at day 4 with 95% of patients which have been seen. 100% of the follow-up of the patients were done at malaria clinic level. We did not have any case of acute hemolytic anemia, including when we look at what was happening at the referral hospitals. None of the patients with possible sign of hemolytic anemia, none of the patients who had possible sign had in fact an hemolytic anemia. So nobody had confirmation from what was thought, because we were looking at very closely to be sure we will not miss any hemolytic anemia. We had 4 SIs in the study, so it was hospitalization, but these SIs were not considered by the PI as drug-related. Tafenoquine in this study was correctly used in 100% of the cases based on J6PD activity. And based on this, the result of this study, it is feasible to use tafenoquine with J6PD testing at different levels of the health system, from hospital to basic malaria clinics. If you go to ASTMH next week, the result will be presented in a poster, so it will be on Friday during lunchtime. So if you are here, Professor Prayut, who is a PI of the study, will be presenting the poster. Now regarding the PAVE study, so these are studies which are sponsored by MMV and PASS, and it's a program which is funded by United. So we had 3 studies, or we have, because it's still ongoing, 3 studies with tafenoquine in Peru, Ethiopia, and Vietnam, and there is a scope studies which are with pramaquine high dose, so it is 1 milligram by kilo by day during 7 days. Quickly, if we look at that, so regarding Peru, and if you have any question, I'm sure Professor Llanos will be happy to answer the question. We are currently at 110 patients out of 1,000, so the study should finish by the end of the year. For Ethiopia, it is written here that the study should start before the end of this month. We have been informed this morning that the first patient was included in the study yesterday, so the study has started. For Vietnam, we needed to have the drug registered to be able to start the study. It has happened on the 15th of October, so now we hope the study will start in the next few weeks. Regarding the 2 studies, which is in fact 1 study, but with 2 sites, several sites, sorry, in Papua, Indonesia, and in Papua New Guinea. So the first stage of the study, where we assess very closely the safety of the patients, because it was a high dose of pramaquine during 7 days, and we were afraid that tolerability will be a little bit difficult, and safety with a risk of hemolytic anemia could also be a problem. So we had a stage 1 which was finished during summer, and the data have been reviewed early October by the DSMB, which is called SMC here, and they gave their agreement to resume the study and to start the stage 2, where patients will be seen less closely because it is a real-life study and we don't want to have a clinical trial. So they will be seen only once after treatment, while before they were seen twice. And this study should resume this month, so it's imminent that the second stage of these studies will start soon. Regarding the investigator-initiated studies, so there is 5 studies, and the last 3 studies, CDOC, SCT, and VET, are used with a modified dose of tafenoquine. As I told you, tafenoquine is registered at 300 milligrams, but some people believe that maybe 400 milligrams should be used, or maybe the drug should be used in milligram by kilo. So there is some team working on that. I will show you in the next slides. So here it's a summary of what is done. So the effort study from Kamala Trimmer, like the Tadore study, in fact, the effort study is finished. I will show you that in the next slide. Tadore is ongoing. CDOT is also ongoing. And the SCT is ongoing. The VET study was supposed to start in October, but they have not yet started, but it should happen relatively soon, because they were supposed to start 1st of October. It is a 1-year study, so they will have to do it. So regarding effort, so again, if you look at on the right, effort will be presented, the result will be presented next week at ASTMH during a symposium on Sunday morning. So if you are at ASTMH and still there on Sunday, please go to listen this presentation, because the results are very interesting. I saw them, but unfortunately I cannot tell you anything. Don't ask me questions at the end, because I will not answer. But somewhere the results are really very good. So it was a big study with 960 patients, 220 from Cambodia, 150 from Indonesia. I put Sumatra because Sumatra is not like PNG or Papua. In Papua, you have the Shenzhen strain, which is more difficult to treat, but in Sumatra, Indonesia, it is not the case. They had also in this study 350 patients from Ethiopia and 240 from Pakistan. And depending on the country, different ACT or chloroquine were used together with tafenoquine. And as you can see, they have used the PK, the Pramaquine low dose during 14 days, which is 3.5 milligram by kilo. But in these studies, they have also used, as a comparison, the Pramaquine high dose with 7 milligram by kilo over 7 days. And finally, the last treatment arm was tafenoquine at 300 milligram. And in the studies, they compare tafenoquine to Pramaquine low dose and tafenoquine to Pramaquine high dose. And as I said, the results are very interesting. So I hope you will be able to come next week to New Orleans. Regarding Tadore, so Tadore is a big study, even bigger than EFFORT, with 1,090 patients. And there is sites recruiting in Brazil. And so the other sites will be in Ethiopia, Indonesia, and Papua New Guinea. And in these studies, they will use Pramaquine during 7 days at high dose, so 1 milligram by kilo by day for 7 days. They will use also tafenoquine with a standard dose, 300 milligram as it is registered. And in these studies, they want to use tafenoquine in milligram by kilo, so at 7.5 milligram by kilo, which is higher than what is done when you use 300 milligram. Doesn't work. Sorry, how do I go back? Here. Okay. Regarding the third study, the CDOT study, so in this study, like in the previous one, the dose of tafenoquine that will be used is higher, as it is written on the top. So they will use 450 milligram, which is 50% more than the 300 milligram. And the study is recruiting in Laos, in Cambodia, and in Thailand. Vietnam will only start by the end of the year. So regarding the fourth study, the ACT versus chloroquine study with tafenoquine, so it's called ACTQ, sorry. So the sponsor for this study is Choclo Malaria Research Unit. So as I said, tafenoquine will be given at a dose 50% higher than what is registered currently. And depending on the site, they will use either DHA piperaquine or chloroquine or artemether-lumefantrine with this dose of 450 milligram. The sample size is estimated at 606. The study will be done in the region of Mae Sot at the border with Myanmar. And the primary endpoint will determine at 4 months the post-treatment whether ACT is AL or DHA piperaquine plus tafenoquine is non-inferior to chloroquine plus tafenoquine. The study have started in June 23, and the completion of the study is expected next summer. What's happened? Okay. Next, the last study from the list. Oh, I went. It. No, it's. What did he do? It's a previous slide. Okay. So the VET study, one more time, this study is sponsored by Choclo Malaria Research Unit. It is a mass drug. Sorry. Yes, it is a mass drug administration study using a single dose of tafenoquine. So during this mass drug elimination study, either the patient will be positive for PVIVAX and will be symptomatic and they will be treated against PVIVAX. If they are asymptomatic or negative, or in fact, if they don't have malaria, they will receive 1 dose of tafenoquine. And for the subject, the woman, the pregnant women who are breastfeeding and the young children, they will receive a prophylaxis with chloroquine instead of receiving tafenoquine. So in this study, you can see they will use a different dosage. So from 10 to 20 kilo, they will give 150 milligram of tafenoquine. From 20 to 35 kilo, 300 milligram, which is a current dose. And for subjects which are over 35 kilo, they will receive a dose of 450 milligram. So the study was supposed to start in October, but it has been delayed, and they expect to finish the study by September next year. Okay. So the last point is regarding this tafenoquine study. We are about to start in India with a normal dose of 300 milligram of tafenoquine versus primaquine 3.5 milligram by kilo. So it is an open-label interventional multicenter clinical trial. We will have 300 participants with a randomization 1:1. So we will have 150 patients by arm, and we expect 10% of loss to follow-up. So we need to have 135 available participants. The study is randomized to be stratified by age. Under 12 years of age, and between 12 and 18 years of age, and greater than 18 years of age. The study should, the duration should be of 180 days, so patient will be assessed until 6 months. The screening and randomization to the treatment will be done at day 1. And we will have 5 outpatient visits following this day 1 at day 2, 3, 5, 8, and 15. And after there is 6 follow-up visits conducted at day 29, 60, 90, 120, 150, and at 6 months at 180. So here are the sites where the study will be conducted. We have done the phase 3 in India, but we had sites in the north of India only, and the recurrence, the relapse do not appear before 6 months in this part of India. So it's why we have sites in Mumbai, which is on the left. Oh, yeah, complicated. So we have the sites in Mumbai, in Kolkata, totally at the east. In the Sadar College of Bikaner, which is one at the top, which is not far from New Delhi. We have also Kiran Hospital, which is not very far from Mumbai. And we have Ahmedabad, which is at the east of the Kiran study. So it is the last slide, and I want to thank you for your attention. Obrigado. And as you can see, MMV, which is a non-for-profit organization based in Geneva, was created 25 years ago, in November 25 years ago. So it is the anniversary of MMV this month. And I'm open to any questions, except the one I cannot answer.
Muito bem, agradecendo a apresentação do Dr. Stefan, agora convidamos a nossa sócia,
And now we invite our partner, Suiane da Costa, to moderate these questions? No. Good afternoon, everyone. We are already on time to begin another event, but I guess our panel is very important, especially in times of elimination of malaria, or at least programming of this elimination. So I guess the panel has contemplated well what each health center that is trying to do this elimination. So I don't know if we can have some minutes to open for questions from our colleagues regarding what was commented before of our speakers. By our speakers, sorry. Hello. My question is for Aniele. Congratulations on the presentation and all the speakers. If I understood well, first a question, those patients that you're doing follow-up, are they treated with Primaquine or Tafenoquine? Okay, so my question is about Porto Velho, in which I guess the follow-up has a bigger adherence. So in your follow-up, you mentioned that in 1 year, only 10% of the people had recurrences. So you know, and everybody knows that, the recurrences might be relapses, recrudescences, and new infections. And maybe in 1 year, new infections are probable. So if we think that the recurrences were only in 10% of that population, it makes me think that the rate of relapse is quite low, because we have 1 year of follow-up, and the adherence, as the title of your presentation is, the Primaquine is very good, and the treatment is very good as well. I would like to know your opinion on this. Thank you. So we will open for one more question after this, okay? This was already noticed, was already said before. So we have a lot of points to consider. The first point is that we do not look for our health system when we are asymptomatic. Even if we have a intensive surveillance during this period, maybe he can go to another health system when he really has symptoms. So if we think that, when we think that all the health units are prepared for the diagnosis, maybe he looked for another unit and had another diagnosis and didn't inform us. So there is a disagreement between what we really observe in real life and what the patients actually tell us. So these are rough data, and what we're going to do after we have those data analyzed in a more detailed way, is to cross this data with the CVAP system, trying to understand if this person was notified in another health unit. Yeah, I agree with you. I was expecting a higher rate. 10% is low. But we have to understand that the scenario in Porto Velho is a very distinct one compared to other endemic areas. So in Porto Velho, we have the administration of Tafenoquine, so we have the reduction of the transmission in those areas. So I guess this is the data that we're still presenting. We didn't analyze all of the possibilities so far. So maybe the Primaquine is working so well that he's not looking for other kinds of treatment. But yeah, this is a low rate, and we decided to understand what was our frequency in all of the participants of the cohort. Because this was a rate that we had in previous congresses, and so we had the recurrence rates, so our rate would increase. So we tried to re-adequate our way to calculate, and we had patients until D60, and we would analyze which had recurrences. So now we have a rate for all of the period of a follow-up of these individuals, and then we have data to understand all of these three possibilities: recurrence, transmission, or recrudescence. Any other question? Sing.
From Suriname. I have first a question for Dr. Duparc. It's about all the studies that are being planned with tafenoquine. I saw that in one region, I think it was Thailand, that you were planning to give tafenoquine as monotherapy in patients who had a negative microscopy or rapid test for Vivax. And I know that there are studies from Kevin Beard saying that tafenoquine should always be combined with chloroquine for pharmacodynamic reasons. So I would kindly ask you to reply to that. And if I may, I also have one short question for the doctor from Peru. Excuse me for not remembering your name. It is about the study that is going to be done in those 30 hamlets. It's a kind of a randomized control trial. In 50% of the villages, you're going to do an MDA. But I was wondering if in the other villages, it would be better to provide the people with diagnosis and prompt treatment, because we know that that is also an effective way of combating malaria, so that you're not comparing it with nothing, but with another proven effective malaria control strategy. Thank you.
Okay, thanks for your very interesting question. Your remark is very pertinent. It is true, we should give tafenoquine with chloroquine or an ACT, more with chloroquine at this time, because we have old studies where we were treating P-Vivax with tafenoquine alone, and it was with higher dose. It was 600 milligram, even 900 milligram, and the efficacy was not fast enough. In fact, we had still patients with parasites after day 7, and it's where it has been decided if we want to treat P-Vivax, we need to combine tafenoquine with a schizontocidal drug. But in the study I have presented, it's not a treatment study, it's a MDA, and patients with P-Vivax malaria, maybe I was not clear enough, will receive a treatment with an ACT. It's only patients who have no symptom of malaria, so who are either asymptomatic or without malaria at all, who will receive tafenoquine on its own with a dose of 300 milligram. So it's what has been decided. I cannot tell you so much more because it's difficult. We try to speak with the sponsor to have more details, and they don't answer. It's data that we found on clinicaltrial.gov. If you want to have more information, you can also have a look on this website. But yes, your question is really valid because it's true, for the treatment of P-Vivax malaria, you need to combine tafenoquine with a schizontocidal drug.
Bem, então acho que nós terminamos aqui a apresentação. Queria agradecer a presença de vocês, a presença de todos os conferencistas por estar aqui, e vamos então desejar uma boa continuidade para o evento. Então, uma boa tarde a todos.
Oi. Bem, nós aqui agradecemos aos pesquisadores, senhoras e senhores, muito obrigado. Vamos à nossa foto.
Ladies and gentlemen, thank you very much. Let's go for our official photo with the people that composed this panel. Thank you very much for the brilliant participation of your brilliant participation. Well, so now continuing with our program, we'll inform some things initially. Well, so we inform you that because of the MMV symposium, we will have 2 moments for lunch, okay? We will have a first moment that will begin now. Feel free to be here, and there is another moment that will happen after the symposium. So we will begin the symposium now, and at the end of the activities, the receptionists will give some souvenirs for those that participate, and others can have lunch. But we thank you for continuing here, maybe. Remembering that after the symposium, everyone will have their meals after this. So we will have 2 moments for lunch so that everyone can be here for our symposium. Now, beginning the symposium, we invite to continue with the works Roberta Taide, representative of Global Health and partner of MMV. Good afternoon, everyone. Thank you for continuing here. Please just, you will have lunch in a few minutes. So this is the symposium planned by MMV and in partnership with our meeting of malaria. And we want to tell you a bit about the implementation of tafenoquine in Brazil. So as you know, Brazil is the pioneer, the first endemic country in the world that has been doing this. So certainly we have a lot to tell you about lessons learned in the real world. And we can't see it sometimes in the studies and the evidences to make this, transform this into public policy. So we're eager to listen to what our guests have to say. So you might have received an agenda, a notebook. So we just had some alteration. So after Alexander's presentation, we will show you a video that we did to illustrate, practically speaking, how this implementation of tafenoquine in Brazil has been occurring. So now I would like to summon our speakers, and then we will begin with the opening ceremony, opening presentation. So she's Senior Director of MMV, and she is representing MMV, which is the organizer of the symposium. I would also like to summon Alexander Vargas, which is the coordinator of the malaria area in the Ministry of Health and protagonist of the event. I'd like also to summon Dr. Roberto Montoya, here representing the PAHO. He has been a good partner in the implementation of cefenoquine. We also invite Dr. Alice Cena, which is the coordinator of Project Curema and researcher of the Parasitarian Diseases Lab at FIOCRUZ. She will also speak about this in our symposium. I would also like to summon Dr. Miller, who is the chief of the Division of Medicine Research, Liza Hall. And Dr. Adélio Pereira, who is also a partner for a long time, and he is a researcher of CEPEN in Rondônia. So I would like to call Elodie to open officially this event on behalf of MMV.
As Roberta mentioned, really paving the way on the implementation of tafenoquine, not only for Brazil, but for the region. And it's very impressive the speed at which Brazil has incorporated those new tools within the public health system, SUS, in Brazil, and especially in one of the most difficult to reach and remote area in the Amazon region with the Yanomami population. That's really very impressive, and that was done with the adult formulation, and now we are very keen to continue working together for the implementation of pediatric tafenoquine, knowing that there is a high number or high percentage of BAVA cases which are actually children. Of course, I would also like to thank PAHO and the support that they have been providing to the Ministry of Health of Brazil, and the PAHO organization in Washington, who is critically extremely supportive of all the countries in reaching the malaria elimination goal. And we believe that there will be new guidelines released by WHO headquarters in Geneva by the end of this year, hopefully, related to the PVAX case management. And again, PAHO will play a very critical role in the region to support the implementation of those new strategies. And of course, I would like to thank all the experts here today who have such an expertise and wide experience in dealing with Varvax malaria, and I'm sure that we will be learning a lot from them. We've been really collaborating with the Ministry of Health here in Brazil for many, many years. We were heavily involved in the trust study, and it's really a pleasure to be here today to hear from Alexander about the implementation and the lessons learned about the implementation of tafenoquine in the region. Also, we would like to mention that we have also been producing a document based on all the lessons learned that we have learned from especially the experience in Brazil, but also from many other countries in the region, on different operational research and pilot on the use of the test and the new drugs. And if you look at the booklet that we are provided to you today, you have actually a QR code that you can look at, and that will give you a direct access to this lessons learned document. And I believe that you will hear a lot by reading that. So, well, I hope that you will enjoy the symposium today, and again, really pleased to be here, and thankful for the organizers of the conference. Thank you. Over to you.
Obrigada, Elodie. Queria também dar a oportunidade de
opportunity for us to talk about tafenoquine, especially regarding the elimination of malaria program that Brazil has until 2035. I guess tafenoquine is one of the tools that will allow us to get to this bigger goal. Afterwards, I will be able to speak a little more about it. Yeah. So we want to thank for this partnership with GHS, MMV. We really thank and all the researchers that have worked on it. Tafenoquine is not a new drug. We are used to saying that it is an innovative drug. It is old, but in the last few years, many researchers, especially people in the surveillance and assistance, they have worked for us to be here today. And afterwards, I will try to speak differently about the difficulties and positive points that we had in the implementation with tafenoquine. And I would like to thank the partnership with GHS and MMV because it's been 5 to 6 months that we have been working on pediatric tafenoquine. So the incorporation, we hope to submit it to Conitec until December. So maybe next year we might be able to use it especially in indigenous areas that have a demographic profile of kids, 40% of kids being infected. So to finish this opening panel, I'd like to ask Montoya to say a few words. Thank you, Roberta. Thank you for the opportunity, for the idea of performing this event together with MMV and the Ministry of Health. So I'll just say one thing. Yesterday I was talking about PAHO. We were talking about a lot of expansion and access to diagnostics and treatment. This is the priority. Without the expansion of diagnosis, we cannot even start talking about primaquine and tafenoquine or anything. So this is the first thing. If there are no diagnostics, there are no cases, there's nothing. And definitely, yesterday I also highlighted that for us, we have a proportion of more than 70% of malaria vivax. So this is a fundamental part of in the elimination agenda. So in this context, we believe that tafenoquine undoubtedly will have a very important role. This is one of the solutions, one part of the solution, so it's a very important part of the solution. Luisa has already said before that today WHO is still working on the recommendation of tafenoquine for testing. So we are waiting for December. We're waiting these recommendations until December, and definitely this scenario would be of a collaborative work with the other countries for implementation. So it was fundamental until now to support this WHO process, and it's still fundamental for this learning with other countries. So I guess it's quite pertinent for us to have this talk right here and to think what we have ahead in terms of the implementation of a tool that can complement other strategies. Thank you very much. Thank you, Montoya. Now I will summon Sheila. She'll be the moderator, and she's also part of the Pan-American Organization of Health and here in Brazil, and she has been also a great partner in all of this process with tafenoquine. Thank you, Roberta. Hello. Good afternoon, everyone. Thank you for all of you that are here with us. So this panel, I was invited to moderate it, and I guess also because of the proximity I have, closeness I have with the malaria program, so that we can understand the lessons learned in Brazil with the implementation of tafenoquine. This is a journey I've been participating since 2017 with a lot of different people. How this work was developed. It was a very complex thing. This initial stage before the implementation, which I guess is a lesson learned that should be approached as well, not only now. So I would like to now give the word to Alexander Vargas, my friend, which is the coordinator of the Program for Elimination of Malaria. He is a veterinarian doing his master's degree in animal biology, and he is in 2024 coordinating the malaria program. And we want to listen, what are the challenges that you have received in 2 weeks of management and what you had to do. So we want to listen to all of your experience until now.
Yes, so then 5 minutes, 10 minutes. I will try to be brief. I will try to talk in a lighter way. You've already seen our presentation, most of you. So at the beginning, when I was a part of the Ministry of the Health for several years, my colleague Cassio as well, it ended up that I went to work there in that area, and both of my colleagues and Cena in Coordination for Elimination of Malaria. So I'll just put up directly here in the numbers that we have, and then we'll work on them. So then this task that we have, I would like to thank very much the possibility, and I will try to talk here more about the details in the background and the minute details. So I'd like first of all to thank all of our colleagues, coordinators, as I said in the initial presentation, everyone who works out on the edge, out on the front lines, our supporters, the researchers. Why? Because at the beginning, about in March, what was our fear? We're going to be implementing in Yanomami territory. I had experience in other areas of indigenous peoples in Brazil because for investigating outbreaks. But really, the Yanomami territory is different from everything when we talk about indigenous areas. So then when you reach the villages there, you need to walk an hour, have to go an hour and a half trip by a small plane. People who know there know how difficult it is to take food and medicines there for the professionals who are living in that area. So this was a concern the Ministry of Health had, but in talks with researchers, with their trust team, Dr. Maciel and teams, we were at ease. So then we started to do the implementation, and what did we notice initially? We noticed that the socio-demographic profile of the Yanomami was not the ideal for us to implement the tefloquine. But with public policy that we're doing there, it was very important to be, it is being very important. We were afraid that we would have negative reactions, so then we, to the presentation we did again. So several places here, we have colleagues who are here. So we would be able to implement in several municipalities, in 6 in the specific indigenous sanitation districts. Today we have here in this presentation that I did 2,176 today, but imagine today that with now we have about 2,300, 2,400 people who have done the use of tetrafenoquine. And so what's important, the A6PD test, the G6PD is a protective factor for us. We haven't noticed bad side effects. In our training, we do the AIDS, we have assistance from severe malaria in terms, we're not really having this problem of adverse reactions. You can ask us, and how do you know that really you're not having these negative reactions, adverse reactions? Because in Brazil we have CIEVs, we have the surveillance systems in the municipalities that are very sensitive to severe reactions, vaccines for medications. So we have constant contact with our technicians. We have another important point in Brazil, which are these municipal supporters. So today we have 31 supporters who are in the municipalities where we're doing our training and implementation. And we get in touch with them. They report to our malaria coordination. In other words, what can I say is that if we have countries that want to do the infliction of methylphenidate, they can use it, even having the adversities and difficulties. The G6PD test was very important for us to have this assurance. Here are analyses, very preliminary analyses that we've had in our coordination in terms of 2 or 3 technicians who download this CVAP database. For example, if a pregnant woman has used tefenoquine, if a child of less than 16 has been using tefenoquine. So in other words, we have been observing that in general, we are having success here. We're discussing internally here with our trust colleagues to make a publication, not necessarily, it won't necessarily be an article, but it may be a report or a bulletin reporting all of this. But in a very objective way, Sheila, we can say that today, after 8 months, we have had success. And it wasn't random success. It wasn't accidental success. We've always been based on scientific evidence. But now, of course, we have improved. I look at some colleagues here that today are people who go out into the field with us, the coordinators, the supporters, who in fact are trainers of this audience of professionals. So then, of course, at the beginning, we didn't have the numbers of analysts that we had, the recordings, and we didn't have enough tefenoquine. But today, in terms of inputs, we are very well supplied. And we hope that next year we'll have all the priority municipalities and expand to close out the states of Amapá and the extra Amazon region. And so then we also want to make a national meeting, in fact, a specific meeting for the extra Amazon states outside the Amazon, and do a one-day implementation, because it's very important for us to have tefenoquine used in so you do a positive test, you're eligible for all of Brazil. We want this to be the case for all of Brazil. If someone wants to discuss we're here available. But to finalize, I would say that after 8 months, we can say that it really was a success. We've been there, and Dr. Montoya in Colombia is also at the meeting with the countries in the Americas. Other colleagues have also discussed in other countries, and we are also available now. And the idea now is, I think, that the next step would be to think about a single report, but now more work and more evidence, right? Thank you very much. Thank you, Alex. I will break a bit with the protocol here, Roberta, and take advantage of these 2 little minutes we have here, because I think, Alex, you know what, Alex, I think it was interesting also as to what happened during this training. The malaria program relived, saw capacity building and training. We had a capacity building and diagnosis because it was not just tafenoquine, the main point. There was also an update as well, right, Alex, of a moment of solving doubts, to talk about severe malaria, talk about the importance of the use of the diagnostic test, the rapid diagnostic test. Yes, I think this is very important, what you just said, because in their training, where training happens in one day for about 50, 70 people, depending on the site. In the morning, we do the theoretical training of G6PD, talk about tafenoquine. And the same moment, then we do the practical part. In the afternoon, we normally have a doctor to go talk about severe malaria and non-severe malaria. We emphasize the importance of diagnosis. We work with strengthening the use of the rapid tests. When I got into malaria, they said, look, diagnose and treat, diagnose and treat, diagnose and treat. In other words, we are able to strengthen the malaria program as a whole. This is an important point, that when you go, your team leaves Brasilia with 2 or 3 technicians, your colleagues from the trust, the doctors that we have, their support from, in December they're going to be with us. So then it ends up that our colleagues out on the points have their doubts, because malaria seems like it's simple, but it's not. There are different types of treatments, so it's a very important point. Thank you very much, Alex. With this experience that you've given us, I will now pass the ball to Jonathan so that he can instigate a bit the discussion, to stimulate the discussion of this new panel here with regard to perspectives for expanding into other places for tafenoquine. Thank you very much. Thank you, Sheila. A good afternoon for everyone. I'll try to speak in Portuguese and not Portunhol. Now I would like to show the video that Roberta talked about, so that you can see directly how this implementation went for tafenoquine. So if we can look at the video. After that, I will start asking questions to the participants here, but I also want to invite anyone here who wishes to ask a question. Feel yourselves, feel free to ask any kind of question. Malaria, as we see this a lot in the northern region. There are subtitles.
Tradicional de 7 dias, e quando deu no 3º, 4º dia, ele chegou aqui para mim ictérico, falou que a urina estava cor de Coca-Cola, ou seja, ele estava hemolizando. Então, se eu tivesse o teste na unidade no dia que ele veio, evitaria muita coisa, né? Então, a gente ia saber que ele era baixa atividade e ele não ia hemolizar.
A Organização Mundial da Saúde, ela já recomenda que para o uso da primaquina, o teste de G6PD deva ser feito. Então hoje é possível que haja testes baratos, de fácil execução e com boa reprodutibilidade para serem usados no campo.
o objetivo principal da testagem de CSPD é a gente avaliar o nível de atividade desse paciente. Então, uma forma mais adequada da gente tratar os pacientes e, com isso, a gente diminuir principalmente as internações por quadros de hemólise, que são características muito apresentadas em pacientes que fazem uso de primaquina.
Ver a implementação de uma medicação que ela é dose única para o nosso principal plasmódio da região amazônica do Brasil, que é o plasmódio vivax, se torna fundamental. Fundamental porque a gente acaba tratando numa quantidade menor de tempo, né, diminuindo aí o tratamento de 7 dias para um tratamento com dose única. Então isso realmente é muito inovador quando a gente pensa numa população de tão difícil acesso que é a nossa região amazônica.
Bom, eu acompanho o estudo desde o início. Nós ficamos super felizes, porque realmente uma luz que veio e falou, olha, a gente vai poder melhorar isso, a gente vai ter realmente condições de tratar a malária com um medicamento muito melhor.
Então, quanto mais eu colocar o diagnóstico e o tratamento mais perto possível do usuário, eu vou conseguir que ele tenha um diagnóstico oportuno e que com esse diagnóstico eu consiga iniciar esse tratamento visando a quebra da cadeia de transmissão.
A população Yanomami é hoje a população indígena que mais está sujeita a esse aumento de carga de malária. O Brasil tomou uma decisão que eu considero uma decisão importante, arriscada, mas muito importante, ou seja, implementar drogas que tenham impacto naqueles que mais precisam.
Então não é só médico, a gente vai capacitar toda a rede, médicos, enfermeiros, bioquímicos, agentes, porque todos têm que estar sabendo, todos têm que acompanhar.
Foi a minha primeira vez usando o teste de SVSA, né? E eu achei ele bem prático, bem fácil de ser manuseado.
Há 30 anos atrás a gente tinha mais de 300 mil casos por ano. Hoje a gente tem na faixa de 130 mil, 140 mil. E a ideia é que não só com a tafenoquina, né, mas com todo esse apoio, essas capacitações, a gente consiga eliminar a malária no Brasil até 2035.
Bom, muito obrigado.
So thank you very much.
Eu quero começar com
I would like to
uma
start
pergunta para
with a question for Délio and Alexander. We wanted to have here someone from health areas who can talk about their experience and their perception of the people who are sick. So I'd like to ask if you have talked to people with patients with malaria and what they say. We have heard from the perception from the health people that it's very good perception in terms of. So I'd like to ask you, what are the patients, what people who have sick with malaria, what do you think of this treatment? What are the advantages and later the use of the device? Everybody thinks at the beginning that it's a device that's very difficult to use, a lot of steps, but I'd like to know what is the reality at the end of the day. Were they able to do this? Were they? Do they think it's a barrier or not? For example, or the procedure. I would like to know your perspective on that. Yes, thanks for the question. It's very important to talk about our reality there, close up. And I will give the question back to everybody. What do you prefer to take? 7 days of a medication with several pills, or 14 if you have a relapse or a single dose? To say this, it's the dream of every drug is to make it single dose, or for us to have a single dose drug. So then I had the opportunity to talk with some patients who participated in the first phase of implementation who had the cafenaquina. They got malaria farther down a year or two later, and it was in a space that when they had ended the implementation part, Portugalio spent some time without the study ended, so you go back to primaquine. And so then there's a time with people who are taking primaquine again. And so this patient specifically said, no, I want to take that single dose thing. So I didn't feel almost anything, because primaquine, if you take it several times during several days, it works well, but it also has side effects that are important, like gastrointestinal and so on. So they saw this. And on the other hand, the question then related to the test is at the beginning when we started to implement this and work with it, said, wow, it's another step, let's stick another finger. It was a concern of ours. Where they want to have their finger stuck again, since they're positive. And at the beginning, there really was. They said, oh, but wait a minute. Once again, when they noticed that the degree of safety ended up happening, not just for tafenoquine, but also for primaquine, they started to see that in the hospital, people started to come up, they took the primaquine without having had the test SPD during implementation. And it was this quick, the awareness came quickly that the SSPD test would bring more security, more safety, and more comfort for you to be able to choose the question either tafenoquine or primaquine. And the people could go home and we wouldn't have to worry so much that they might have a question of hemolysis, and then we would not be able to follow them up if they had a relapse or something. So just to add to Derek, just in fact the report we said, it comes about 6 states, mainly in the northern region. We can observe that the acceptance of the population is very good. The health professionals that we talk to all report that it's been a success. And when we have gone to the municipalities, before we start the training, we can note that people are kind of like looking at that. They're kind of suspicious. They think it's more work for them. At the end, we note that they catch on very quickly. They learn how to do the test very quickly. And then talking to the colleagues, then we go back to they are get so experienced that in 3 minutes you already have a result, because it's so practical to collect it in 2 minutes. The analysts already can give you a result, and so this was I don't even spend 3 minutes to have results of SPD and make the decision if you're going to take tafenoquine or not. So initially, people said, is Brazil going to be able to put in this test? Some professionals said, are they going to be able to do this? No, it's positive. So there's another question that our colleagues then have this question, taking out the doubt. So the supporters help us, they say, take advantage of your supporters and solve your doubts. But it's been a success. I can also add that the question was about the patient himself and using the test, but I can say, even talking about from the side of the point of view of the health professionals, that these doctors and nurses that you are deciding to take, see what medication you're going to use. In the beginning, there is a resistance. We come from Portugalio, from Manaus, where people, or other places, people were accustomed to, so people are so accustomed to German. So now it's kind of suspicious, especially when we talk about the possibility of a hemolysis. But there's also a risk, especially we have data, doses, and in an appropriate way. And so then when they note that also is having more guarantees than the professionals who are working, they quickly, the learning curve changes very quickly. And then to add the health service that the Secretary for Portugal was talking to Eliana, she talked about when this moment came, we didn't have any more tafenoquine, we didn't have SSPD, but it was, you were constantly, she was pressuring me, we'll be coming back to use this. They noticed the importance of this and the improvement in the organization of the service during the training, which was very good for them. Thank you. Now I'd like to ask a question to Ivor, and I know that the consortium is working in innovations to have a diagnosis that is more sensitive. In terms of Dr. Llanos talked yesterday about the need to do a diagnosis, an asymptomatic diagnosis. I don't know if you could comment on this during your experience or what you're working on now to have a diagnosis of more people, and in fact, if possible, people who are carrying these syndromes, these situations.
The question. So, as the part of the Vivax Serology Consortium, we've been working over the last almost 10 years to develop a test that can diagnose people at risk of relapse. And we now have a test that has an 85% sensitivity and specificity to detect people that will relapse over the next 6 months. And that is partly, and it will also detect asymptomatic carriers and even people who have very low densities in the spleens, mostly parasites in the spleens, and are really hard to detect otherwise in the bloodstream. So we have this test now that we can use for identifying who is infected and also who is likely to relapse. The question now is obviously what we're going to do with these tests, and what we're thinking what is possible to do with these tests is to actually go and mass screen people, find asymptomatic carriers, and not only find asymptomatic carriers with asymptomatic blood stage infections, but actually finding people with dormant liver stage infections. So we can go and target those people that will not just be infected right now, but that will relapse over the next few months. And we can do that in a way that we do not have to go and mass treat entire populations, in particular in areas where transmission is low and where maybe 10% of people have exposure over a year. We do not want to go and have to treat 100% of individuals and do a lot of treatments and a lot of G6PD tests. So I think we have a tool here that can be used in that way, and is actually starting to be used in this way. Cambodia has started to use it that way. Laos has started to use it that way. So there's a number of countries in Asia that have started to do that, of actually using this to control Vivax malaria, to eliminate Vivax malaria. What is obviously essential in using such a public health intervention in the community is to then have a drug. So we can answer part of Roberto's challenge about diagnostics, but what has to happen is no diagnostics is useful if there isn't a treatment afterwards and an action afterwards. And having a single dose treatment that you can use then to treat people in the community that you can diagnose, you say you are at risk of a relapse, we give you this one single dose of treatment and you will not relapse, then that is actually, in my opinion, a game changer. The combination of these serological diagnostics that detects risk of relapse and the single dose treatment. And I think this is a tool that we can take into an asymptomatic community setting and really accelerate malaria elimination.
Muito obrigado, Ivo. Eu quero falar agora, falando das inovações, passar a fazer uma pergunta para a Alice. Alice, não sei se você pode contar um pouco o projeto Curema, porque eu acho que também é uma inovação não só de uma estratégia, sino que também atinge a uma das populações mais ao risco de ter malária, como o Dr. Roberto falou ontem.
About yesterday, which is the gold mining, placer gold mining, and we know that these populations are very difficult for them to come seeking, but so we need to have an innovation and think outside of the box, as they say. So I don't know if you could maybe tell us a bit about the project and how you use that tefenoquine, how that can help so to get these populations to be free of malaria. Yes, thank you, Jonathan, for the question. This point is in a way is a follow-up, a logical follow-up to the answer from Eeyore, because we are implementing now currently a Purema project, which is, how we say, a second stage of the Malakichi program that Dr. Mato presented yesterday. We're working with people involved in gold mining and the Upper Guayanas region between Amapá, Rich Guyana, and Suriname. And this audience is very difficult to reach. They work in distant areas and remote areas in the Amazon region, and that also do activities that are informal or illegal. So you add another obstacle to the options. And so then this is a very movable region. We see this in our region. We know that similar phenomena happen in other areas, mining areas, such as Dr. Aniali mentioned before in the presentation on Roraima. So then we decided to find this audience, this public in areas where they're moving around, when they're going in and out of locations, the gold mining locations. But even so, even if we don't arrive into mining areas, these areas are distant, they are remote. So in this strategy, we have to work with community agents, with members of the community. And so these are people who sometimes don't have a formal health education. So this represents an interesting point for development of diagnosis and treatment in these areas. We don't know. We know that this is done routinely in several programs for control elimination of malaria, but the implementation is, for example, Tetteh is another challenge in that area, in those areas. So our project combines with intervention for malachite with Vivex, and then we don't know if these people, if they frequently present infections in the areas when they're in the mining areas. And so then this, these are sort of sometimes self-treating without notification, without diagnosis. So these are people who did not have an infection with Plasmodium vivex. They might have a risk of relapse, but they don't have any record of this event. So then we are proposing that focused treatment for asymptomatic people that we consider to be at risk of relapse. And so then the initial idea of the project was to use rapid serological tests that were not made available because of deadlines for development. So the selection is happening with immunological criteria. And we start out the study with primaquine, and now we are introducing tefenoquine in this action. So this is an action at the collective scale. It's a treatment of acute infections, and so we don't yet, unfortunately, have results to present. But we decided to test this strategy because we think that, first of all, we need to have innovation in how these people that don't have access to diagnosis, treatment, and notification can be reached by interventions that can act against the relapse in Vivex, and because we also think that tefenoquine can be a very interesting solution to an audience who have problems in adhering to treatment. And there is a tendency to interrupt the treatment as soon as symptoms get better. They tend to stop treatment as soon as they feel better. So we'll be happy to share the results next year and participate in the remainder of the discussion about the challenges in terms of implementation in these remote areas. Thank you very much. Now I'd like to, following Elo, I'd like to ask a question about the use of tefenoquine potentially in strategies for chemoprevention. We had Dr. Janos was presenting also the FLAME study, but I would like to know if someone has a general opinion about the potential use for tefenoquine in strategies for chemoprevention, always with the use of but tefenoquine today has to be given after a diagnosis. So I'd like to know if anyone has an opinion about the relevance, or if you think that also the use of tefenoquine can be a strategy for chemoprevention. Can this also be a good strategy to accelerate efforts to eliminate? To start off with, Jonathan, I think that this person of chemoprevention have to be very careful, because especially when we're talking about areas of borders, frontiers, mining areas that were said, that many of them, there's illegal activities in many of these areas, and we know that there's this question of self-medication. So then I think that we have to go along this framework. We have to be very careful when we move here. I'm not against efforts. I think we need to have more studies, and it has to be very much discussed. We really have to discuss these strategies. Sometimes demands come from the Ministry of Health asking, what about tafenoquine? People really are afraid of when they go out to an Amazon area in the Amazon, fishers or people who like ecotourism and people who come from other countries, they're afraid of becoming infected by Plasmodium. But I believe that you have to be very careful and talk about this.
Okay, prophylaxis is almost a bad word in Brazil. So I'm on the field, so I may speak more boldly. But tafenoquine has this use outside Brazil, 50 milligrams, if I'm not incorrect, per week. So we are doing 300 milligram use with tafenoquine. So what is the result of it after it had its first results? So how long does it protect that person as a prophylactic? So we know that this has an effect in the beginning, in the gametocytes, and if it sometimes will be in the bloodstream for 2 to 3 months. So what is the effect of it? So I guess we have to study a little bit more to know this. So to really eliminate malaria in the Amazon, we will need to have more creative measures. This is what we have been doing for control. So the state of Rondônia, as an example, we have a lot of transmission of Malaria, Porto Velho, Candeias, Guajará-Mirim, and another city. So what happened with the other cities? So I guess three or four parts of the states are free of it. So we deforested these areas, but in places where we have forests, we are not able to to eliminate malaria. So we have to think about vaccines or a more long prophylaxis. So yeah, we're going to make the medication remain for a longer time in the bloodstream. But maybe with tafenoquine we can do that, with the others not. But yeah, we have to think about it, and we have to study more about those next steps. Thank you very much. Now that you have talked about other discussions, so if you want to speak about other strategies and treatments, I would like to ask you, so we have tafenoquine today. It will remain here for a long period, but what we will have in the next few years in terms of new innovative treatments and elimination of malaria, so that we can get ready for the future. Because as Delio said, tafenoquine is not the silver bullet. Probably we will need other technologies. So could you tell us a bit about what comes for the future?
Because as we were talking about chemoprevention, one of the most promising new tools that MMV is currently developing is a long-acting injectable drug that would act as a chemoprevention drug to prevent reinfection. So what we are currently looking at is a drug, or a combination of drugs rather, that will protect patients for at least 3 months, if not 6 months. So we are hoping for the best, 6 months. In all the different population groups. So children, but also adults, hopefully pregnant women as well. So that's a very promising new combination that will involve atavacon and a new compound developed by MMV. And this is currently under development, and we are hoping to have that combination available in approximately 5 years. That will, of course, also reduce the risk of transmission, so that will have a broader impact, of course, than just the chemoprophylactic effect. So that's one of the really most promising new drug currently under development. There are also, as you know, lots of resistance happening, unfortunately, of course, in the GMS region, which is now spreading to Africa as well. So MMP is also putting lots of effort in developing new drug or new combination of drugs that will address the risk of resistance. So there are, for example, some triple ACT, so looking at the combination of different ACT that will address that resistance risk. And there are also, and so this one is currently under phase 3 clinical trials. So we are hoping to get that in approximately 2 years. So it's a combination of artemether, lumefantrine, and amodiaquine. And we also have very promising new drug under development. So that would be completely new drug that has never been used before. One is called ganaplacide and lumefantrine, and we are hoping then, based on that new combination, to have a triple combination. So it's going to be non-artemisinin component, so that will also address the risk of resistance that we are currently facing with artemisinin compound. And this is also under development, and we hope that this will be available within the next 4 to 5 years. So as you can see, lots of new tools that will help countries to address malaria elimination. And as I said, the long-acting injectable one is really very, very exciting and promising. So we are very much looking forward to get the result of that new drug, new combination.
Muito obrigado, muito prometedor, sem dúvida. Eu quero terminar com uma pergunta para o Dr. Montoya. Sabemos que a malária não tem fronteiras, e sabemos também que a malária aparece muito nessas fronteiras, não só do Brasil, mas fronteiras no Peru, na Colômbia. E também sabemos que as iniciativas regionais, tipo Rabreda, a IREM na Mesoamérica, podem ser uns mecanismos importantes para acelerar os esforços de eliminação. Você acha que agora não vemos um mecanismo como tal que está ou que pode ser feito para acelerar os esforços? Você acha que é preciso essa interação, esses mecanismos, essa comunicação com os países? Você acha que é importante ou você acha que tem que ser uma necessidade para poder acelerar?
It has got to be a necessity to increase the efforts for elimination. Well, I think that in general, for elimination, there are mechanisms for the countries to collaborate. And there are also the institutions that have an important role. And there are different mechanisms, particularly in the implementation of these radical cures. So I guess it's better to talk about improvement in interventions than radical cure, especially with the use of tefenoquine, because there are a lot of improvements to be made. For example, let's talk about mechanisms and implementation. For that, we have to talk about phases of implementation, stages of implementation. So we will have to do it by stage by stage. So the first element to consider is that the countries should recognize that there are different scenarios of implementation, and it's got to do with the population, the amount of services, complexity of intervention. And a new scenario, we are talking about expansion of diagnostics and treatment. So it's important to understand different stages and scenarios. of different solutions for radical solutions with tefenoquine, but I guess tefenoquine will continue to have an important role on radical cure. So we have to establish that primaquine continues to have an important role, and in this context, I think the mechanisms have got to do with already exist mechanisms that allow interaction between the countries. It has got to do with learning, with tools, regulations, norms. About this topic, there are a lot of possibilities for learning through cooperation and exchanging experiences. And I guess in that case, Brazil is fundamental. I guess in the past, experiences such as Rafael has made possible a very quick change. Also, the introduction of penicillin in the Amazon region. That's an example of cooperation among the countries and partnership between external institutions. So I guess this kind of approximation has to be supported, and we have a joint work with MB, PAHO, and also other cooperations that allow us to have other partners in the region. But the most important thing is to favor this interchange among the countries. So the experience that Brazil has with tefenoquine will be essential. Yes, certainly Brazil is influencing other countries, and well, because of time, I will give the word for the moderator to finish the symposium. Thank you for your presence.
And views on the introduction of those new tools. For me, it was really enlightening to hear Delio saying that, you know, it's the dream of any clinician to have a single dose cure, of course, and that will hopefully address the compliance of treatment that we are seeing with primaquine over 7 or 14 days. And really, I would like to congratulate the Ministry of Health of Brazil for, first of all, their very strong commitment, but also it's quite impressive to see that more than 2,000 patients have been treated with tefenoquine today, and that you are planning for the rest of the year and 2025 to really expand its use in all the different areas as per the SUS program. And we have heard from Ivo and from Alice the importance of the additional new tools that are not only the tools, but also the strategies, right? So Ivo explained the opportunities that we are now having with Serotat and how that could be used in the region. And Alice has really made a very strong case about the implementation of the COREMA project and how to target, how to reach population. But as Roberto mentioned, we are not only talking about new tools and innovation, we also especially talking about the use of different interventions, right? And this is why it's really important to look at the different potential scenarios according to every single country, epidemiological context, and not apply a sort of blanket approach to everyone. And that's really something that has to be done, of course, by the Minister of Health according to their context. And this is where the role of institutions like PAHO is really critical. And I was really pleased to hear from Roberto about, you know, that the importance of the collaboration and exchange of information, because this is really what we are trying to do today with this symposium, and how important it is to share the lessons learned across countries and the cooperation that is needed to make that happen. So with that, I would really like again to thank everyone, all the experts around the round table who make the effort today to come and present. and as well PAHO for their contribution and support. And then again, praise the NMCP for the also future introduction of pediatric tafenoquine, because we know that 40 to 50% of cases are in children. And so with that, I very much look forward to meeting with anyone after the symposium and to seeing you all. And I hope that you have a great end of the week and enjoy the rest of the conference. Thank you so much to everyone. Thank you.
Muito obrigado. Se alguém tem alguma pergunta.
If you'd like to make any questions, please you can. My name is Antônio Rafael da Silva from the University of Maranhão. I work with the diagnostics and treatment in other things. I thought it was very interesting, this point. I mean, the drug is important as a single dose, as it said there. It's cheap. I think it's cheap because it's public. It's going to the people. And it works with adherence, 7 days, 1 day. I think that the composition of chloroquine and primaquine, and my understanding, I guess, that made Vivax not to have resistance since the beginning. So this combination is very important, in my opinion. So my question is, what is the time of effect of this drug? I mean, one drug together with another. We're not talking about that because that is unquestionable, but the period of effect is fundamental, because when you combine mefloquina con artemisinin, so it has a small period of effect, and the other one is a longer period. So in some time, the patient will have only mefloquina in her bloodstream. So that's why we want to eliminate this resistance. So I just would like to know the time of action of the drug, and to make a final consideration. First, that I've never seen, or I've never had the opportunity to have access, that only one drug can eliminate a disease. I'd like you to talk about that, and I'd like you to talk about SUS. We have a unique health system, the health system, and only the Ministry of Health will not control or eliminate the disease. We have a great capillarity that might help with that. And the last observation is, I guess, the prevention of malaria would be to improve entomology in Brazil. Thank you. Thank you. Thank you, Professor Rafael. I'll try to answer partly. Tafenoquine is single dose, but the treatment is not with a medication. So you use chloroquine and tafenoquine. So despite it's synergic for the bloodstream, but its duration is very long. So we have the treatment dose of until 20 days. This is what we have. So it remains being eliminated. It persists for 2 to 3 months in the body, in the organism. So we don't exactly know what to do with it, this information. But on the first phase of implementation, we had a test in 2 cities. And then the Ministry of Health is implementing now inside a scaling up. And we are going to do it in different regions in partnership with the different cities. The cities are the ones that really carry and learn how to treat and do diagnosis and use the equipment, and then they get multiplied. So this is a first training, and those are the ones that continue having the service. So this was due to this capillarity we have in Brazil. So we all understand that not one drug doesn't solve all of the disease, and we need this combination of instruments and entomology, and maybe tefenoquine may affect this entomological part. So just complimenting Professor Rafael, thank you. Now, regarding, we won't have only tefenoquine. It's only one more tool that will allow us to get to the elimination. Of course, we have other points, such as diagnosis. So with the decrease in cases along the years, we will have to strengthen the diagnosis. So we need more sensitive techniques, such as a PCR, point of care, to get to those cases. And we will need to have a more sensitive surveillance. And so it involves diagnostics, professionals with data analysis. So I guess this is a challenge when we are in that phase between control and elimination. We will have to review the surveillance. And now regarding entomology, we really
de fortalecer cada vez mais a vigilância entomológica. Então, assim, a gente quer trabalhar com os dados entomológicos de forma que eles permitam que a gente tome decisões, os transforme em informações, tome decisões. Então, a gente está fortalecendo essa parte dos vetores malária, né, para ajudar tanto na utilização dos inseticidas de forma inteligente, né, dos mosquiteiros. Então, isso é algo realmente que a gente tem que fortalecer cada vez mais. A gente sabe dessa questão, dessa mudança que a gente chama dos sucanzeiros, funazeiros, que estão aposentando. Então, eles eram os nossos guardas, né, no passado. Tem uma parte deles que ainda trabalham hoje, mas a gente está passando esse bastão para os municípios. Eu acho que isso aí o senhor tem toda a razão. A gente tem que rever e fortalecer cada vez mais. E terminando, essa questão do SUS, eu acho que é muito bom esse ponto que o senhor colocou, como a gente...
As a health policy, so then if Brazil is able really to be successful, it's because of SUS. The 5,700 municipalities in the country, we have health units, we have a professional who works there with surveillance, and this is what makes this capillarity, is what allows us to be successful with all the problems. When you start talking about a country of continental dimensions, but SUS is really our strength. Thank you. So thank you, everyone. So let's have a photo of all the participants, and thank you for the time. And we'll have a group photo. Thank you very much. And his research target, because he's here, is in resistant parasites and the development of anti-malaria drugs. So our next speaker is our dear former student and now leader of a group, Ana Carolina Aguiar, who is, for those who don't know, she's a medalist from the Raidimi medal. And we have the 5 medalists. There's Ana Carolina, Adiemi, Erica, Denise, and Danielle, who's arriving here now. But so it's a great pleasure to have you all here. So then Ana Carolina has vast knowledge. She's been through several institutions like Johns Hopkins, School of Hygiene and Tropical Medicine, and the University of Liverpool. Her lines of research are based in development of candidate drugs for new anti-malaria drugs and elucidating mechanisms for existence of the parasites. As you can see, she, as the others, has extensive experience on the topic, and she's focusing more on experimental models for malaria and ex vivo studies, as well as isolates in terms of Plasmodium vivax, Plasmodium falciparex. She is part of the consortium which works to discover new antimalarial drugs. So please, Anna. And now, finally, last but certainly not least, I will call the other professor from our panel, Professor from DNA. He is an expert in antimalarial resistance. Currently, he is professor for parasitology at the University of Strasbourg. He has a major experience in malaria and has occupied different positions in field work on Pasteur, Eustrus in Africa and Southeast Asia. He is a member of the expert working group from WHO, and has had his career dedicated to fighting malaria. His work is focusing on molecular markers for falciparum resistant strains, and he's also been a significant contributor to advance on these topics, and he is my collaborator in France. So thank you, Didier. I will present in English.
To the organizers for the invitation, and especially to Maria de Fatima, and I'm very happy to be here. I'm going to talk about the molecular surveillance of drug resistance in Ecuador. Ecuador is in elimination, and I'm going to explain a little bit why we have to keep molecular surveillance until we reach elimination. So, as you know, well, malaria in Latin America is mostly concentrated in the Amazon and also in the Pacific coast of Colombia. But if we focus here, there is Ecuador between Colombia and Peru, and Ecuador has still some malaria cases. And if we see where malaria is still possible in Ecuador, we see that it's possible in the north of the coast, but also in the Amazon of Ecuador. How has malaria changed? You see, this figure is quite impressive. We used to have more than 100,000 cases in 2001, and this number went down all the way to 2014, where we had only 200 cases, 200 reported cases of malaria. This is thanks to the efforts of the ministry and the programs where like for example, PAMAFRO has been very, very efficient in Ecuador. The program was very big and very expanded through the country, and that's how Ecuador, since 2012, is considered in elimination. And Ecuador is one of the countries selected for the E2020 initiative and now the E2025 initiative. So it should be able to eliminate malaria before 2025. But what happened then is that if we focus, since 2015, the number of cases has been started increasing again, and now it is kind of irregular. So depending on the year, we see the number of cases going up and down. We have more or less between 1,000 and 2,000 cases each year. Most cases are Plasmodium vivax. However, we also have some Plasmodium falciparum. If we see where the cases are, they are near the borders. So we see in the north, this area near the border with Colombia is mostly Plasmodium falciparum, and near the border with Peru in the Amazon is mostly Plasmodium vivax. We have sometimes other outbreaks of falciparum further inland and of vivax too. But it's the province of Esmeraldas that is located in the north of the coast, the one that has more Plasmodium falciparum cases. We can see here how in the last years the number of falciparum cases in the north coast has remained between 100 to 100 cases, sometimes going more than that. And the number of cases of Plasmodium vivax has increased in the last years in the Amazon mainly. I think this is not working anymore. Okay. Okay, so what are the challenges for malaria elimination in Ecuador? Well, there are several challenges, but some of the challenges are, and these challenges have been identified by the Ministry of Health, like difficulties in the service network, like supplies, diagnostics, treatment, high human mobility, high difficult accessing the sites where there is malaria, violent situations in some areas, and indigenous territories, so there are some language barriers or cultural barriers. And in the case of Ecuador, we see this exemplified in, for example, in mining areas, especially in the north coast of Ecuador. So what we can see here is that the number of so this is the mining areas near the river, and you can see here a town, and it's quite common to have like malaria outbreaks in these areas, and of course the mining ponds then become excellent sites for breeding of mosquitoes. The other case is the communities in the Amazon. These are very isolated communities, so it's not easy to access them. You can see that there is like a big big like ponds where there are mosquito breeding sites. And in order to get to these communities that are close to the Peruvian border, you need to take an airplane. There is no other way to get there, so you need to take a small airplane, which is very expensive to do that. I'm going to focus, though, in the north coast of Ecuador, in the Esmeraldas province. And one of the main problems we have is we have quite a bit of outbreaks. So you see here in 2013 and in 2019-20, we had like important outbreaks of Plasmodium falciparum in Esmeraldas city. Same thing in San Lorenzo, which is near the Colombian border. This is how the number of cases show like monthly. And you can see the different outbreaks, even one that just happened 2023, 2024. So we do molecular surveillance for asymptomatic infections, for lineages circulating, and also for the surveillance of the drug resistant. And I'm going to focus more on the last two. If we look at the anti-malarial treatment in Ecuador, there haven't been that many changes in the last 25 years as compared to Colombia, for example. Ecuador has used chloroquine since the 50s all the way to the years 2006. That was the main treatment against Plasmodium falciparum. And only recently we started using artesunate or coartem. So we look at the different drug-resistant genes and at the mutations in them. The main methods we use is like more classical molecular biology methods, like looking at microsatellites, Sanger sequencing of drug-resistant genes, and now we are also doing more genomics using amplicon sequencing and whole genome sequencing with the help of collaboration at the Harvard School of Public Health and at the Broad Institute. And we compare between Ecuadorian parasites and previously sequenced Plasmodium falciparum in the region to track the movement and the potential entrance of new alleles. So between 2013 and 2016, that's where we started our work, and we've seen that so most parasites are clonal. So there is no complexity of infection in Ecuador. It's only one. But we see that the clones and the different parasites are very well defined. We see low diversity. And in this case, we saw that, for example, this lineage marked in red was present in the north coast of Peru at the end of the 20th century, and this parasite was also present in Colombia. This clone has been present for like 20 years, so it's a very common clone. When we characterize the drug resistance mutations in these parasites, we see that most parasites have mutations in PF-CRT and PF-MDR1. So the vast majority of them have these genotypes of PF-CRT and have 2 mutations in MDR1, so in 2 different positions. However, the wild-type parasites are dominant for PF-DHFR, PF-DHPS, and PF-K13. And what we see is that so the drug-resistant genes, they look very homogeneous across all the parasites in Ecuador, and that this is consistent with the history of antimalarial treatment. And the conserved mutations appear to be quite independent from the genetic lineage. So the mutations are common for all the parasites, and we see that the selection in these genes appear to be constant for Ecuador, which is quite different to what has been seen in Colombia. In Colombia, we see a lot more mutations in the different genes. However, when we started studying the population structure between 2019 and 2020, we see that a new lineage of parasites appear, and we see that in an outbreak that happened in Esmeralda City here. In green are the new parasites. We still see the lineage that we marked in red, but this new lineage, we tried to identify where it was coming from, and it appeared that in 2012 these parasites were already present in the north of Colombia. Doing whole genome sequencing, we found that these parasites were not very closely related to the previously characterized parasites, and they were reported in 2016 in Colombia again. So when we looked at the drug resistance markers, we found that the dominant parasites have a double mutation in PF-CRT, a triple mutation in PF-MDR1, and a double mutation in PF-DHFR. However, no mutations in PF-DHPS or in PF-K13. So we are seeing that there is an increase in drug resistance mutations, which could mean a change in resistant phenotypes. We don't know that for sure, but when we compare for PFCRT, we see how the change between 2013 and to 15 and 19 to 21 is completely, there is a big change in PFCRT, PFDHFR, and PFMDR1. So the main parasites have completely changed. What is driving this change? It's mostly the composition, the genetic composition and the drug-resistant markers are being driven basically because of different outbreaks. And if we see, for example, the first outbreak in 2013, so it was the red clone with a small number of mutations, and the second outbreak is here, the green clone, with a group of parasites that are quite unrelated to the previous ones, but with a lot more mutations. So we recently looked at a new outbreak that happened in the north coast of Ecuador, and we see that this comes from another lineage that is different to the previous two. So here is the new lineage. We don't know where this lineage is coming from, but we could assume that maybe it's again migration from Colombia. And again, when we looked at the different outbreaks in the north area of in the north coast of Ecuador in this county, here are the different outbreaks, and we see that we see a switch in lineages and a switch also in drug-resistant parasites. So here we had a small number of mutations. Then we saw new parasites entering with new mutations in PFCRT, PFDHFR, and PFMDR1. And in this last outbreak that just happened this year, we see mutations in PFDHFR, but different mutations in PFDHFR, but the same in PFCRT. And we see a new mutation that never was reported in Ecuador, that is the mutation in PHDHPS. So as you can see, it's very hard to predict what is going on. So we think there is a lot of migration between Ecuador and Colombia, and here are the different routes that may be going on, that may be happening. So there is the maritime route, there is the road route, and there are other small routes, and a lot of these routes are illegal, and a lot of people are crossing between the two countries, and they are carrying new parasites. So even if Ecuador is close to elimination, these new outbreaks that sometimes come with migration are making it difficult to eliminate. So in summary, Plasmodium falciparum in Ecuador are mainly clonal, are closely related to the other Pacific coast parasites, for example, from Colombia. However, low prevalence and unrelated clones can cause important outbreaks in eliminating areas. And these outbreaks also can drive very drastic changes in drug-resistant patterns in the elimination setting. So this underlines why it is important to do molecular surveillance and keep molecular surveillance of drug resistance in the elimination settings. And finally, of course, I think that neighboring countries need to work together in malaria elimination. It's not like there is a border and we cannot say because of the border we can just eliminate in one side and not in the other. We have to work together, and of course this implies politicians to get together and work together towards this result. Well, and I just want to thank everyone who has participated in this research, and at our center, but also all our collaborations, the Ministry of Health, and PAHO has had also an important role in this since we began in 2013. Thank you.
Thank you, Fabian, for the nice presentation and to be on time, okay? Thank you. Anne, por favor.
Então, boa tarde a todos.
Good afternoon, everyone. I'd like to thank you for the organizing committee to be here. It's an honor to be here. Thank you, Fatima and Mariano, for the presentation, kind presentation. Today, I will present to you a bit of what we have been developing in the laboratory. My title is Mitigating the Generation of Drug-Resistant Parasites through the Discovery of New Classes of Antimalarials. I declare not to have any conflicts of interest in this presentation, and so we begin with a very relevant subject: resistance to drugs, different microorganisms. This has been, especially in the last few years, a race against time, and the scenario with malaria is not different. And we know a lot about the resistance to bind the parasites to this drug and derivatives of artemisinin and partner antimalarials. So that's why we need to find new classes of antimalarials. But we need to do some things differently from what has been done in the last few years, and from then on, we need key points to find antimalarials so that they can combat these parasites. So we have to take a look at points that are a priority. So I would like to talk about these specific topics during this presentation. So it's important that these classes act not only with a target on the cycle of the parasite. We know that we have medicines, but we have to take a look at different stages on the life of the parasite. We need antimalarials that act by new molecular levels, and we have to apply it to experiments to understand if these antimalarials will survive, will surpass these obstacles, these barriers. So sometimes the resistance comes in a small period. So this is the barrier to develop antimalarials that have these that can overcome these battles, these barriers. So in the lab we have pipelines of experiments that we make. So this is the first one. We have a panel of multi-resistant parasites. We have been doing this for a lot of years. We have pattern standardized strains, and they carry the resistance that we can see on the field. So we have to fight this. Another important thing is what we call molecule of resistance. So we challenge a cultivation with the antimalarial that we want to test. So what would be the molecule of the parasite that is circulating in the patient? So if we have resistance in vitro, and that means that if we have this in a practical way, then we can see if we have resistance. So when we get these resistant strains in laboratory, we do the sequencing of the genome of this parasite to find mutation points that might tell us about mechanisms of resistance and mechanisms of new compounds. And a very important topic we have been working on is to understand the the resistance on the field. So I work at the lab, but I cannot develop a preclinical medication without testing it in circulants. So I have a strain in the lab, but it doesn't mean that it's going to behave the same way though in the circulants. So I'm going to talk about this topic, what we have been doing on the field, and due to the wonderful partnership between Carolina Bioni and Delio, and it began in collaboration with the group of Professor Rafael Guido and with me at USP. So this is a project financed together with the Malaria Venturi. And what we do, we are in partnership with MMV. We test the compounds preclinically and clinically. So this is an interest with the pharmaceutical industries and universities. We have tested molecules of Professor Daniel and others. And so if you would like to use our project to do the same studies, feel free. So what we've been doing in the lab is going to work on the field. Well, this is a question, and it's a goal for the development of a new drug. And so there is a technician that helps me. So we collect the blood of the patient, falciparum and vivax, and we see what is going to happen. And so we can see if what we did in the lab is going to continue working. The other point is, how can we test vivax if we do not cultivate it? So it's important to have a compound that is important to tackle both species so that we can simplify treatment. So we have a compound called DSM-265. It's not in stage of development anymore. This compound inhibits an enzyme which is ODH, and it's important. It works with a parasite. This was a study published at Lancet in 2018. What they realized is that in this left graph, each curve represents one patient after treatment, and it's from Plasmodium falciparum, infected clients. So we had an increase in the parasitemy. So in your left graph, we had a compound on Vivax, but it didn't work. So after some time, we tested this compound on a field. So it worked for the isolated compounds, but not on the field. So this is a follow-up. It's an interesting target we have studied. Researchers on the group worked with other series, and we tested those two compounds. They are from the same series, and now we have compatible compounds that inhibit Plasmodium vivax and falciparum with the same potency. And this will show you that every point represents an anti-malarial that we have tested. So we have tested lots of different anti-malarials. So it's not infrequent that one compound works with Vivax, but the other doesn't. But the same doesn't work with falciparum. So this is another question that we have been having. What we have observed is that the profile of resistance of our isolates that circulate in Porto Velho of falciparum, they are similar to what we have studied in the lab. So, but sometimes for some compounds, now we are gathering those data to understand what happens, even if it happens against falciparum, which has a similar background with our circulants. On the field, I can see that we can see that it doesn't work with Plasmodium falciparum. And so all of these experiments are very important in a process of validation of anti-malarials. So here I won't have time to talk about all of them. I wanted to talk about this one because it's an important example. But we have been studying other kinds of compounds, and I brought to you some of the publications. And now I will go to a second part, which is to understand what compounds work in different stages on the life of the parasite. And just to tell you a bit of the story, I brought two similar studies with different compounds. And now the first is a process of pyrimidine, azepine, which was a work that we made in collaboration with Roberto Bargieri of USP. So now it's the results of a PhD work. And another one is Yasmin Annunciato's work, and she studied a new kind of compound, which is quinolones. So these compounds, pyrimidine came from NIH, from a library, and the four quinolones came from a collaboration with USP, and a person from the university synthesized that substance. So we wanted to understand the life cycle of the parasite. So I won't go into detail of, I will tell you that they worked with the sexual stages, not sexual stages, and they worked with the isolates and the food compounds. But we wanted to understand if they worked for transmission blocking agents, and we tested Yasmin's compound, and he developed a model that is very used by us, and he analyzes these blocks. He created a transgenic parasite that expresses an enzyme, and he can know by the section if that compound inhibited lufineto. And this is a preliminary study to understand if they could be blocking agents. And here is Yasmin's and the other person's study. The pyrimidine azepine was a better blocker than the other one. And in collaboration with Maisa, I'm showing these works in a more summarized way. We decided to validate. So are they going to work in a model of artificial fitting? So what we did with Maisa was to collect blood infected with Vivax, and we fed the mosquitoes with it. So I brought the results from one of the studies. So we evaluate the amount of oocystos in the control group compared with treatment group. And so the transmission was blocked. Here is stomach, super-infected stomach, and the other one not. This is in the case of 4 quinolones, and she went forward, and in cooperation with the University of Lisboa, she evaluated it in vivo. So she got a rat and she infected it, and she wanted to know if after the metabolism the transmission would continue to be blocked. So we saw that oocysts decreased, and there was the blocking of the transmission. And so the stages for the 4 quinolones, we also analyzed that the blocking with hepatic stages, and also the compound one is 4 quinolones. She was active. It was not toxic for hepatic disease, hepatic cells, showing that it works in the 4 stages of life of the parasite. And so we need new molecular levels. And I continue with this, with Juliana's compound. And there are different ways to understand what is the molecular level of a compound. For example, we can do a metabolomic. We can express an enzyme. In the lab, we have gathered the phenotypical assays and in vitro study versus the evaluation of the total genome. So we create resistant parasites And then we try to understand what mutations we can find. This can bring me some questions. So we can have a mutation which indicates a target, or it can indicate a mechanism of indication, so of resistance. The two questions are preliminary, so if you know that about a compound, a medication that you are applying, so it puts us ahead in understanding how the mechanism of resistance was created. So we have the susceptible strains, and here we have the bottles of pressure to create this pharmaceutical. And so we can see a mutation where at the level of the molecular level. So there was a substitution in the position 259, indicating to us that probably the target of the compound class studied could be cytochrome B1, and to understand a little bit about it, we put an extract, mitochondrial extract, and we could see that, yes, they inhibited complex BC1 also in this enzymatic assay. So these were recent studies, recent data. There are a lot of things that I couldn't talk about here. So at last, what is the take-home message? The new classes of antimalarials are urgently needed, considering the resistance derived from artesunate, and compounds should act against different stages of the parasite's life cycle. If this class that you're studying in your lab has a high propensity to generate resistance in vitro, and you couldn't finish the checklist of this pipeline, it is a scientific information, but maybe these are compounds that shouldn't be prioritized during the formation of pharmaceuticals. And we saw it's essential that we test these new isolates, because we can understand if it helps with Plasmodium vivax, and we can understand if what we did in the labs will work, and then we can continue with the studies on the field. So I would like to thank the students and everybody that is very much involved in this project, and also all of the collaborators and sponsors. Thank you very much.
To meet colleagues and friends, and the opportunity to present what I'm doing in my lab about antimalarial drug resistance and a special non-conventional phenotype of resistance, which is dormant parasite in Plasmodium falciparum. Okay, so I have no conflict of interest. Yes. Maybe it will last more than 20 minutes. Okay. Okay, so just to give the context, I would like to remind that antimalarial drugs are key actor for malaria control and maybe elimination. So we use it as in chemoprevention. So I don't know if in South America there is no. But in Africa, okay. Yeah. Okay. Thank you. Okay, so in Africa, there is a strategy using the SP, which is used in prevention in pregnant movement or in infant. And there is also amodiaquine with SP for seasonal malaria chemoprevention in children. Drugs also are used to manage malaria cases, especially now the ACT, which is recommended by WHO. But there is also other strategy like MDA or focus screening and treatment or mass screening and treatment, and we use the drug. So the mode of action of the drug is very important, and most of these drugs, which are amino alcohol or amino-4-quinoline or folate, or antifolate, target the mature stage, the mature blood stage. So the primaquine are specifically active on the gametocyte. But the most important thing is that artemisinin have a large range of action, and especially its act on ring stage, which makes that artemisinin is a very potent drug with a huge decrease of the biomass after the first dose. We have to keep in mind that artemisinin, to be active, they need to have the cleavage of the endoperoxide bridge, and this step can occur when hemoglobin is degraded and iron ferrous is act on the artemisinin. Okay, so the main challenge that we have and we have to face, and it's a permanent threat because we always see the emergence of drug-resistant parasite after the introduction of the drug. So we saw the resistant parasite to quinine, chloroquine, sulfadoxine, pyrimethamine, and more recently to artemisinin, and in Southeast Asia to mefloquine and piperaquine. The only thing that I can add is that what we observe is that the time delay between the first introduction of the drugs and the first observation of the resistant parasite is shorter and shorter. And the first cases of drug-resistant parasite occur only in low transmission area, like Southeast Asia or South America. Okay, so the mechanisms of resistance, there is a general consensus about the genetic basis of antimalarial drug resistance, which is the mutation or amplification in gene which encode the parasite, the drug's parasite target. This is the case for sulfadoxine, which the mutation in DHPS, pyrimethamine with mutation in DHFR, or atovacone mutation in the cytochrome B. Or the second thing is that the mutation or amplification will affect a pump that affect the concentration of the drug into the parasite. So the pump will flow away the drugs. And this is the case for chloroquine, amodiaquine, which is the mutation. We have a mutation in PF30 and PFNMPR1. For mefloquine, I think that there is only resistant parasite in Southeast Asia. It's based on the amplification of the MDR1. And for quinine, there is some candidate, but I don't want to give more information about it. And for artemisinin, so what we observe in Southeast Asia is that the artemisinin resistance is linked to mutation in a gene which is the PF-Kelch13 gene, and the phenotype that we observe is a temporary cell growth arrest. So I would like to focus my presentation about that. There is different terms. It's quite difficult to understand that The growth arrest could be named dormancy, could be named quiescence, could be named persister cell, etc., etc. But the definition is that it's when the growth and the development is temporarily arrested. What we know is that this phenotype occurs and is closely associated with some change in the environmental condition. And the classical definition is quiescence is a predictive cell growth arrest. And dormancy, it's a consequential cell growth arrest. It means the change, the stress of the cell. We know also that this cell growth arrest is a common mechanism to survive, and it exists in almost all organisms, in vegetal, mammalian cell, insect, bacteria, etc., and also in parasites. And this state is an alternative between cell proliferation or differentiation and cell death. So we have some example in apicomplexan parasite, and the phenotype that we observe, it's a recrudescent phenotype. This is the case for Toxoplasma gondii, and we have two forms of parasite, which is the tachyzoid and bradyzoid, and we know that the bradyzoid is the dormant form, and it's regulated by the eukaryotic initiation factor 2 alpha, which is the phosphorylation of this factor. And the phosphorylation usually occurs when the cell is stressed. We have also, and we talk a lot about that, P. vivax and the liver stage. So we have the hypnozoite, and we know that the sporozoite, when infected hepatocyte, there is two possibilities. One is to develop into schizoid, and the second is to stay dormant in hypnozoite. For Plasmodium falciparum, it has been recently identified the cell growth arrest phenotype in a ring stage. So we already know for falciparum that there is dormant stage, which is the sporozoite, but it was the first time that it was a blood stage. The dormancy was described in the blood stage. This was found, the first observation was done by Nakazawa, which showed that if in vitro, if some parasite is exposed to SP, he was able to detect a surviving population without any genetic change. Since then, the most famous example is with artemisinin, and there were a lot of paper and reports showing this dormant phenotype. So this is an example here where we have dormant parasite here. So it's quite difficult to distinguish dormant and pycnotic parasite with dead parasite. But the main difference is about the morphology of the cytoplasm, which is still blue. Okay, so I would like to speak about the ring stage, which is the very important stage where the parasites have to decide. And what we know is that the ring stage are able to stop the growth. There is some evidence with, for example, the isoleucine deprivation, because the parasite needs this amino acid. If there is no isoleucine in the culture medium, the ring stage can stay dormant. And if you had isoleucine, the ring stage will resume their growth. This is the same thing with the high or low temperature. The ring stage can enter into a dormancy state. So there was a lot of paper showing that the transcriptome of this rich dormant ring stage show that there is a shutdown of the very important metabolic function, and there is expression of different specific pathway. So this phenotype, it's general strategy used by Plasmodium falciparum ring stage to scope the environment stress, and this is independent of the genomic modification or mutation. About the drug resistance and artemisinin resistance, I mean the gross RS and artemisinin resistance. So what we observe is that we have two clinical phenotypes. The first one is the delay of the parasite clearance, which has been shown in Southeast Asia, and this is the definition of artemisinin resistance. And what we know is that the ring stage is able to resist because there is a decrease of the degradation of hemoglobin, so less production of iron ferrous and less activation of artemisinin. And this is the rationale of the mode of action of the K13 mutant parasite. And the second phenotype is the recrudescence. And there is a lot of reports showing that there is a recovery of the ring stage for up to several weeks after a single pulse. So the classic name of this phenotype is the sleeping beauty. So the question that we try to answer in my lab, it's to see if the gross RS phenotype, which is observed after drug exposure, is caused by the drug itself, or it's due to signal release in the environment. So we start to do a very simple experiment, which was to produce a supernatant, a stress supernatant, by using a classical laboratory strain, which is the NF54. So we expose this culture to 200 nanomolar chloroquine for 20 hours. We collect the supernatant and we use it and we expose 3 different strains. So the PL1, PL2, which is a strain from this Cambodian strain, which are K13 mutant, and PL3, which is a wild type. So we expose for 24 hours with this supernatant, or we expose the same as control with RPMI. So, and we make slide at 24 hours and at 48 hours. And what we observe is that, I don't know if you can see, but okay. So with the RPMI, we have a normal growth of the parasite, but for the parasite exposed to the stress supernatant, we observe a delay of growth and an increase of the proportion of the ring stage at 24 hours. So the second question that was to know if this ring, which stop the growth, they are able to resist to DHA. So we plan another experiment. So we produce the same supernatant and we produce some control, which was the NF54 non-exposed to chloroquine or RPMI, or infected, non-infected red blood cell exposed to chloroquine. And we did the RSA, so the classical in vitro test to see the level of the resistance of the parasite. So we expose 3 different strains 30 minutes to the supernatant or the control, and we did the RSA. And what we observe is that, so this is the result, there is no there is a similar proportion of viable parasite for the parasites which were pre-treated with the control. But for the parasite exposed to the supernatant, the stress supernatant, we have a twofold higher survival of the parasite, which we think that's the hypothesis was that there is a release of a signal in the supernatant of the stress parasite, which make that the ring stage enter into a dormant state. So to go forward, so the next question was, if we dilute the supernatant, do we have still the signal, and the signal is it able to lead to the dormancy of the ring stage? And what we observe is that with the dilution, twofold dilution, fourfold dilution, there were there were no effects. So it seems that there is a threshold, the signal has a threshold, and at this threshold, the ring stage are able to sense this signal and enter into dormancy. The next experiment was to filtrate the supernatant and to define what is the molecular range of the molecule of the signal. And what we observe is that the signal, it's a very small molecule, because at the most stringent filter, that means that less than 3 kD, there is still the effect of the supernatant of the ring stage. And the last experiment that we did, it's to to see if we kill the mature stage by DHA, if there is the same signal which make that the ring stage will enter into dormancy. So we use a system which is a transwell system and some control, but the most important is the blue one, trophozoite, and the ring stage in the upper well. And what we observe is that in that case, we have an increase of the survival of parasite. That means that when people are treated, they are infected by mature stage and ring stage. Maybe DHA, artemisinin, will kill the mature stage, which maybe will release a signal which makes that the ring stage will enter into a dormant stage. Okay, so the next step, and I don't have the answer now, is that to analyze this supernatant and try to define what is this signal. I think I have some time just to finish. 2 minutes, okay. So just to show that the second thing that we did, we did a single cell analysis of the ring stage, the 0 to 3 hour ring stage. So we did a simple single cell RNA-seq. And what we observe is a ring stage 0 to 3 hour post-invasion. And what we observe is that we found 9 different subpopulations. So that means that the ring stage, they are in different states, even if they are the same age. But the most important thing that we observe is that we did that on the wild type 3D7 and the mutant K13 mutant C550Y 3D7, and as you can see here, is that we have additional subpopulation in the mutant parasite. And the question now is that is this subpopulation is the parasite which are able to survive to the pulse of DHA. And the second thing that we observe is that there was here another subpopulation in orange, and when the parasite is exposed to the supernatant that I show, there is a twofold increase of this population. So the hypothesis is that this subpopulation is the dormant parasite. So just to conclude, This is a summary of the result, and the hypothesis that we have is that in normal conditions, so the ring stage will progress into trophozoite and schizoid, and under a stress like artemisinin, what you observe is that we have, for the ring stage, if they progress into a trophozoite, there is an extension of the ring stage phase, which makes that the ring will be able to survive to the DHA artemisinin pulse. And we have also the production of the dormant parasite, which is the subpopulation that I show in orange. And this subpopulation, I think it's responsible of the recrudescence phenotype. So this is the work that we are planning to do. The first is to characterize this subpopulation linked to the K13 mutant parasite, and try to find molecules that are able to kill this parasite. The second thing is that we want to understand what is the key factor that regulates the commitment of the ring stage. And the last thing is to define the signal, the molecule that which mediates the signal in the supernatant. It's okay. Thank you very much.
Obrigada, merci, Didier. Eu vou pedir agora o Mariano para conduzir a discussão.
Opa, agora tá. Então, eu queria agradecer o convite também da comissão organizadora. É uma honra estar aqui e muito feliz, entendeu? Depois de tanto tempo que eu trabalhei com essa parte de resistência e
with this resistance topic. Since the beginning, when the cultivation of malaria began and all of the molecular aspects of malaria, I had the pleasure to begin this work with FIOCRUZ in Fatima's lab. And before we begin with the questions, we saw three very interesting presentations. One that approached a feud, what is going on in South America, and how do we still have the separation between the kind of resistance we have in Brazil and also in the Pacific. How this is so different until now, and time would separate the groups. We don't know if it was because of the Andes or really the kind of treatment was different throughout these years. And after, there was something that remained the same, but it's quite different. So this was the beginning that made these two groups have two parasites on a certain way. The second presentation is a more basic one that shows us how we can predict the resistance. We have tools now that can predict, and unfortunately we don't have a cultivation of Vivex, and that would be wonderful for us to understand, especially in Latin America, how Vivex is the most important one to understand what is going on with this. And the third presentation is a presentation that shows how the microenvironment influences a parasite. What is the epigenetics? We understand very little about it, of what is going on with the parasite. We know a little about how is the ventilation inside the parasite, how this epigenetic regulation happens, and it always happens. I saw a lot of times inside the cultivation, why can't we have more than 10% of parasitemia? We have masses, so why don't they not reinvade? Why is there, if we have a new mean, there is something that regulates infected blood cells. So they are so important that it's not the genome of the parasite, but we have to look for the epigenome of the parasite so that we can understand better all of this. So I would like to open up for questions now. Please identify yourselves. We don't know. We know everybody, but I am Renato Carvalho of FIOCRUZ. I have two quick questions. One for Ana Caroline. It's extraordinary what you've been doing. You've been working on it for a long time. It's quite spectacular. One question that I have for you was, what's the next step? Why doesn't it advance more? You have shown different compounds that you have for this activity. They are very good. Maybe some of them are more potent and they act with different species in different stages. It's already well characterized. So what is there, what is missing for this molecule to advance? This is much more complicated for this new stage. So what is missing for them to get to a clinical trial?
Impressive what you showed. If this kind of study, it's very hard to study epinozoites in Plasmodium vivax. They are also a dormant stage. Do you think this kind of knowledge that can be acquired with the dormancy of ring stage can be applied to find new potent drugs for hypnozoites as well?
Obrigada, Leo, por sua pergunta.
Thank you, Leo, for your presentation. Excellent for your question. Excellent question. So we have these compounds that we develop, contribute to the development of them, and so we don't have any obstacles for the development of these pharmaceuticals, a financial or collaboration obstacle. All of the essays are very well defined, and that is made. So if a molecule like this does not advance, it's really because in the process of development there was a no-go, so it's not appropriate for it, and it doesn't go forward. So in Brazil, what has improved the scenario? I've been working with pharmaceuticals since my master's degree 12 years ago. And so I will use my experience as an example. I have one molecule that is in a more advanced way. And we have a barrier in the definition of the pharmacokinetics of that drug. And so these studies are very expensive. We need financing. And if we don't have great agencies behind, we stop there. So this is the great difficulty.
Waiting for the translation, but you speak in English.
Yeah. No, I just like, because we have a big problem with treating Plasmodium vivax hypnozoites, the dormant forms of P. vivax. And it's very hard to study the biology of hypnozoites. So I'm just wondering if you can use this system that's, let's say, easier to manipulate and to study. If you get insights from these ring stages, studies the dormancy of the ring stage, to apply also for the hypnozoites biology.
So you mean to use the same methodology to study the ring stage, the dormant ring stage?
Yeah, more or less, but to get inference of the mechanism of dormancy to apply to hypnozoites.
Yeah. It's what you are trying to, you are trying to do. So the most, I think the most, and it's easier with falciparum, it's to use single cell sequencing. Because with that, we can define a biomarker of this subpopulation. After that, we can use fish and probes to see this dormant parasite by microscopy. We can sort this parasite by using flow fish. So the sorting based on the fluorescence of this subpopulation. The main disadvantage is that the parasite will be killed, and what we want is live parasite, because the final objective is to test drug and see which drugs are able to kill this subpopulation. So it's the work that I have to do in the following years on this, let's say, K13 subpopulation, K13 dependent subpopulation, but also the other independent subpopulation, which lead to a recrudescence phenotype. And this is, I think, this subpopulation which is the most challenging for malaria elimination, because I think that the current anti-malaria that we have doesn't work on this subpopulation. And so to be able to test new molecule on this subpopulation, this state, ring stage state, it's very important, I think.
Hi, Joel Vega Rodriguez, NIAID. Congratulations, great presentations. My question is, if I can, one for Carol and one for Didier. The population, the resistant population that you obtain with your lead drug that targets the cytochrome BC1, do you know if those parasites are transmissible by mosquitoes, considering the information that we know from atovaquone resistance?
Thank you for your question, really nice question. We never tried to use the same parasite to infect the literature that is able to not transmit more the parasite to the mosquito, but you never test our own parasite.
Okay, thank you. And for Didier, my question is for your assays. What specific stage that you treat with the drug, if you treat a different stage other than the ring with your drug and collect that supernatant, let's say trough or Schison, can you still get the same phenomenon when you use that conditioned media to create the resistance on the next population? And on the next population, if you try rings or trough or Schison, do you create the resistance as well?
No. No, if I understand well, your question is that
is this stage specific?
Epigenetic regulation of the stage. So no, it's one of the characteristics of the artemisinin-resistant parasite. It's when you do the RSA, the ring stage survival assay. So you expose ring stage to DHA for 6 hours, and after 72 hours, you see the proportion, you see the survival parasite. Okay, and if you take this parasite, which has survived to the pulse, and you redo the RSA, you will not have 100% of survival. We will have the same proportion that we have with the first pulse.
But if I understood correctly, your first experiment was with chloroquine. You create a stress, and you take that supernatant, and you treat parasite. My question is that stage specific? If you treat a trophozoite or a Schison, do you create the same response that will affect the other population?
It's what I show with the Transwell experiment. Yes. So we use the same parasite, but at different stage. So in the upper well, it was the mature stage, and the lower well, the ring stage. So when we put the artemisinin, the DHA, we kill the trophozoite, and the medium is shared by the two culture. So it was one way to show that maybe the mature stage release a signal which is sensed by the ring stage, and which could lead to the cell growth arrest.
Thank you.
Okay, I think that I have there is one question, and then I will ask for one question. You have a question too? No, my question is like this. I mean, it's very interesting that even in the field, or if you induce also drug resistance, you have the resistant parasite, even if you have like these mutations, 1 or 2, 3 mutations, the IC50s, they vary. They can be very resistant, even with the same point mutation. So the question is, it's an accumulation of other mutations in the genome, or it's an epigenetic effect of drug resistance?
I think that can be both. Or, for example, you can have the same SNP responsible for that resistance, but you can have different SNPs in different regions that can also regulate that, or can be something related with epigenetics as well.
Yeah, so in our experience, so we've done also in vitro studies of some of these mutations, and some genes are kind of predictable, like PFCRT. You see a clear increase in the IC50 with 1 mutation, and sometimes with 2 mutations you see even a bigger increase. But for example, PFMDR1 we've tried different drugs and we don't see a phenotypic effect with those mutations. However, we did a collaboration with a group with Petra's Rohrback group in McGill, and the mutation that is very common in Ecuador and in South America in MDR1 is the 1042 mutation, and we could see a phenotypic effect. There is no, so the drug cannot enter so some compounds cannot enter the parasite when that mutation is present. However, we don't see an increase in IC50 against any of the drugs that we have tried. So there is an effect, but it's not clear what exactly that is doing. So.
Yes, it's well known. It depends mainly on the genetic background. If you have different genetic background with the same mutation, we will see different phenotype, or I mean a range of phenotype. And it's classical with the K13 mutant. You can have we did that with David Fidock, so we genome edit different genetic background with the same K13 mutation, and we have a range of the RSA value from, I don't remember, but 5% of survival to 20%, something like that. So the genetic background is very important. So I just have a question.
Okay, last question now.
Fabian, it's about so you didn't talk about K13, so you don't have artemisinin-resistant parasite in Ecuador, so it's a good news.
No, we haven't found any artemisinin-resistant, or there is a mutation in K13 that is quite common, is 189, but no phenotype is associated to that resistance.
Okay, and the treatment that you use
is a Coartem.
Coartem.
The current treatment is Coartem.
And for me, we used to work in Southeast Asia, in Africa. Your genotype, your PFCRT genotype, I never see that. Very specific to South America.
Yes, and it's not only specific. PFCRT genotypes are very specific to the region. So the Pacific Coast is always C, the first, and the Amazon is almost always S, the mutations. So yeah.
Thank you.
Fatima.
I'd like to thank all my colleagues for this very nice roundtable, our roundtable. E eu termino aqui, agradeço a todos pela presença.
So thank you for your presence. Let's finish here and let's go on to the next session. Thank you very much.
I'd like to thank you, the judges, for your brilliant participations, and we'd like to ask everyone for an official photo for our records. Everyone to the front for the official photo. So then we close out the activities for this panel and we will continue with our next panel. So we'll now continue with our next table. Malaria and predictive models. We invite the research from Leonidas in Bargieri and Oswaldo Foundation. Nathália Costa Pinto Lopes to lead the activities. As moderator, research from the Institute for Health, Todos pela Saúde, Wanderson de Souza Sampaio. Good afternoon. It's a pleasure to call the three speakers to the 7th round table for our National Malaria meeting. I will give a quick introduction to them, but I will assume to you that I will be getting to know many of them myself in their participation together with you, and I think we'll learn very much with them about the predictive models in the scenario that we find ourselves in, climate changes, and also projects and directions for eliminating malaria. So invite, first of all, Monica Viegas-Andrade. She is Associate Professor from the Federal University of Minas Gerais, Center for Development and Regional Planning, an undergraduate degree in economics with a master's in the center where she is today and a doctorate in economy, FGV, postdoc from the University of Cobel Fabra and in Harvard, and her research is concentrated on economy applied, on the economy of health and evaluation of health technologies. I also invite Caio Henrique de Carvalho Monteiro, researcher at .lab Brazil from the University of Pernambuco, where he did his master's and currently is going for a doctorate under the orientation of Patricia Tacacomeno, bachelor in information systems, and in .lab Brazil focuses studies on artificial intelligence, machine learning, and deep learning with an emphasis on temporal series. I also invite Gabriel Laporta, who's a researcher for the Medical School of ABC, biologist with a master's and doctorate in public health, postdoc at Universidade de São Paulo, the Federal University of ABC, and has developed projects to assess the dynamics of infectious disease in different landscapes and in the context of climate changes. So welcome to all, and I invite our first speaker to come to the front. Good afternoon. I would like to, first of all, thank the opportunity to be here. I'm Monica from UFMG, and I would like to thank especially Delio and Claudia for the invitation, for the opportunity to be here in this very important meeting and the theme of malaria. So the work I'm going to be presenting here is the economic cost of malaria. And this project was a project developed as part of a tender bill from the Bill and Melinda Gates Foundation with CNPq. And our main question was, I have to declare I have no conflict of interest with the presentation or with its content, sorry. And our main question for this project was about what is economic load of malaria in Brazil, considering different types of costs, directly and indirectly, and the agents involved. So we have the challenge here of estimating, considering, therefore, the expenses in the system. In the case, we've restricted to the expenses mainly from the Ministry of Health and the municipalities. I will talk about this. And also, here are the costs effectively met by the family. So we had three main objectives. One was to develop a detailed model to estimate the economic cost of malaria, considering these different types of costs and agents involved, estimate and breaking down by unit of the Federation and by agent, financing agent. And we also want to develop a platform to the National Plateau for Malaria Control that would allow, the objective was to have this information of how much we spend with malaria, both at the level of municipalities and the level of states and of the level of Brazil. So the team was coordinated by myself together with Professor Maciel from Harvard, and has a large team of researchers. So I have a group of economics, health economics, the Department of Economics. We have a large team here that worked in this project. Here are the final results. So we, so in the first estimate that we saw, that was expenses here of the health system. So then here from the perspective of the system, we estimate the costs considering the expenses of the ministry and the costs for the municipalities. We see here in parity of purchasing power in dollars. We worked with 2015 to 2019, so you see here varying a bit, but it's in around $100 million per year. Expenses per capita of about $3.5 million, and per notification varying about 60 to 70. In terms of percentage of expenses for the Ministry of Health, we reached 0.08%. In other words, almost 1% of expenses, annual expenses, would be spent with malaria. So then we developed a methodology to be able to estimate these expenses, which included expenses with surveillance, with personnel, expenses with treatment. So this from the perspective of the ministry, and looking a bit to see these differences here between the states and the Amazon region in Brazil. So you see here we see in the deeper red areas are the ones that have the highest expenses. These expenses are the expenses here. These are expenses per capita, so it's very much related as well to the question of demographic density, population density, the lighter areas where the expenses are low. So we have a certain variability, not just in the level of expenses, but also variation in the composition breakdown of the expenses, also especially because of the level of incidence of malaria. So here's a bit about this between the states. So we see here that the states that spend the most money are the states of Amazonas, followed by Pará and Rondônia. This is a picture that's repeated every year, and then a little bit of the breakdown. The breakdown between the components that we're able to survey is relatively stable, and such that the most important component of the expense is surveillance. Here we worked with the expenses for surveillance, in fact breaking them down between the diseases for a compulsory notification. Unfortunately in Brazil we don't have information specifically for diseases, which makes it difficult to check up on these expenses to see what is specific for each condition or each disease, but we have developed this methodology, and then following this with the components of human resources, and then after that the treatment, which is relatively the cheapest part of the expenses. Those states that have still greater incidence will have a different composition, because in these states the expenses for treatment are a little bit higher. But this breakdown, this composition here, Acre, for example, that will have about 65% of the expense being expense with surveillance, because it has a more important percentage there in terms of treatment. Here, 2019, here we did for all these years to see that this breakdown has been kept as relatively stable in terms of the major groups. But it will vary a bit, because obviously the incidence will vary. Here we have the address of the platform that was developed. This platform has all the expenses at the municipal level for all the years. The purpose of this project was to, in fact, to have the National Malaria Control Program have developed a methodology for predicting expenses in Brazil, and also that this methodology could be exported to the countries. We also developed it. It has a main source. A large part of it are our secondary data offered by DataSUS. So it can be replicated for other years. And this has this breakdown at the municipal level. And it allows us, the platform allows us to make comparisons between municipalities and between states, both municipalities in terms of geographic relation or also the level of incidence for malaria. So this is the publication. This is referring to the expenses from the perspective of the ministry as a PLOS, which was published, and so if you wish, you can have access to the article, and the data from the platform are available. In fact, they're available for download. So besides the perspective of the ministry, we also do a field research. Since we want to look at the economic load from the social perspective, we include then the expenses and, in fact, the costs for the families. And so how much this load is for the families. To check this, we did a field research with the control group and treatment group, a household research in the Amazon region and municipalities and endemic areas in different municipalities in the Amazon region. And then what we have here is that we used an instrument to verify a question to be able to see the quality of life, loss of quality of life because of malaria. And so this is an instrument developed by Aerocall, Euro Quality of Life Group, which is the instrument that's most used, and also it's recommended by the Ministry of Health, that we then are able to estimate the qualities, right? In other words, the years of life associated to quality of life. And so then here we have these two graphs here. We have the curves here. These are the comparisons of the control groups and treatment groups. And these curves that we're doing here is in the axis, the horizontal axis here. We have the states of health organized here in order from the best to worst. So then what you're seeing here is the curves. And so then we have the control group. We have an important loss. Then we have a quality of 0.82. This metric is between 0 and 1. And 1 would be perfect health. So then you can see that in the region, the Amazon region, our quality of life is a quality of life that's inferior to what we're seeing in other regions in Brazil. We've done this study for Brazil. We are the group also that estimated the social preferences by states in terms of health, which is used by the Ministry of Health. And when we compare this with this average, you can see that an important loss. And so compared with the people who had malaria during the episode of malaria, this goes down to 0.69, which is a loss of 14 percentage points. In other words, 16%. So then it's a question of very low quality of life. This is quite very comparable to what you find in the literature for chronic diseases and even of severe conditions. And one of the things that we had in the research, we saw the research, it's a domestic household survey then. One question is that reinfection is a serious problem. So when with this, we would also have this measure of the qualities. And what we saw here is this instrument from EQ5T3L. It measures the quality of life. It's a metric that estimates the quality of life, taking into considering 5 dimensions with 3 levels of severity, and that we see here for the control, the treatment group, we see that in the domains that are most affected are the domains of pain and discomfort and anxiety and depression. Here's a little bit of what we're still finishing, but we're still writing the last paper, which is this economic load. So we're going to bring together 2 things here, which are we'll have the social perspective, including here the expenses with the system, and also the costs and the expenses of the families. So we'll have the expenses with single health system, the expenses with the families, the doctors and non-doctors, the indirect costs here, especially it's school absence and absenteeism from work, missing school and missing work, and the costs, intangible costs, which would be monetization of this loss of quality of life. Just so you have an idea, I was commenting here, and at lunchtime, one of the most strongest results that we've noticed, and that will very much impact this estimate, is exactly the question of absenteeism, which was something that was impressive. In other words, practically more than almost 50%, 46% of the people who had recent malaria had losses, lack of work, for not being able to do their work, and not just the work, paid work, but also work for self-consumption, in other words, production for their own food, for example. And these losses are quite high. You see here, average of 10 days. In other words, this is a period which is very important. And when you put this in from the point of view, economic point of view, and with all the relapses that we see for the episodes of malaria, this loss is extremely relevant. And in this case, it's a silent loss. It's a cost that we're not able to observe. So these are the main results of the work. This work has political implications that are very important because it offers to you, as researchers, it offers you an instrument to know how much we spend with malaria and how much we would not spend, how much money we would avoid spending if we could avoid cases of malaria. So I think it's an important work in this regard. And so having these losses in terms of quality of life, it brings important parameters for the groups that are working and for us to think about elimination of malaria and to inform public policies focusing on elimination and control of malaria. I would like to thank here the CNPq, Ministry of Health, the National Program for Malaria Control, the Melinda Gates Foundation, the partnership Marcia. And this work was only possible because we had an important partnership with the ministry in discussing and validating this methodology. So thank you very much for the opportunity to be here. Thank you very much. So thank you just for keeping the time, and we'll call our next presenter to make with their words.
Good afternoon. Good afternoon. So today we will discuss the use of artificial intelligence to make the prediction of malaria. So the artificial intelligence is in a boom moment because of new technologies and ChatGPT. So in our initial talk, I'd like to tell you what is artificial intelligence and to understand it and how we can work with it to make the prediction of malaria and our work of eradication of malaria. So sometimes we think 5-6 years ago, we thought about robots that would be working, automatized cars. And I tell it, look, tell me what you are like at work, what is artificial intelligence, and then it would have an interaction with robotics. So really what we should get to know about artificial intelligence. This is the first point, first step. And it's data-driven. So the artificial intelligence is a mechanism that will learn based on the amount of data that I can give to it. So the first point is that I don't have good quality data that actually express the reality. I won't be able to make the artificial intelligence to help me with a good decision making. So if I don't have good quality data, I cannot use artificial intelligence. So I have to go back and try to treat my data, to improve my data, and with this, we will have the possibility to use artificial intelligence. So when we talk about data and artificial intelligence, we have different parameters. So we will have artificial intelligences that have supervised learning, non-supervised learning, reinforced learning. So because of ChatGPT, we have been talking about it, and we have generative intelligences such as ChatGPT. So through different databases, it's going to be able to generate audios and pictures, but we have an entire universe of artificial intelligence. So we have supervised learning, where we can have these, we can pass these information. So it's going to give us, look, this is positive, and this is negative. So it's a technique in which I can group users in certain social media and in profiles combined with statistical combinations. So we are going to talk a little bit more about the part of supervised learning, and especially devoted to regression forecast, which is this prediction. So when we analyze artificial intelligence together with the prediction, we have a new universe. So when we talk about forecasting time series, we can understand that I have a data set that are occurring a long time, and based on these events, we will be able to feed a model so that it can understand the standardization of these events, and based on this, it can really make a prediction. So when we talk about artificial intelligence to make predictions and prices of oil and other things, I have to feed this model, because it's data-driven, with a great set of data, so that based on the past, it can predict the future and values and predict that variable that we are studying. So another point that is interesting is that this prediction can be connected to different databases. So I can have a notification of malaria databases, technological databases, and if I understand that these data or databases have a correlation that will impact or will tend to show me an increase on the number of cases, I can work with those variables, and my model will receive different data. And when I talk about time series, we will have data that are dispersed a long time, and so I need a rule, whether it's daily, weekly, or annually. So we can shape it so that I can tell what is my main series, and so that we can have a prediction, really. And when we talk about a prediction using artificial intelligence for malaria, so we have the CVEPI database, and we can understand historically what are these cases of malaria, what is the time when they occur, and so the model will learn it. So if I have a good databases that really reflect what's going on, and then my model will be able to learn so that it can help me with the decision making. So, for example, when we take a look at CVEP, it's considering the state of Amazonas. So I have 52 cities and how I'm going to predict it. Maybe the granularity of predicting the number of cases per state is too open. So if we predict it for each city, maybe then I will need a model that is specialist for each city. So when we start thinking about that, we think, what is the amount of models I'm going to need, the amount of data, how this is going to work. So I'm going to need one model for the entire state or 62 models. So each city will have its specialty, will have a cost to run. So if I have 62 cities, I need a more robust machine. I have a higher cost. And then I have another division. So now I can look at from the point of view of health. So I have some regions of health. So how many models of artificial intelligence I would need to predict or to have a good prediction of the amount of the cases? 1 per state, 9 for regionals of health, and or 62 for cities. And when we start to evaluate and experiment, we start to think of new possibilities. But now I can have 5 models. Why? I understand that there's a unique state, 62 cities, with the divisions by regionals of health. Sometimes the cities are not geographically close. Sometimes the locations are not close to each other, and we can have another pattern of artificial intelligence to have this grouping using artificial intelligence and using a non-supervised model of cluster so that the cities are grouped according to the statistics of the year. So I'm going to analyze 10, 20 years of quantification of cases, notification of cases. So I can understand. So there is a peak of notification in this city, and this other city is not close to it, to this one, but it behaves the same way. So based on our time series, this model can learn that these cities they are statistically similar. So I can take a look at regionals health, or I can take a look at the clusters and understand how this notification of malaria happened in the state of Amazonas. So this grouping with clusters tell us that, look, in this notification, I have notifications of different cases of malaria, so I need clusters for different time series because the behavior of Vivax and falciparum are different. So Vivax has more number of cases, so we can have this division of the state geographically. So I have the state, the regionals of health, and the cluster, and I can evaluate that divided by data sets. So I have 2 notifications and all the confirmed cases. We divided into 2 groups of Vivax and falciparum, and so we have a set of experiments telling the division of clusters based on the kind of malaria and the division of the states and the models. So I can have a setup of approximately 150 experiments to guarantee that really I will have one model that will perform better for each state. So If one city has doesn't have a lot of notification, it's going to have a sensitive case. So, for example, the case of the city of Manaus, which has a higher number of notifications. So the model will be able to identify peaks. So we have information based on each data set, and it will create a model. So this is a kind of artificial intelligence, a kind of model that can predict and have really low error. So it'll have a delay on the prediction, but as this delay, this time of the curve is a standardized time, then we can minimize it so that it can understand and predict when there will be a peak on the amount of cases. So now we are exploring and increasing this potential. So now we are coming from an experiment in the state of Amazonas. So, and going forward to the legal Amazon region. So, but I can take a look at the state once again for these 162 cities, and now I can divide it into clusters that can understand the statistical model of each city so that we can have our prediction. And our objective is really to have a dashboard that is integrated and receive these databases. So it will receive an input of the user or CVEP Malaria. It's going to integrate this information. It's going to activate the models according to each area and make the prediction. So I'll make the prediction for the next 3 weeks, 1 month, and then I can have a red flag saying that I can have an outbreak or a peak in epidemics, and so we can have the anticipation and make this peak not happen. So I hope that my model is always wrong, because the decision maker can have activity so that that outbreak doesn't happen. So this is the structure, and we begin to use it in initial stages of artificial intelligence. And then we process the data until these models that can make the predictions to understand the cases that are going to happen in the next few weeks. And based on this prediction, we can have a classification. Is this number of cases, does this characterize an outbreak, an epidemics? So we can use this artificial intelligence to subsidize the system for decision making so that we can always avoid and really combat the amount of cases of malaria. And at last, there is, I'd like to thank the University of Pernambuco, FACEP, CNPq, WS, and I would like to emphasize that we can only have the setup of experiments and probabilities and models because we have the support of CNPq together with WS, and we can train these models in exhaustive models of benchmark so that we can have the adapted model based on our structure. Thank you. So let's have our last lecture of this roundtable. Good afternoon, everyone. Okay, I have 4 minutes and more 3 minutes from Monica. I'd like to thank the organization, to thank for being here in this Amazon capital that is wonderful. I'd like to greet all of my colleagues. It's a great satisfaction to be here. My name is Gabriela Porta, and I'm going to talk about prediction of variation of temperature in the cycle of malaria. There are no conflicts of interest. This is the summary of my presentation, and I will begin talking about. I really like this picture in 3D. It was a very emblematic study for me. It was a modeling study made in Tanzania in felines, and I guess it really summarizes that we have to have this 3D picture in our heads. So basically what you're seeing here. Let me just have a Harvard course here. Yeah, it's not happening, right? Yeah, I guess that's it. So as I have more 7 minutes, didn't understand it very well, but okay. So we have here 3 axes. Y-axis is density of vectors, X-axis is temperature, and Y-axis is precipitation, rainfall. So here in the combination we have curves that are unimodal, they're not linear. And you have an optimum expected, which is in red, which is where you have the highest density. A mathematical model, higher density of vectors. So if it's true, we will have the same thing regarding the parasites. So we will have optimums of temperature. And this is a curve that is maybe universal. In case of parasites, there is always an optimum of temperature. So in this case, let's see if I learned. It's a little better. Thank you. So you're seeing here R0. It represents the number of secondary cases from a primary case. And this increases according to the curve reaching a certain temperature. In this case, it's something like 31 degrees. And this is a study that was made in Tanzania. For example, in Belém, what is the optimum of temperature for transmission? It's a very hard question, right? But if somebody tells you it's 31 degrees, you can say, yeah, it's plausible. It was a very important model that was challenged afterwards by other groups. And I'm going to tell you a bit about how you can do this, how you adjust a mathematical model to test the hypothesis. So this is a classical model of transmission of malaria, Ross-McDonald model, in which this R0, this rate of reproduction of the disease, is due to different factors of the parasite and of the mosquito. So we have the M, which is density of vectors. We have A, which is the biting rate. It's squared because the female has to bite twice to have a transmission. We have vector competence. We have 2 probabilities multiplied because the female needs, when it bites, it has a certain probability. And it also has a probability to infect the host. And so we have, I guess, this is genius, simplified. But in the original formulation and the explanation, I thought it was very genius how it was proposed, which is the thing that the female is connected to the extrinsic rate of the parasite, extrinsic incubation rate of the parasite. So this has a rate a long time, and finally we have human density and recover rate. It doesn't assume a recovery, so a certain day, at a certain moment, the human becomes susceptible again. So this can be applied by the National Program of Malaria. So we made some calculations. Dr. Marilis is the first author of this article, so you can see here some calculations. In this column, we have R0s calculated for rural settlements in Amazonia in 2007. We hope that the tafenoquine changes this. So, but what do you think about these zeros? They're high, right? There are 60 secondary cases from a primary case in Machadinho do Oeste. It means that the disease is going to persist forever and ever. And with strategic control, maybe it might just go in back. Just so you see that it's possible to apply mathematical models to estimate parameters of interest. So at first it was proposed for that. And so there's this Ari Mordecai's work, which is very emblematic as well. So what they did, they took the classical model of malaria and assumed that the parameters of the parasite and of the vector are also sensitive to temperature. So you can see this little t. Yeah, I'm getting good at it. So this little t here is assuming, so that's the biting rate, vector, those are sensitive to the temperature. And so we had one more modification, which is interesting. They modified the density of mosquitoes to parameters that are ecologically more realistic. And then we will go back there. And that's it. Let's see the results that they obtained. The main result is this. So again, we have unimodal curves. Imagine the situation. You have the rate of maximum reproducibility conditioned to this model and the available data. What would be the optimum curve of each parameter separately? And what you're seeing are nonlinear curves. If we increase the temperature forever, one beautiful day, you will have a decrease, for example.
So I think this is the biting rate at 15 degrees. It's quite low. As you increase the temperature, it increases almost linearly, and then it reaches a threshold and drops. So then I think that this threshold at more or less 30 degrees then goes down. So you're not going to have a bite rate increasing linearly forever, one beautiful day. There's a lot of temperature also is not a great for high and low, too high and too high. Low temperatures are not very good. So they have an optimum. It's true for all the parameters. The right threshold, the vector competence, and so on. You always have these responses that are unimodal. And then there's a legal. What's interesting here, the question, because Mordecai is the F0 optimum and 25 degrees. She said the estimate previous one was 31, which is very high, too high. We thought that this is much lower, so this has a lot of implications also in terms of what we're expecting, in terms of possible changes of temperature. 25, I don't know what you think. 25 degrees is optimum. Optimal seems to be low, even though in the labs it demonstrates that sometimes you do have something interesting here that later you can see, but we need to read the work with a critical view. One thing that bothers me in this work by Mordecai And look, far from being, I don't have a monopoly on the truth, but I'm just saying that we have to read the works with a critical view. Also, feel free if you want to disagree with me. That's fine. No worries. So there are two important things here. First of all, the work by Ed and Marco, it circumscribes the events and vectors in Tanzania. The work by Mordecai said, no, we're going to get parameters from several vectors all around the world because we want to do a model for Anopheles. Right? So then when you look at the key species that she used to estimate the parameters, you're going to have, for example, they're all major vectors of malaria, except for albopictus. But this pinus, there's a little bit of quadrimaculatus. Quadrimaculatus is perhaps the main vector in the United States. Obviously, Gambia came in. So you see here migrates. Into that formula you used to work from pseudopuccipenis. So then it's interesting that this parameter is exactly did not have any parameter for Anopheles, and they got it for Aedes albopictus, and then assuming that it would be a proxy, Aedes albopictus. So that was supposed to be a proxy. And I don't know. My opinion is that the response is very species specific. So the response for precipitation, for example, temperature, for example, if you compare Dalinja with Marajoara, the response is the same to an increase in temperature or to a longer period of drought. These things you have to look at. So then, having said that, I'll go into the next and final phase of the presentation, which is the use of envelopes, environmental suitability. This approach has several other names: models of ecological niche, species distribution modeling, appropriate ability of habitats, models for potential distribution. But all of them are more or less have the same protocol. They use artificial intelligence, these algorithms for machine learning, to cross data of occurrence of species and environmental data. And there's some interesting things that are done with them. For example, here, there's a work of ours done here in South America. You can see here two maps resulting from this type of analysis. The first is a map with Darlingi, and then the second, according to this map, there's a high probability of you being able to collect Anopheles Darlingi along the main channel of the Amazon River. We're going to collect there, and on the other side, so then just to make an addendum, this is the map, and so it has a higher possibility with others. But besides this, you have other things for falciparum, and there seems to be a mirroring, but that's why you have the people for parasite vectors. Listen, what would happen? So in terms of the specific response, what would happen if we had an increase in the temperature, a reduction in the temperature, or an increase in the drought period, the dry season, for example? If you're thinking about Amazon climate, we have several simulations and models, but there's a consensus that not only average temperature, but the minimum, but there's also a consensus that the precipitation is going to reduce, but more than that, but the drought period will be greater between the seasons, between the dry and the wet seasons. So one of the simulations we did was that you're seeing here the current distribution of Darlingi and the future how it's going to be. In other words, a disruption in this distribution, see that dispersed with this region down into Cordoba in Argentina, whereas other species of Anopheles, for example, and so then we see the distribution of Anopheles juniorum is not affected by these future conditions. So this is also common, for example, to other species of the same group. Anopheles malajoara, which occurs here in Pará, is also much more resistant. You can see this. So in other words, the Eucalyptus galingi, it's this species of shaded edges of woods, the lava, for example, whereas malajoara is a much more resistant species that likes wetlands more. So people who collect anopheles know this is true. So therefore you will have really a potential, since you have a vacant niche, maybe you will have a replacement by another species. So very well. Having said this, we talked all about the Stephensia. I would like to just note that this is a very intelligent way to apply these models to test hypotheses, and the question here is very simple. It's play. It's very important, very intelligent what they've done here. There's collections in the field. There's modeling, and so then it was very well addressed. So then they knew the time when they had Stephensis in the Horn of Africa. So then you can see here they have these open circles. Here's the points of occurrences, where you have it in Asia. It also happens. It happens in the Horn of Africa, and so they took out all the occurrences from the Horn of Africa, excluded this analysis, just did this analysis from the points of occurrence in Asia. So they said, look, what happened? They obtained results that were quite interesting, showing that in fact there's a favorability for habitats, natural habitats, that is intrinsic to an ecological niche of the species in the northern part of Africa. So if one finds this species diverse out there, it's going to find appropriate habitats. So then it's that's what we're talking about. So once you know that you have this, you're talking about creating a group, rapid response group, and I think that it has to do with that. So the scientific question was very well made, and I think it has a lot to do with this capacity that we have. Since we know this beforehand, I think that it makes sense to programs and control in this case to work also beforehand. So Holland here is looking at this. So in other words, this is just to end. I'm almost expending the time of my colleagues to getting back to this. We did presented this work yesterday, and I'm coming back to it, and I'm revisiting it here to say simply the following. Look, everyone, in these future models, besides working with temperatures and precipitation and other variables that are commonly used, for example, altimetry, vegetation, we need to include hydrology. So this program of science is available. We need to do this for South America. It has to do really so here we have to see evaluating the response. So it's interesting, a distribution for malaria. We hope that you're able to see this legend here, but the darker green is a larger wavelength of the period of transmission. And so then when you consider climate only, you obviously will have here in this part, the dark green, which is right here, from sub-Saharan Africa, you're going to have greater probability of having more malaria during the year. And if you consider you have a very strong, more heterogeneous pattern, because you have the effect of the rivers. Even the Nile River here, even the Nile River goes into its model and becomes more real. But then you have my last second here and my last slide. Practically, You have the model that's going to happen, and so we're going to have a change. The reds, so they say it's going to increase, and the blue is going to reduce. But, in other words, we finalize, then the takeaway messages of what was said, the simultaneous effects of temperature and precipitation, and the density of vectors. Thermal responses are always nonlinear. It's not just by increasing the temperature infinitely, you're not going to favor it, not always. This optimum for malaria transmission has a range, and it's species specific, of course. And finally, the importance of including these models for hydrology in these predictions of the temperature effects on the malaria cycle. Thank you, Gabriel. Thank you, everyone who presented here. Excellent presentations. Congratulations for sticking to the time. Times is very good. It's not the first time we're meeting here. And panels, I know everybody here, so I think that the wealth of this debate is coming from much more probably from the audience than from me asking questions and what I can do later for you. But it's interesting here in this panel is that it has a method as its name of models that we can see that has to do a lot with the model. Can be artificial intelligence, it can be estimates of cost effectiveness, it can be climate model for prediction of diseases and vectors and a whole bunch of things. So therefore I think here we run through different scenarios and different applications of the different concepts of modeling. And malaria obviously is the background. So I'd like to open up to the audience for questions for the members here of the panel. We have a bunch of questions here if you have time, so feel free to offer yourselves to ask questions. Going once, going twice, going three times. Sold. I'm going to start. Okay. So, Gabriel, it's not just the point of it's hard to use. Good afternoon. Congratulations for the presentation. My name is Evandro from Universidade de São Paulo, and I have a question for Caio. I think that it's very interesting to bring in artificial intelligence for this discussion, and I was thinking more in the question that it's been very much discussed in the Congress and in the symposium as well about the question of deforestation and climate changes and how this will affect the number of cases and all the situation of malaria, especially in Brazil and in Latin America. And how can this, since this model is already trained for this, how, if not, how could it be trained into this thinking about this new scenario that may be on the way? Yeah, what's interesting in the model is that it will be able to learn based on the historical amount of data that you've got. So if we get here a historic series of deforestation data, and then we're able to link this to a model and make a mixture of correlation, and you have a weight to how much this other temporal series can or will impact on this model. So then we have models that get the question of rain and fall. And so depending on where the rain falls, it will impact on a jet lag of 7 days that will be farther down. So the model is capable of learning. But in fact, you need to look at it to see the model to be able to understand what's the standardization, for example, the question of deforestation, how much time later will it impact a certain outbreak. So initially it's if we have historical data, and these two temporal series can be sequenced and to understand the relation between them, the model will be able to learn. To the contrary, we can work on this with how the exogenous variables can generate right here. So then, especially now when we're in a growing curve of deforestation. So possibly we'll only see this impact in 2 or 3 years. So it's going to depend. There's no way for you to already predict these 2 or 3 years if we don't have a historical series that accompanies this speed of deforestation we have now, but there's a model and that we can work on with the idea that we call IMOFlow, which the model will always be there feeding itself on the historical series, and it will always be improving. So you're able to link the functioning to the main historical series, for example, CIVEP, with the case studies and temporal studies in parallel that will be limiting that model. So it may be in 6 months we may have a greater volume of data, and the model will then come up with a new training and learning cycle for it, so they can more and more can be more specialized to the situations working on. So do you have any idea?
Need to be tested, I think, in terms of their prediction and their utility, or maybe in only their ability to explain the past. But we are trying to discuss here predictive models, and I wonder if there are really sufficiently good examples of predictive models for malaria that have proven themselves in any particular settings to predict things that were not yet happening. And if not, why we will not put a framework to demand that? Because while they are clearly useful, I'm not questioning it, but if we are not putting this as the ultimate test, we may actually, I think, miss even their best value. Thank you.
Alguém se dispõe a responder? Gabriel?
Yeah, I have provoked you and then, no, just joking. But yeah, your question is really key for the discussion we are having here. Because, of course, at the end of the day, you want to know if your prediction is true or not, or how much true. So, I have shown the Stefansi map in my presentation, and I think that is, let's say, a proof of concept of how this kind of potential distribution modeling can be useful. Because the truth is, if we were to use what we knew at the time, where Stefansi was there in Asia to build this model, we would know in advance that it would reach Africa someday. So having said that, it's important to clarify that some predictions and some outcomes that have not yet occurred can be avoided at the same time. So if we know in advance that something will happen, we can plan now to avoid something in the future. So even so, a predictive model that misses the point because it provoked action towards to prevent it, it's still useful. But one way forward to improve the prediction is to include not only, because usually we use internal validation, but we should use external validation. So we build the model, do the predictions, and then go to the field, make collections, and only after that we publish the paper. So yeah, that's what I think.
Obrigado, Gabriel. Victor.
Good afternoon, everyone. Perhaps Kayo and Gabriel may help me understand something. As we talk about models, I see that we tend to focus more about humidity and temperature. But what about these other climatic parameters? For instance, light intensity, cloudiness, winds, atmospheric carbon dioxide, air pollution. Why do these models not consider these other factors which, say, back then or many years ago were not so much of an issue, but nowadays they're becoming an important factor in our day-to-day lives? For instance, we have some places that are very much polluted. We don't have adequate lighting, adequate oxygen. So things have changed compared to, say, 30 years ago, 15 years ago, 10 years ago. Why are not these factors considered in the current model?
Acho que vocês podem responder em português, porque o Victor, ele mora em Manaus há pelo menos uns 10 anos já.
Can speak in Portuguese because he has been living in Manaus for 10 years already, and he understands Portuguese. Can anyone answer that? Thank you for the question. So until a few years ago, we haven't really thought about working with that. So it was a status quo of this area of research to consider other factors. There is a reason for that, because to work with ideology is not the same of working with rainfall. There's that. So if you have if you spend a congregation of data, it's not easy. But these other factors that you put, I guess they are important because part of them are collected with satellite imaging. So, for example, it's possible for you to derive some kinds of parameters of satellite imaging that are being produced weekly, monthly. So let's say the same sensors that help us estimate NDVI would also help us estimate other parameters. So I guess that everything is part of innovative aspects of the sciences to be able to reach different levels of analysis. So if you think that is interesting, maybe you should do it now. It's quite relevant. And so it's interesting because today our tools are very much available. So we can get the database, and even if I say, no, I'm not going to develop a machine learning model. For example, we have Facebook tool, which is LaserPress, so you can use the tool without a lot of coding. So you can get these exogenous variables and apply in your prediction model, just so you can have a validation of the idea and understand really what exists. So it's important always to remember that not all correlation has a causal relation. So it's important to understand if there is a relation between those variables and what will have the most impact on your model, because sometimes you will have a lot of variables of one model, and then you make it more robust, and you won't really be helped in your model. So for example, sometimes you have 10 time series and you believe that there is a direct relation, but actually it doesn't happen. So with 2 or 3 variables, you can have the same performance. Hello. I'd like to congratulate Evandro. Really talked about 3 different things, talking about malaria, but using different models. I have a question to Monica. I guess this matter of the budget impact of malaria is really something that we need to amplify a little bit more. this evaluation, and it really impressed me this absence of on the work. It's been a long time. We have been working, for example, Holbeck Malaria talked about this, the return of the investment when we have the elimination of the malaria. So it's important for the government to understand how eliminating malaria can make us have the return of this economical investment. So how can we transform this data you're showing there to a convincing and advocacy for the manager to maintain the elimination of malaria in the agendas? So another question to Gabriel. So inside modeling, the part of temperature, this is something that is intriguing. In the temperature of the Amazon, we have a constant pattern. We don't have a fluctuation, really, of maximum and minimum. And then we have to evaluate. Is this really what happens here? Or is this rate of transmission homogeneous? Does this have an optimum, or is it linear because of this homogeneity? Not because it doesn't have this fluctuation. So what do you think regarding the Anopheles defenses? We have to talk about this and evaluate how much it has of impact and how we can have overlaps of species in this climate change scenario, which will transmit better the malaria, to focus on the biology of the vector. Thank you. Thank you, Sheila, for the question. So, the usage of the result is practically, let's say, direct. We can, when we close the estimate of the economical charge, we can calculate this for each case in a more general manner. And in our case, we will have the disaggregation by state. And we have the charges of the families, as you mentioned. It is a silent cost that is not monetized directly, but it is a cost that is associated to productivity, to decisions of investment that people make, of education, and a number of things. There's this, in the specific case of malaria, what calls our attention is the absent people from work. So we have lost data, and there's something, the dimension of work that we cannot get, and it might be elevated. So we can use this result to show to the manager and say what would cost the program of elimination versus how much I would be spending in terms of direct cost of the system and costs of the families. So the model will have this parameter, which I think is fundamental for the cities and states. Thank you. So a last comment, Gabriel, just so we can continue. Yeah, these are difficult questions about the temperature. I guess it favors a lot the transmission if we think that the optimum of the curve is 31 degrees. I guess the value of 31 degrees is a lot constant on different cities in the Amazon. So I guess that would be the most common in different places. So if you have the meteorological pattern, 31 degrees would be the most frequent one, and it favors a lot the transmission. But I guess the point is maybe referring to the dry season, And this differs us a lot of that study. So maybe we'd have as a subproduct this decrease, and the fact is that the curve of response of the rainfall or availability of water is a lot more strict for the mosquito, so it feels more the lack of water than the temperature. About defenses, we made a very similar analysis of this one, and we will send it for publication soon. And there is a prediction, and we can talk about it. It's really time for to act. Thank you, Gabriel. So now we can finish this table. I want to thank you for your excellent presentations, new data, and thank the audience for remaining here. Thank you very much.
So coming back to our programming, we will now begin another mini conference. We would like to invite for Centers for Disease Control, Provision, Alexandre Maciel de Oliveira. Good afternoon. I'm Alexandre Macedo. I work at the Center for Immunization and Respiratory Disease at CDC. It's a pleasure to be here. I'd like to thank Gisele for the invitation and participating in this meeting. In fact, I worked for several years with global health. I think it's one of the reasons that brings me here today. So I have a great
Institute. He's a physician researcher from Australia. Dr. Robbie Commons é pesquisador médico do Instituto de Investigação Menzies da Austrália e vai nos brindar com uma apresentação sobre The Power of Data Reuse to Improve Malaria Treatment, Insights from WARN, which is the Worldwide Anti-Malaria Resistance Network. So thanks very much.
Thank you very much, Alexandra. And thank you very much for having me here. It's a long way from home, but it's great to be here. So, as mentioned, I work for a research institute in Australia called Menzies, but I also have a strong collaboration with WARN, the Worldwide Anti-Malarial Resistance Network, and I'm going to tell you a bit more about WARN today. Just in terms of my disclosures, I have received funding from the Australian Government through the Australian National Health and Medical Research Council. So in terms of my story, I am an infectious diseases physician, and that was my primary purpose after going through university and training and work. But I then became interested in research, and so my home base is near Melbourne in Australia down the south, but I also worked in Darwin, which is up the north and is much more tropical, not quite as tropical as we are in Belém, but yeah, more tropical than Melbourne, that's for sure. I was in Auckland. I'd followed my wife, who's a surgeon, across to Auckland, and one of my previous supervisors, Rick Price, emailed me about a PhD opportunity. And I think, as all good stories start, it's just by chance, and you take a chance, and here you end up. So this was about 8 years ago. And he emailed me not thinking I'd be interested, but trying to find out if I knew anyone who might be. Anyway, it sounded like a great opportunity, and next thing you know, I was involved with it. And it was in collaboration with WARN, which is the Worldwide Antimalarial Resistance Network. They're a global collaboration, but they're based out of Oxford in the UK. My supervisors, Rick Price, Julie Simpson and Kamala Thrimer, you've already heard a couple of their names mentioned quite a bit today in terms of clinical trials that are being run with tafenoquine. So I ended up at WARN, and WARN is one part of EDO, or the Infectious Diseases Data Observatory. And EDO, in essence, is a data repository. So it sounds pretty straightforward. But it's a data repository with a difference, because it doesn't just take the data and let it sit there. It then curates the data and matches it to other data sets so that the variables are the same. And that creates great power to that data repository, because it means that you can then undertake analyses with individual patient data where the data is equivalent across studies. In terms of how the steps of the process within WARN work, first of all, an investigator decides to deposit their data in the repository. And once it's deposited, the data is curated and standardised to a standardised set of variables. Then people might decide they want to do a study on malaria or a type of specific aspect of malaria, and they put in a request to WARN to do this study, a data access application. That request is then assessed by an independent group, a data access committee, and the chair of the data access committee is a WHO member. And it is also assessed and signed off by the contributors who've originally shared their data. And if that is all successful, then the data is shared with the people that put in the application, and the analysis can be undertaken. So WARN started in 2009, and the first study group was actually published 4 years after that in 2013. It first made changes related to their work in WHO guidelines in 2017, and by 2023 there was almost 800 data sets and almost 200,000 patient records that were included in the repository. And there'd been over 50 study groups formed. And there's been lots of publications and bits and pieces to do with efficacy, to do with safety, pharmacokinetics, and I'm going to focus on 3 applications that I've been involved with WARN, and these demonstrate the power of using such a large repository of data and what that can then achieve with secondary data use. So these are optimising antimalarial doses, extending treatment to new populations or subgroups, and improving trial methodology. So licensing for antimalarials, the pathway is pretty clear. And MMV's we've heard from MMV today, they're heavily involved with this pathway, and it's pretty clear. You know, you find the best dose, which is safe, and you license that dose. Generally, licensing studies are relatively small, and there is certainly a role for post-licensing studies, so phase 4, to actually look at those doses, potentially refine them, and also to consider subgroups that may not have been able to be considered in the original trials. And this is where the WARN data can potentially come in use. So the first study that I did back in 2016-17 was I looked at chloroquine and chloroquine dosing. And as you'd be aware, it's not an issue that's really been a major concern in the Americas, but chloroquine resistance was really taking off in Southeast Asia for Vivax around 15 years ago or so. It's been some level of resistance that have been reported sort of throughout most endemic Vivax endemic countries, but it was really a hot spot in Southeast Asia, so in particular in Malaysia and in Papua. Now, if you're a policymaker and you're considering how to deal with chloroquine resistance, you've got probably lots of options, but 3 key options that I'd propose. One, you could change chloroquine to ACTs, and that's obviously what's been done in Southeast Asia in many countries. You could potentially optimise the chloroquine dose. Is this the best dose that you've got? Or could you actually change the dose to actually make it more optimal? Or number 3, and this is what's happened over the last really 5 years or so, as we've increased our aminoglycinine use across the globe, you could add an aminoglycinine. And so I wanted to look at what the effect of chloroquine dose was and what the effect of adding primaquine was on the risk of recurrence in the early stages of Vivax malaria, so the first 42 days. And I'll just take you through this study fairly slowly, just so that to give you an idea of how these studies are set up. So this is, the studies are individual patient data meta-analyses. So they're quite different to a traditional aggregated meta-analysis. You're not taking the aggregated results from studies and pulling them together like that, but you're taking the individual raw patient data and using them to reanalyze the data. So the first thing I did was we did a literature review, identifying all published clinical trials of Vivax malaria. After we'd done that, we identified those that were eligible, and all of the eligible studies, we then approached the investigators. So we sent out lots of emails asking whether they'd be happy to share their data to the WARN repository and be part of the study group. A large number said yes, and so we ended up with 37 studies and around just over 5,000 patients that were shared for the analysis. So once they were shared, the data, they were then curated. I standardised the data and got it ready into a single data set so that we could actually analyse it. And you could see we had quite good representation across most Vivax endemic regions. And as mentioned, we ended up with individual patient data. So this figure shows each dot represents a patient, and it shows the patient's weight versus their milligram per kilogram dose of chloroquine that they received. So not the dose they were meant to receive, but the per protocol, so the actual dose that they did receive. And you can see here, as you'd expect, you often have weight banding, so with different weights, you get a curve. People that are on the lower end of a weight band will get a higher milligram per kilogram dose. People that are on the higher end, heavier end of a weight band will get a lower milligram per kilogram dose. And we could see initially that close to a third, or just over a third of patients actually received a dose less than the recommended chloroquine dose of 25 milligrams per kilogram. Obviously, we wanted to know, was there a relationship between chloroquine dose and risk of recurrence? And there was. For every 5 milligram per kilogram increase in chloroquine dose, the risk of recurrence reduced by 18%. That was across all ages, but it was an even greater reduction in recurrence in young children, in children under 5. So for every 5 milligram per kilogram increase in dose, there was a reduction in recurrence by 41%. What about primaquine? Well, as we know, primaquine has schizondocidal activity and is also suppressing the first relapses, which can occur within those 42 days. So the effect of primaquine was marked. It was a 90% reduction in risk of recurrence over those first 42 days, so adjusted hazard ratio of 0.1. And this was present in regions where Vivax relapses rapidly after the first infection, and also in regions where Vivax relapses slowly after the first infection. So low relapse periodicity regions and high relapse periodicity regions. So what can we conclude from this first study? Well, we can say that we can reduce recurrences firstly by giving people the right dose. So we shouldn't underdose, and this is, I think, a take-home message, full stop. Whoever you're treating, make sure they're getting a decent dose. We could increase the chloroquine dose from 25 to 30 milligrams per kilogram, and this would lead to substantial benefit, especially in young children. Or we could add primaquine and decrease recurrence by 90%. And so this leads to the second section of this talk, which, as we're all aware, radical cure of Vivax malaria requires treatment of both the blood stage and the liver stage. And we unfortunately only have one class of drugs to treat the liver stage, and they are the aminoglycinines. We've got the old drug, primaquine, we've got the new drug, tefenoquine. Unfortunately, both of them, belonging from the same class, have the same side effect that's hampered implementation, and that being severe hemolysis or potentially severe hemolysis in patients with G6PD deficiency. Now, the good thing is they prevent relapses. The bad thing, they have hemolysis. Relapses, the total dose is what determines their anti-relapse efficacy, whereas in general it's their daily dose, this is for primaquine, that determines the risk of hemolysis or other side effects. And this is important as we think about different regimens of primaquine. So what dose and duration should we be using of primaquine? And this table here just really sets you through the 4 different regimens that are currently in discussion or in recommendations at the moment. So if we look at the total dose column first, there's two total doses, 3.5 or 7 milligrams per kilogram, low versus high. If we look at the daily doses, these are 0.25, 0.5 or 1 milligram per kilogram per day, low, intermediate or high. And depends whether you're giving it over 7 or 14 days as to which of these 4 rows you'd fall into. Now, interestingly, the very first early studies back in the 1950s suggested that around about a 5 milligram per kilogram dose over 14 days was better than 3.5 milligrams per kilogram. But because of the US military experience in the Second World War, where they took soldiers back across the ocean, there was a lot of comfort with using the 3.5 milligram per kilogram dose, and that really got taken up because of its proven safety. WHO guidelines currently recommend 3.5 to 7 milligrams per kilogram. 7 milligrams per kilogram if you're in Southeast Asia or Oceania, and that's over 14 days, and 3.5 over 7 or 14 days in the rest of the world. But in practice, most countries give 3.5 milligrams per kilogram over 7 or 14 days because of concerns about safety. Unfortunately, there's very little direct evidence comparing high and low total dose primaquine. There's a little bit, but not a lot. And it's led to a lack of, with Cochrane views that's assessed it and assessed under rigorous guidelines and looked at it a traditional way with aggregated meta-analyses. It's led to a lack of data and a lack of confirmation about which way we should be going. So we looked at this in a different way. We looked at it and said, okay, well, rather than doing a trial across multiple countries requiring thousands of patients and millions of dollars, we'll look at it through the WARN system and with pooling data. And so we aim to determine the effect of primaquine dose on Vivax efficacy, tolerability and safety. We pooled studies together, efficacy studies of uncomplicated Vivax malaria with at least 28 days of follow-up that included at least one arm with daily primaquine. We approached all the investigators similarly to before and collated the individual patient data. And from 96 eligible studies, we were able to collate data from 36 studies, including 8,500 patients. For the efficacy analysis, we had just under 7,000 patients. And this is a Kaplan-Meier figure, so it shows the time to first recurrence over the 180 days and the risk of recurrence on the y-axis. And you can see the three lines, the black line being no primaquine, which has the highest risk of recurrence, the blue line, low total dose primaquine, with a lesser risk of recurrence, and the red line, the high total dose primaquine, with the lowest risk of recurrence. And if we compare the high dose primaquine versus the low dose primaquine, the adjusted hazard ratio of 0.45 shows that there's a 55% reduction in risk of recurrence with high dose primaquine compared to low dose primaquine. So you'd treat 10 patients and prevent one recurrent episode of malaria. Now this is a global analysis. It's not, and regions are all different, but this was surprising because it was not only present, the results were present just for regions where there's high relapse periodicity malaria, but also for low relapse periodicity malaria. This figure is slightly different. So we posed the question that just because traditionally we use 3.5 or 7 milligrams per kilogram, are they actually the best doses? Or is it better to keep going? Or is it better to stop halfway? Or what's best? Unfortunately, the error bars haven't come out on this figure, I don't think. But this is a spline graph showing the hazard ratio of recurrence as we increase total dose of primaquine on a continuous scale. And you can see that the hazard ratio falls until it gets to about 6 or 7 milligrams per kilogram, and then it plateaus. So we can probably say that the best dose of primaquine globally, overall, to reduce the risk of recurrence is around 7 milligrams per kilogram from an efficacy perspective. But what about side effects? And we've already heard that primaquine has a risk of gastrointestinal intolerability, and obviously there's the risk of hemolysis. So if we, first of all, before we go there, just a reminder, we're talking about side effects now, so we're going to talk about daily dose of primaquine, not total dose. So we're going to talk about the furthest right column. I did this study with Dr. Megha Rajasika, who's at the University of Melbourne, and included around 5,500 patients. And you can see after, in an adjusted model, looking at gastrointestinal symptoms on day 5 to 7, so this is after acute symptoms of malaria have reduced, after the shizondazidyl drug has been finished, that there was no substantial difference in gastrointestinal side effects between no primaquine, low daily dose, or intermediate daily dose primaquine, but there was an increased risk of symptoms with high daily dose primaquine. Obviously large confidence intervals though. Saying that, since these studies were collated, we've had a number of new studies that have been done looking at high daily dose primaquine. And one of them has been done by my colleague, Professor Kamala Trima. This study was actually a falciparum study where they looked at radical cure, high daily dose primaquine radical cure, so 1 milligrams per kilogram per day in patients with falciparum, and randomised that against patients that just received a single low dose of primaquine, just one dose of 0.25 milligrams per kilogram. And the difference with this study is that they gave their primaquine with food, and they observed the food taking, they provided the food, they observed it, and they demonstrated there was no difference in gastrointestinal side effects between the two arms, between very low dose and very high dose. So if you're giving primaquine, I know we're moving to tefenoquine, but if you're giving primaquine, I'd give it with food. What about hemolysis? Because that's really the elephant in the room. And until recently, we didn't really know what the risk of hemolysis with G6PD deficiency was, because there was a few factors that we didn't know before we got there. First of all, Vivax malaria itself, or any type of malaria, has a risk of hemolysis, and we didn't know the amount of hemolysis that occurred with Vivax malaria. Secondly, we didn't know if primaquine caused hemolysis in patients who did not have G6PD deficiency, who were G6PD normal. And we needed to know both of these things before we were able to determine that residual effect of primaquine on patients who are G6PD deficient. So this figure here shows the population curves for their linear mixed effect models over the first 42 days for chloroquine, patients receiving chloroquine in the blue line and patients receiving chloroquine plus primaquine in the red line. And you can see, and it's showing what their hemoglobin does over that time. So you can see that initially over the first 2 to 3 days, patients drop and they have a nadir. Interestingly, there's no difference between primaquine and no primaquine. Importantly, this is restricted to patients with greater than or equal to 30% G6PD activity, so their normal G6PD activity. And then both lines increase. You'll note that the red line, those that got primaquine, potentially increase even more than the blue line. And potentially this is because they're preventing the relapses that would occur without having received the primaquine, but I'll come back to this a bit later. We wanted to know, okay, that's fine, primaquine as a whole didn't seem to have an effect, but what about primaquine dose? Did that have an effect? Was high daily dose causing a risk of hemolysis? Again, an adjusted analysis looking at the absolute change in mean hemoglobin on day 2 to 3, and there was no difference between no primaquine and any dose of daily primaquine, but again in a population of greater than or equal to 30% G6PD activity. That's fine, this is all population-based stuff. The people we're worried about are the outliers. They're the people that have suddenly hemolyse, need a blood transfusion, or worse. So we came up with a metric to try and identify patients that had a big fall of hemoglobin and also had an event that was clinically significant. We chose a greater than 25% fall in hemoglobin to less than 7, so a measure that you'd often give someone a blood transfusion for. You can see here the numbers, very small numbers across the board that had this measure, including one patient who did not receive primaquine, but potentially a little trend there in those that had higher doses of primaquine having this event. Now, we've heard about intermediate G6PD activity a bit with tefenoquine, and there's a concern because our G6PD is X-linked. You have heterozygous females. Heterozygous females have 2 alleles, a deficient and a normal. Depending on the lyonisation process that occurs, they'll have a variable amount of G6PD activity. And so there's the potential for heterozygous females to have an intermediate phenotype and have quite significant hemolysis with primaquine. So we explored this a bit further. We had 1,600 patients where we had quantitative G6PD activity, and this figure shows G6PD activity as a percentage compared to day 2-3 hemoglobin. And you can see that those patients that had less than 70% activity did have a reducing hemoglobin on day 2-3. Again, if we actually look at the severe events, you'll notice they're very small numbers. No males in this 30 to 70% region had these severe hemolytic events, and that would make sense given that theoretically males should not be intermediate. These are probably the ends of the normal curves of the normal males. But females, even though it's only a small number, but 2 of 16 females who received high daily dose primaquine did, in this intermediate category, did have a severe fall. So, concluding from all of this, what can we say? Well, high total dose primaquine is more effective than low dose primaquine in many regions. Now, just a note that in Australia, in the US, in the UK, standard treatment is high total dose primaquine, but that's because routine G6PD testing is done on all patients before treatment occurs. We can say that increasing the total dose to 7 milligrams per kilogram globally would reduce the risk of vivax recurrence by about 55%, but there's individual and regional variation. This is based on endemicity, parasite phenotypes, potential patient adherence, and CYP2D6 genotype incidence. There's no increased risk of hemolysis with primaquine in patients with greater than 30% G6PD activity at the population level, and no increased risk of severe events in these intermediate group of G6PD patients at the low or intermediate daily dose primaquine, but potentially there is in high daily dose primaquine in females. Now, coming back to the question I sort of pointed to before, in that figure of haemoglobin over time, the group that received primaquine seemed to have a higher haemoglobin after 42 days. So we wanted to assess this more to see that actually is primaquine good for your haemoglobin rather than bad. We're always worried about it causing negative effects, but actually is it good? And so we pulled together studies that had a longer period of follow-up. So they had at least 90 days of follow-up, and they followed patients through multiple recurrences. So not just the first and then censored and stopped, but they kept going. There's less studies that do this, but we pulled 8 studies with around 4,500 patients. And 2 figures here. The first figure on the left shows what happened to people's haemoglobin over the 180 days, and the black line on the bottom is those that did not receive primaquine versus those that received low total dose primaquine on top. You can see they did have an increase in their haemoglobin, but it was pretty minor, 0.2 grams per deciliter. I'm not sure if you'd call that clinically significant. Probably wouldn't worry me in the hospital. On the right-hand side, it's those that received high total dose primaquine versus no primaquine, and they had a bigger increase. They had a 0.5 grams per deciliter increase. Again, this is over the population. This is a population level. We looked at this slightly differently, so we looked at the rate of anemia over time, and there was no significant difference in the rate of anemia when low total dose primaquine was compared to no primaquine, but there was a 40% or close to 40% reduction in the rate of anemia when high total dose primaquine was given compared to no primaquine. So at a population level, primaquine treatment, especially high total dose treatment, does lead to higher haemoglobin likely through suppression of recurrences. I'm going to change tack now because and talk about the second application of this data. So these data sets. So because the data sets are so large, we're actually able to look at individual or smaller populations that we wouldn't usually be able to do. The first thing we did was a study with MMV where we looked at primaquine in children and paediatric doses. And the take-home message here was that the similar overall pattern to the global analysis where higher total dose was better than low total dose, but this was even more marked in children less than 5 years of age. And you'll note that this is a story that I've already told you at the start with chloroquine, a different drug, but the same story. In young children, giving more seems to be the best way to go. We also, in discussion with national malaria control programs in our region, a lot of countries were very keen to know what their local data were. They said, that's fine, that's the global data, but what about us? And we want to know, before we change policy, we want to know what our data is. And so we've undertaken a few regional and country-specific analyses. The first one that's been published was in South Asia, and that included India, Nepal, Bangladesh, and Pakistan. I'm currently undertaking 2, one in Ethiopia and one in Indonesia, and we're undertaking one with collaborators in the room at the moment in the Americas. And again, this is looking at milligram per kilogram dose effect on efficacy, safety, tolerability of primaquine. We've taken this a step further, and we've sort of developed an app, an R-Shiny app, where we can actually look at this for any country within the data set or any group of countries or any region that we choose. So you can choose on the app which country you'd like to see, and it will output a report. And this was done, I did this with Peter Edler at the University of Melbourne, and creates a standardised report. There's a short report, a 2-page report, and a longer report if you're interested. The plan is to update the systematic review twice yearly, curate the data, and input it as it becomes available. And hopefully this will be open access online by the end of this year through the WARN website. And then the final aspect I wanted to talk about is there's an opportunity to really standardise data and to feed back into the whole process, so that not only are you standardising trials and standardising methodology, you're standardising outcomes, but you can feed that back and then you get better data through the next time. And so the whole process just reiterates. As part of this, and as a slight offshoot, we also have the ability to look at other ways that trials could be improved. And so Dr. Ihsan Fadila is a PhD student in Indonesia, and he's looked at methemoglobin, which is something that I don't think we've talked about in this meeting thus far. Now, methemoglobin is a side effect, so you get an increase in methemoglobin when you take an acetaminophen, whether that be tafenoquine or with primaquine. And this causal framework sort of explains some of the thinking behind it. So basically, primaquine and tafenoquine are prodrugs. They're activated to undergo metabolism and become active metabolites. And it's those active metabolites that have the anti-relapse effect, but they also have the hemolytic effect. Now, as a potential byproduct, they cause methemoglobinemia. And the question is, could this be a surrogate endpoint for relapse? There's a couple of studies that have suggested this is the case. So Ihsan pulled together data, 1,700 patients from 8 studies, and you can see this figure shows the daily primaquine dose versus the day 7 methemoglobin. Now, as we expect and as we know, as you increase your primaquine dose, your methemoglobin level rises. That's to be expected. What he also showed, though, was that there was a correlation between the risk of recurrence and day 7 methemoglobin. So a doubling of your day 7 methemoglobin was associated with a 30% reduction in recurrence. So methemoglobin is potentially a pharmacodynamic proxy for these active metabolites and can potentially be used as a surrogate endpoint for recurrence. It doesn't work for an individual patient. You can't say to an individual patient, oh, you had a methemoglobin level of this, so you're not going to get a recurrence, because one, they're too noisy, the measurements, and two, any one patient may or may not have a hypnozoite hiding in their liver. But there's certainly, he's simulated this, and there's potential for this to be an outcome for clinical trials, which may reduce follow-up time. You're only following till day 7 rather than 180 days, and potentially reduce the required sample size and obviously the cost of trials. So in summary, we've got this massive data set. Lots of study groups have been formed. There's been lots of publications. It's been able to be used to standardise methodology and standardise systems. And it also has led to guideline change and reduced malarial morbidity. I haven't talked about tafenoquine, and we have done some work with tafenoquine, but I think the work with tafenoquine will probably be in the future as more and more data become available, and there's the ability to look at subgroups of patients, look more in detail at safety and efficacy. And I guess I wanted to really stress home the point that the data from a clinical trial that you might be involved with or undertake doesn't end when the clinical trial is published. And there's so much more that can be done with that data, and it can be so powerful. And you shouldn't feel afraid of that, because it really can do a lot of good and a lot of benefit for the patients that were originally in it. So with that, I'd just like to thank everyone that's involved with the work that I do, a large number of people in the room and outside of the room. And thank you again for having me speak today.
Muito obrigado. Rod, I think.
Thank you. I guess.
Gisele? We don't? We're late because we started late. Can I open up for 2 questions? Forgot to say, it's a pleasure to be in Belém. It's my second. É prazer estar em Belém, a segunda cidade favorita.
Second favorite city in the Amazon. And the first is Cruzeiro do Sul, and we have two questions. So as we wait.
And congratulations on the work. It's extremely hard just to deal with one data set. I can't imagine dealing with multiple data sets. So my questions are two to you. One is, how do you build trust for people to share their data? Because I think this is a concern from a lot of countries. I have worked with a lot of countries, and we know that this is something in the back of our minds. Second, how do we demystify and have better studies like that out there if that's possible? So how do we improve, so to speak, the quality of the studies? Not because the researchers are bad, but because there is always a lot of update, and there is a lot of these new technologies, metahemoglobin, and everything that you propose here. But how can we foster, or are we fostering a collaboration of also improving the quality of the study designs? Thanks.
No, thank you. I think the trust is a critical factor, and I think there's a real risk of this being seen as people coming in and stealing data and not giving back. And so I think it's critical that the investigators are involved in the study and that they feel that they are part of that study. That provides an opportunity, one, for the study to be better, because you're not people aren't taking data from an online system, not in contacting the investigators, and not actually knowing what the truth was behind the data. It allows a back and forward, so if there's any clarifications that need to be done between the data sets, it allows the metadata, so the actual what happened with the study. Did you give food? Did you not give food? All of these sorts of things to be asked. And it allows a benefit for all. And the truth is that there's no point in doing the studies unless you're going to get impact from the studies, and it's going to be feedback and actually make differences in policy and change outcomes for people with malaria. So I think that that's absolutely critical. The other question is tricky. I mean, overall, I think it's a slow process, and a bit like drug development, nothing's fast. But I think the more that you're involved with a group and that there is a collaboration, then there's better relationships. It also allows an opportunity, and WARN has this, there's lots of tools online where people can use them to set up their studies, so there's pre-existing protocols and pre-existing things like that to try and help standardise systems. We've been involved with trying to standardise definitions for hemolysis. But again, it is a slow process of collaboration and building trust, I think, between researchers.
Thank you. One quick question, Gisele also authorized that.
Bom, primeiro, parabenizar o Rob pela palestra fantástica. Obrigado por ter vindo até aqui, é longe. Depois, para deixar meu depoimento, a primeira vez eu fiz estudos clínicos em malária com o Délio e outros colegas que estão aqui, e a primeira vez que me falaram, deposita seus dados lá com os ingleses, eu falei assim, nem morto, né? 10 anos depois, eu fiz logo em seguida de eu ter feito as análises, eu fiz os depósitos, isso já faz 10 anos, e eu continuo colaborando, acho que isso é uma iniciativa fantástica. A gente na FIOCRUZ está fazendo parecido.
I have been collaborating for 10 years, and at FIOCRUZ we have been doing that. There's this open science topic. So, Rob, just a quick question. Theoretically, we are having analysis with secondary data. On the other hand, from the moment that you analyze CRF and collect data in a standardized way, and when you do meta-analysis individually, the data was collected for that ending. So how do you see that result in terms of level of evidence? Because it's a research with secondary data, so it wouldn't be the biggest level of confidence, but if we have a collective work for this kind of collection, so wouldn't it be higher? Wouldn't it have a higher level of confidence?
I mean, if you think of your level of evidence, you know, you've got systematic reviews and meta-analyses right at the top. And there's an argument that individual patient data meta-analyses are right at the top there because you can actually get that granularity. Saying that, as you pointed out, sometimes we're analysing questions that were not the intent of the study. And we're also using indirect comparisons because we're using data from one study that may not have directly been compared to look at something. I think the benefit with using doing the analyses that we've done is that there's also variation within studies. So we're looking at the milligram per kilogram dose. So even within a study, you get variation that was not looked at within the original analysis. And so there's certainly risk of bias, as there is with any study. But I believe that there's power and ability to account for that bias that means that it does have a very high level of evidence beyond, say, a single randomised controlled trial.
Thanks a lot.
Agradecemos aos senhores pesquisadores. A nossa foto, registro de foto oficial, por favor. E assim encerramos essa atividade de mini conferência. E já seguindo ainda com a nossa programação, conforme o nosso...
According to our plan, we will begin the roundtable Science of Data and New Technologies, Innovative Technologies in Malaria. We invite a researcher of Tropical Medicine Institution, Dr. Heitor Vieira Dourado, Daniel Barros de Castro. To moderate the activity, we invite researcher of the Federal University of Pernambuco, Patrícia Takako.
Bem, com muita honra que a gente inicia essa mesa redonda com um assunto extremamente importante para a atualidade. E eu quero convidar para cá os palestrantes. Wanderson Sampaio, por favor. Também o Klaus Garcia, por favor. E a Patrícia.
And the third speaker is Patricia, who is already here. And now to begin, Klaus is going to start speaking. Just to have a brief presentation, Klaus is a consultant in epidemiological data of the Secretariat of Surveillance and Health of the Ministry of Health. Good afternoon or good night, good evening. Good evening, everyone. I am representing here today a research we did, an analysis, a reflection that we made in partnership. I really have only 5 minutes. So together with FIOCRUZ and PAHO, about some possible innovations that we might think about for control of malaria and in the context of elimination. So taking advantage of what was said by Roberto Montoya, we need to think differently, which doesn't mean that what happens today is bad. We have to think about strategies that can promote different strategies. The process of elimination of malaria, especially when we talk about Vivex, it takes a long time. So what can we do when we are talking about a continental country where we have different social vulnerabilities that have an impact on each city and state of the country? So thinking about it, the innovations are alternative and reform, update, promotion, improvement. And we have 2 different scenarios for malaria in Brazil. This is the Amazon, and nowadays the system of information of malaria. We have CIVEP malaria for the Amazon region, and Cena, which is for the extra Amazon area. They work separately. So remembering what is the process of notification like, the agent, the notifier, they fulfill a form. Any information of this form feed the system, and from the feeding of from this information, we have an analysis, and the system makes it very well. So we have two forms. The most updated one was updated in 2020, and Sinan is 2010 form. So we have they are different. So along years, CVAP Malaria had some updates because of the advance of malaria in Brazil. So some fields were added to that 2003 form. And among them, we can see, for example, routine of testing for G6PD. And more recently, there's the adaptation in the process of how we insert information regarding treatment, especially those, we have a point for tefenequine, so we understood it as a process of innovation. Regarding the process of notification, it is very common to have the printing of the forms. So when you're getting the information about that patient, you fulfill that form, and it is sent to a typist. That person types the information on that form, and it's online, and it's distributed to the different layers, city, state, and country. So it happens in real time. However, from the moment that you fulfill the form, so until that form is on the table of the typist, this can take days or even months. So we made some analysis on those scenarios. So you can see that in the last few years, in some months we can have in the entire Brazil 20,000 cases of malaria. So we are talking about lots of different notifications and cases in Brazil. So this is what happens the moment that you fulfill the form until the moment that it's typed into the computer. It takes some time. So it takes 10 days. Theoretically, it's not too much. However, if we see the behavior of the notification of this period, 99% of these notifications happen until 135 days after the fulfillment of the form, and some of those until 120 days. But still, 3 out of 4 forms are typed until 135 days. So depending on the area you're doing this investigation might not be so adequate. So when we take a look by state, you can see that Roraima, Pará, and Tocantins have a mean of time, and this process can take a little longer. So if we take a look at special places in indigenous lands, we can have a mean of 30 days from the moment that you fulfill the form, that you fill out the form, and until the moment that it gets into the system. So in 2021, this average varied. So if you can take a look, you can find notifications that are inserted into the system in up to 90 days. So in the mining sites, the average is similar to the other notifications, 10 days. With this scenario, we begin to think what could be done, not only about opportunity and notification. So if we could have a system that took advantage of better opportunities, what would that be like? So if we had a digital module or in a smartphone, smart device. So in this process, we thought, can this have an impact on the quality of data? So searching for the literature, we could see that countries that used new methods of notification gained quality in data. Is this interesting for malaria? Yes, maybe. Because in an average of all of the notifications, we have 9% of ignored information. 6.4% of ignored information when we're talking about occupation, and we know that this has an important influence on the absence of work, and 48% of the information are not specified. So there is still half, 1 and 2 occupations we do not know what they are because they are marked as others. So there's the process of location. So when we get into the northern region, there are some information that are lost. They're not filled out. So we might have, for example, the date of birth or name of the person that is misspelled. So this is important for the epidemiological studies when we're talking about that cycle. And in this cycle, if we think about a device, and at the moment that it is connected to the internet, instead of using paper, does it accelerate this process? And does it decrease that time of, for example, 30 days? So this can prevent outbreaks, and it can improve the process of surveillance. And in cases of, for example, the internet's not available, these devices have enough technology to become data repository so that in the moment they get connected, those data can be sent. So, but it's not very different from the computer. The problem is until we get to the typist, sometimes it takes 1 month. So sometimes an outbreak is happening, so CVEP does not detect that because of that time. We know that the Amazon has different ways for things to happen. So what would be the result of it? We have not only CVEP or Cena, but we have the system of mortality, of information, lab systems, and these systems do not talk to each other. And because of that, we have to have other strategies such as record engage. So in other researches, we could identify a number of patients that evolved to death. But there are limitations of this method. In this research, for example, we found 44% of the deaths that were investigated only. So it's still about that. Only 30% of them had the name of their mother, date of birth, patient's name, typed correctly in both systems. Only 1 in 3 registrations we have these data filled out precisely, which makes all of the process of investigation harder. So besides that, when we're talking about deaths, there's not a specificity of the diagnosis in some regions. So when you use those strategies, you can again include it into the process of surveillance. So there is this table. Please, somebody help me with this, please. So 1 in 2 deaths by malaria, when it's not specified in the declaration of death, one is for most falciparum and the other one is by Vivex. And in the death certificate, it's it says B54. It's identified as B54, which is unspecified malaria. So it's not specified. So because of a number of challenges that we have in the process of surveillance, we have this idea that if we work with a digital module in which you are not dependent on a computer, where you can insert these surveillance data, in this case, in a more intuitive way, sometimes on the palm of your hand, we could gain some things. For example, we could insert the CPF of the person. That would improve interoperability between systems. We could ask if that person that had malaria, if she was infected before. And these are sometimes questions related to the smart device, and it's an improvement of the notification. So we could accompany if after receiving that case of malaria, if she's going to have a recurrence, or if it's going to be leading to a death. So the process of surveillance and elimination of malaria will not end when we offer a medication. We can have different scenarios. So besides that, we could also work with an integration of the different systems, for example, CVEP and Cena, because there are difficulties when we work with it nationally. The integration of data. We're talking about malaria, okay, 99% of the cases.
Então, o quão interessante seria integrar esses dois sistemas para que o programa como um todo possa funcionar melhor. E aí nós temos, para dizer que a gente não está trabalhando com cenários completamente hipotéticos e utópicos, quais são os principais desafios para isso? Recursos financeiros, investimento financeiro, investimento de recursos humanos, porque a gente precisa de pessoas para trabalhar nessa construção desse novo módulo, treinamento desse novo módulo, precisa dos recursos para adquirir esses smart devices. Nós precisamos passar por todo um processo de teste. A gente não simplesmente cria dizendo se funciona, se não funciona. A gente tem que realmente implementar e, assim, entender também quais são as áreas prioritárias, até porque isso pode não ser viável em toda a região amazônica, pode não ser viável na resta amazônica. Isso é realmente pensamentos que nós temos que ter, discussões que precisamos fazer, justamente voltando de novo naquele comentário do Dr. Montoya. O que a gente precisa fazer de diferente para a gente conseguir continuar caminhando em rumo à eliminação. E, bem, é isso. Muito obrigado.
Som. Próxima apresentação, então, do Evandro Sampaio, que é pesquisador e diretor do Instituto Todos pela Saúde. Por favor, Evandro.
Obrigado, doutor Daniel. Eu vou tentar responder uma parte da pergunta que o Cláudio deixou no ar, né? O que a gente tem que fazer de diferente para começar a pensar em eliminação. Bom, essa história que eu vou contar para vocês aqui, ela nasceu dentro do Instituto Todos pela Saúde, onde eu trabalho agora, e obviamente ela nasceu dentro de um contexto diferente, né? Um contexto de Covid-19. Isso, no final, vai culminar numa ferramenta que a gente apelidou de SAVED, que é o acrônimo para o Sistema Automatizado de Vigilância Epidemiológica Digital, que já tem uma ferramenta que já está implementada em pelo menos 50 municípios do Brasil em fase de teste. Então, eu vou começar a história.
So let's start this now. Back to front, presenting the tool. We'll tell how the story started. And in a little bit, I will explain what this has to do with malaria. Don't worry, it's got a relation. So then, in the midst of the pandemic, you probably remember we went through an episode, a dramatic episode and Public Health in Brazil. The Ministry of Health at the time was supposedly suffered a hacking attack or something like that. At that time, we had a scenario where we were orphans. We were left without reliable data for decision making. There was a rearrangement at the end. The SUS, the National Health System, is great because it's big, and so we were able to equalize this situation. But then we noted that there was a greater weakness in this process. In other words, a simple hacking attack risked us to losing a program of making data available, very major data program. We started internally to think about potential sources, alternative data sources that would allow us to have additional systems for alerts for infectious diseases that could become epidemics. And then we went to try to investigate the electronic record system of health units as a potential source. So in this, where's Gabriel to help me to use this, to teach me to use this? So this QR code here, you can access this article where we discuss a bit about this idea and to try to do a proof of concept, trying to demonstrate that in fact this source of data, electronic records, is very rich, even though it's not a structured source of data, which is an ideal database, such for example, systems, official surveillance systems. In fact, it is a source of free text. So it's a medical record, and so the nurse, the doctor describes the findings that they find in the exam, but they also have signals and signs and symptoms. So we also thought that maybe if we applied some computational methods, we would be able to extract from there a set of terms that might make reference to some syndromes. And so we're thinking about an application of syndromic surveillance based on medical records digitally. And then we did a sort of proof of concept using testing for febrile respiratory system and compared this with the temporal series of positivity tests for COVID, because that was the respiratory symptom that we had predominant at the time, and then we could observe the fact that there was a major similarity between the two temporal series, showing that the application of this would be possible and the sorts of generating alert signs for the beginning of an epidemic of a given syndrome. So then the idea of the project in general was for us to allow us a decision to make decisions. The idea is to have a system with high sensitivity. We're talking about syndromes and not diseases. We're not looking for specificities as something primary, but a sensitivity as an alert system. And this would be applied to any place where you had electronic records, and more than 96% of the basic health units today have electronic records. And this generates a database that's available in real time. So we have a source of data that even though they have their problems and not structured, this allows us to generate this information in real time. And based on this processing, computational processing of a program for classification that we say would be simple, the rest is basic statistical visualization for us to work within the aspects of epidemiological field work. So then we thought about other potential sources generating alerts, and one would be data that we call the level of occupancy. Many of you probably use this daily. This tool from Google they call peak hours. So then we'll look and see how the bar here and so forth here on Presidente Vargas. So let me see, where is it? And then Google shows you this graph, a bar graph, that shows you if at this time, exact time now, the level of occupation of that place is above average, is below average, or on the average. So this allows me to decide if I'm going to go there, or if I'm lazy, don't want to face lines. So what did we do? We started to collect these data systematically from basic health units and emergencies and pharmacies. And creating this historic series, we have a pattern for each unit. We collected for all the state capitals in Brazil so that we're able to monitor today almost in real time if we're having an abnormal increase of people looking up these units, which one might lead to an increase in the need for public health services that would probably be caused by an increase of a certain disease. So this is a first level of signal. Obviously, it's very sensitive, it's not very specific, but only makes sense if it comes together with the other two, which is syndrome monitoring and a macro syndrome of diseases that are predominant in terms of pathogens that are predominant at this moment in Brazil. So this is all involves a series of processing stages. I'm not going to go into much detail here, but the fact is we're now preparing, but we described these findings, and they're showing that this level of occupation is capable in general to predict, at least in this scenario in São Paulo and in the estimated scenario in Brazil, to predict 2 outbreaks that we had of severe acute respiratory syndromes in Brazil and São Paulo, and I won't give you the details of this. So then we got the level of occupations of several health units here in this example in São Paulo, and we wanted to know if this level of occupation was varying very much in terms of geographic location of these units. And then what we observed is no, this level of occupation was in normal time, shall we say, it's more or less the same in all the units, which makes us think that maybe if we were to monitor, maybe we don't need to monitor all the units, but just some, in terms of the, so just to show the temporal assignments. So then there are 2. Wow. It's artificial intelligence. So there's 2 waves of the outbreaks of respiratory disease that we used as models to compare with the level of occupation. So then we apply dynamic time warping DTW to see if the curves were similar. We made 2 comparisons, the level of occupations with the respiratory disease in general, and another one, especially with SARS-CoV-2. And so then, in fact, there's a similarity, the temporal series. And more than that, the temporal series of occupation was able to anticipate the other 2 curves, respiratory pathogens, and especially in terms of accordance with up to 6 weeks beforehand. So transforming this story into a short story, we, in 6 weeks, would be able to predict a number of cases of respiratory symptoms in this case. So then at the time, we were using a computational technique that was very simple, which is regular expression, but basically we seek to specific parts of terms within this text of the electronic records, and we convert those in a set of tokens, and we have a definition of case for each syndrome. So if you've got a group of tokens, it means that that is a respiratory febrile syndrome or asymptomatic syndrome or febrile or diarrheic or so on. And then obviously we've advanced, and there's a parallel to remember that this is being implemented in some municipalities, so it's using so far this technology from the top. In parallel to this, we're developing a map using LLM. This Kai's explained earlier, it's an algorithm for an artificial intelligence, which is popularly known as generative artificial intelligence. Translating this into more popular terms, we'll create an API, which is type of black box, where these text data will come in and go out and be classified in a set of syndromes. This is in the testing phase. We want to make all this available here. We want to make this available free of charge for use within this unified health system. It's a nonprofit organization, so the idea is not to sell this, but to offer this as a service to the community. And this API also will be a service offered. So For those who don't want to, if you want to use the system but you have an electronic records, there's an IT people who want to develop their own visualizations. They can use this as a service. So there's a series of things, then complex things here of LLM that I won't be looking at too much. But the fact is that we've implemented this tool. These are some cutouts of screens for discussion, obviously. Obviously, there's limited access because of the surveillance people in each state and municipality. This is a system where the client, the main client, is the decision maker in terms of surveillance, the states and municipalities. And then from the post, we do this classification point using a triage screening of people to do a temporal spatial distribution and demographic placing to generate some alerts using these situations you're seeing here that generate quite rapid visualization. The idea is the decision maker doesn't need to figure around, and so then we don't need to understand. So Vanguard, if it's green, it's good, red, it's bad. So you'll click on red, which is what's most interesting for you. And this system also generates an automated report. So here we're also using generative artificial intelligence. Basically, it's this model that reads everything that's generated from zeros and produces a graph. And this report can be modified by the user, and it's generated, but it's not automatically published. But it can be published after the PDF format or sent by the network, by WhatsApp, and the decision maker, whatever they think is most interesting. It's a panel that generates from monitoring. It's not enough for it to be generated automatically. Someone has to make a decision. So if the report was generated but nothing was done, they have a marking in red. If it was generated and analyzed and published, then it's marked in green. But what does this all have to do with malaria? It has to do with us to think that maybe we could go beyond the syndromes and focus on greater specificity to talk about diseases. And obviously, since I have this story with malaria, I thought first about malaria. But what happens is in 2017, Andre and Sheila here, and Marco said, hey, look, if we want to move forward and eliminate it, this is in 2017, said we need to think differently and maybe think about monitoring febrile symptoms would be interesting. With this, initially thinking about this, we started to, in fact, improve this algorithm to reduce not febrile symptoms only, but also malaria, using the same logic that I explained, LLM applied to text. And so then we started to evaluate temporal series, time series. Here, remembering these are time series, and cases of supposed malaria, supposed identified here. So then we started to compare these curves between the system for predictions with CIVEP, thinking about, in general terms, for malaria in general, and thinking species by species. And so obviously, we had difficulty in doing this with falciparum in Manaus because this was all done in the Manaus scenario, okay? Because the number of cases of falciparum in Manaus, fortunately or unfortunately, unfortunately for the model, fortunately for the program, it's quite low there, so it's hard to work with a temporal series when we only have a few dozen cases. So we did this for malaria in general and for Vivax malaria separately, and basically what we identified, once again transforming a long story short, is that this model is able to predict also with up to 6 or 7 weeks beforehand of lag time, increasing cases of malaria expressed in CVEPs and the official system for notifications. So we applied the same techniques that we applied in the comparison with respiratory syndrome, and we found very similar results. And so here we have a series of things that we still need to do to normalize the series, eliminate noise and temporal series. Those who knows that it's not the simplest thing in the world, but then we understand that this is a result, a promising result that's worth investing in, and we did the same thing for malaria in general and for Vivax malaria. This malaria in general for forecast would be similar, between 6 and 7 weeks. So then also for the next stages, we have a colleague of ours is developing and testing the accuracy to identify, not comparing temporal series, which is something more ecological, but trying to see the accuracy of the model at identifying cases of malaria using medical records and seeing how much this model is capable of, in fact, detecting case by case, no longer temporal series. So we are in the development phase, as we mentioned here, in the LLM. The idea is to have separate models for different purposes. So we'll have a model for detection of malaria. The launch of the system, the deployment of the system when we're ready, and then maybe to capacitate and train people. This interface of the system would be, this is the interface of the system that was developed for Manaus using electronic records from the Tropical Medicine Foundation. You can access this using this QR code. This is the interface, and we don't yet have data of level of occupation for Manaus. We started monitoring this recently. And in terms of basic data, we only have from electronic records from the Tropical Medicine Foundation. Here are some visualizations. Once again, time, the triad, person, place, and time. So I'll go here. I will show how this works because there's nothing funny, in fact, here. Really, the data go into the computers. But then I will jump this so that we can go. This just to show the time and consumption, computing consumption this requires. And so this is something, the computing costs. We have a local server, which I consider as very robust, but we did a recent test on it. But it didn't work out. So then we need to improve these models. So then we have some enormous difficulties as that we receive different sources of data. Each electronic record that comes from a different place comes in a different format. So we have very hard work here to adjust data. We also have difficulty in Brazil to understand what is LGPD, the Brazilian data protection law. Many people haven't, I've heard it, I don't even know where it comes from. People don't really know about it. They think that this law is a bank vault that opens up for everyone. So when in fact it's a door that you can open doing everything appropriately, but we have faced many problems with this type of, there's people who think that LGBT prohibits everything. Oh, that's not it, right? So then we still have a series of difficulties of transfer of the data in real time between systems. We have very positive experiences with the municipal government of São Paulo, which developed an API that connects with the system and it works very well. And to cite two very distinct scenarios here in the municipality to send Excel files and a cloud. Both work, but first case is much more appropriate. There's to have a person involved. Should have it all automated. This thing, computing costs. Yeah, right now, the Institute is funding all this I've shown you here is like what we call software as a service. So then all computing costs we assume, so we don't know how long we can handle it. This is the team involved in the work. Everyone is our employees for ITPS. One was the one who is dedicating most to these analyses. And I'd like to thank all these institutions. We're conducting this project together with the PAHO, Pan American Health Organization, and CONASEM, who was our first partner here, and CONAI, FIOCRUZ as well, and some health secretariats. This is just outdated because we already have many other partnerships with other secretariats, and paying our commitment of 000. That's it for now. Thank you very much.
Thank you, Vanderson, especially for being on time. Now, Patricia Endo is the professor of the University of Pernambuco. Thank you. Good evening. It's always hard to be the last one after everyone, so I hope that you're not too tired at the end of the day. So I have 3 minutes left here, but okay, I promise to be a little bit faster just so that we can talk to you I know we're late, but I have to thank you for your invitation to be here. I am a computer engineer from the Federal University of Pará, so I've been living in Recife for 20 years already, but I was 20 years here in Belém. So for me, it's an enormous joy, and when I was invited by Wanderson, I thought it was very good to come back and to feel this warmth here in Belém. So let's go. Not to in the University of Pernambuco, I am a leader researcher of .lab Brazil, and our focus is on neglected diseases. So malaria is one of them, and neonatal and maternal health. I have a background on engineering. My master's and doctor's degree was on computer engineering. This is possible because I have partners and I know about the importance of having people that understand the problem on a daily basis. So I would like to thank Wanderson because he was the person that said, let's do a good job. Let's connect health and data and technology. So we've been working together since 2018 and together with ITPS, FMT, UEA, Faculty of Nursing, Hospital of Women in the state of Pernambuco. So it's very clear for me that all of you know a lot more about malaria than me. You know about the challenges of malaria better than me. So that's why I need partners like you that understand about the difficulties on the problems of health so that we can use informatics as a means. So my objective is to use artificial intelligence to solve the problems that you have to solve on a daily basis. So in a very simple way, we can take a look at the health of human beings in these squares. In a very simple way, we try to look at prevention. We try to avoid these diseases and these epidemics to happen, and we won't be able to always have that. So people will get sick. We have to diagnose those people. We have to understand what is the disease that these people have. And once they're diagnosed, these people need a proper treatment. A lot of the times, this treatment is not protocoled. It's not standardized, and the idea is that we can improve the lives of these patients. And once again, once the treatment begins, we can accompany that patient so that he can recover faster and have a better quality of life. So, in a kind of arrogant way, we have to use AI in all of those aspects. We have to understand what challenges we have in all of those squares and phases and use artificial intelligence on our favor. I guess we have a lot of discussion on this topic. Oh, now everybody wants to use AI. But yeah, we have, specifically as a research group, we have a purpose that is much focused and we want to apply AI on the practical terms. So we can look at the specificities and limitations of the tropical diseases that are neglected. So I brought some examples before talking about malaria, and now I'm going to discuss diagnostics. We have a project, Valeria, and we have to have a clinical diagnostics that is more accurate. So Brazil is one of half of the diagnosed cases with arbovirus have lab tests. So 50% of the cases have only clinical diagnosis. So we have many difficulties about the diagnostics of arboviruses. The symptoms are very similar. And so we developed was a project of 4 years in which we looked at how we can help the doctor to have a more accurate diagnosis about arbovirus and to help with the epidemiological surveillance and so on. Despite SUS being wonderful, Brazil is a giant country, and it's hard to have available tests to test for dengue or chikungunya all the time. So if we have more precise tests, we will be able to help with the surveillance of these diseases. So today we have Val devoted to this classification and aid with the arboviruses diagnostics. So we have 2 projects. One is Tetteh that works with tuberculosis. Our focus is to work with people that were diagnosed with tuberculosis before and that have a higher probability. Literally speaking, the model learned a probability of death. So I guess it's not okay to look at the probability of a patient to be dead or not, to become dead or not. So I know that this patient has 92% of probability of to die. So what does this mean for the doctor? So he said, I want this model to be wrong. I want to apply actions that might say, look, Tito had some mistakes, so I need a more personalized treatment. Maybe someone can pay a visit for this patient once a week. So I don't know, but the public policy field is a great one, but the idea is to give a tool for to support the decision-making process in the case of tuberculosis. So if I know that this patient has a higher probability to abandon the treatment, which we know is long, so we can think of alternatives for that patient to follow the treatment, continue the treatment, and to be cured of tuberculosis. So we have also the Hansen AI project, and Hansenitis is a stigmatizing disease, and we think that we don't have any cases of it in Brazil, but it's been a long time that Hansen's disease, sorry. So Brazil is the second country in the world with more cases of Hansen's disease. And we have this project in which we use artificial intelligence and we can see the probability. We can subsidize new ways of treatment and we can make him go for a better physical therapy. And we also have the follow-up. We also have follow-up and rehabilitation. And I'm going to focus once again on Val. It has a new phase, and we are focusing on chikungunya now. I guess here and in Recife, everybody already had chikungunya or dengue, so we know about the consequences specifically of, especially chikungunya. So people have chronic pains for the rest of their lives. So we had a partnership with Replique, which is a program of the Federal University of Pernambuco focused on the treatment of people with chronic chikungunya. And our idea is to have also the probability, to say the probability of a patient that already had chikungunya to have actually chronic chikungunya. So this can help a better decision making for treatment. And at last, we have an analysis of risk part, analysis of alerts. And here I have a specificity. We have Angels and Sophia, which are focused on neonatal and maternal healths, but I've brought also Malaria here to cover the the project of malaria. So we have to understand what we can do with the data analysis so that we can prevent and generate alerts of possible epidemics and risks of pregnancy, and just so we can focus a little bit more on malaria. I guess on the previous roundtable we had Kyle talking about his PhD project, in which we have a background based on artificial intelligence models on malaria. And I want to highlight the importance of having scientific methodology that is robust. So we began in the Amazonas state, and then we went on to the legal Amazon. So we need a scalability. Also, Vanderson said that we need resources, computer resources to run these models. But here, something that I wanted to highlight to you, we think where we are going to treat these neglected diseases. So we cannot think that in those places we are going to have very powerful computers. We have to take a look at reality. So these projects that I presented to you, all of them are models that are light. This was something, a non-negotiable for us, and all of those you don't have to use internet to run them, and we won't be able to implement these on practical terms if we have complex things. So comorbidity, symptoms are kinds of information that we have here. Sometimes we will have places that do not have lab analysis. For example, blood exam. When I run this model, I won't have that information of a blood exam. So we thought a lot about how we would produce a final solution so that it would be a viable final solution and plausible to be used where we need. I'm finishing. And to talk about malaria, Caio already talked about prediction. And then maybe you can help me a little more. I had to understand a bit about oocysts. I don't know what that is. So you know it much more than I do, for sure. So they are structures that we find in the stomach of the mosquito, and after it got blood from the host. So we have to infer kinds of infection, levels of infection, and the efficacy of interventions. We have to count those oocysts that are in the stomach of the mosquito. So we have to dissect its stomach. Yeah, of course you know about it. So how can we count the number of oocysts? So we are going to dissect its stomach, and then we take a look at the plate, and we're going to take a look at kind of this, and we will have to be able to count with our own eyes how many oocysts there are on this image. I don't know if you did that already, but I used to ask people how long you're going to take to count all of those. So this is a very important job to understand the efficacy of the interventions and the level of infection of malaria, and it's a manual work that has to be made very carefully. But okay, we'll get there. So do you know how many oocysts we have here in this image? So we have a lot of challenges, right? Because this demands a lot of time. One plate, one mosquito demands a lot of time, a highly specialized human resource, and it's a human being. So sometimes we're cranky, we're tired, we want to go home. And so This process of counting oocysts in a manual way has many challenges, and it has the probability to have errors. So this is a very technical task. And for the human being, we have many difficulties because we have difficulties with processing. We cannot process things very quickly. But a robot, a computer, a machine does that for us very fast. So we can think, okay, AI is good for that. This is an extremely tedious job that a person has to do because they're doing their master's degree or PhD, and they're losing their time, kind of losing their time, giant amount of time counting. And we can train an AI model so that it can count all cysts for me. So we can use computational vision models, and this is a way to detect images, and it's going to learn, and then we can get many images of many dissected stomachs with different oocysts, and then we can have a model that is trained, and it can detect every oocyst, and it can tell me if that oocyst is myelinized or not. And so we get out of a work that is manual, boring, takes a long time, and we give this job to a robot. But a robot that it will think in a rate that we will get to know. We have 80% of accuracy. And the more images we give him, the more he will learn. He's not going to complain because he doesn't have to go home. However, there's always a but. But so we are going to use AI to update this process to make this process faster, and he's going to count oocysts. But we keep having challenges. So the first challenge is for us to train an AI model, we have to give him examples. Give it examples. So for him to be able to count oocysts, we will have to count oocysts for him. We call it labeling. So this is Jade's picture because she deserves it. She's a master's degree student, and we have to label it. So we had to collect a lot of pictures, and she had to label many pictures so that we could give the model so that he could learn. And these are the challenges. We have to label the bases manually. So you can see that AI is not going to dominate the world because there are things that it can't do. Maybe sometimes we could tell the AI, just give me the little balls, and so she digitalized the images with the microscopes, and I told judges that we needed different images. So the greater the variability, the better, because it's going to learn different things. Even if it's counting oocysts, the more variability it has, the better. So, okay, I won't be able to finish it on time. So we gave her some months to label it, and I'm going to speak about it very fast. So for us to work with images is a problem because we need computational capacity to train these models. Different from the models like Malaria, in which we have clinical diagnosis of arbovirus, which is very specific. So working with images is still a problem because we need computational models, and I guess this is a very clever way to use AI. Maybe this is a job that nobody wants, and when we see many mistakes, this is for a robot to do. So I brought this example to you. We talked about other projects that we have, which they're not related to malaria really, but we have to understand that sometimes we need to think a little bit outside the box. And this, oh, this is a tedious job. It looks like a robot-like work. So this OSIST kind of work, for example, will have an impact on different researches. So my time is up. We had different problems, and Jadi could solve lots of these problems. And I would like to finish talking about a tool to improve quality of life of these people. And I'm talking about a neglected disease. And sometimes we talk a lot about neglected disease, such as malaria, but at the end of the day, maybe we are neglecting the sick people. Us, as society and as researchers, we might look at AI as a tool that will help us improve the quality of life of those people. Thank you. If you allow me, I will have a role of moderator. So before we have questions.
Just a few curious points here about some of the things that were presented first, Klaus. You talked essentially that innovation really doesn't need to be artificial intelligence, but sometimes the quality of the notification, a change in the notification, forms of innovation can be an innovation. So, Klaus, what would be some next steps maybe that you're thinking about in terms of making some changes? I don't know if it's in your sector that's going to be able to make some changes, if it's in the notification or any pilot tests. And you also, when you make your presentation, you actually produce some insights of maybe doing notifications photographically of to adapt the forms for initiatives like this. So I'd like for Anderson to also comment. It's also about computational complexity, but then there are several problems that we need to solve. And could you maybe comment a bit about how long, and the size of the team that you took? You had some people there, but do you have companies contracted behind to develop this technology? Because have you been doing this for years? Or then also for Patricia, you showed here some tools that are already ready, Valeria. But I'd also like to understand about the availability of these tools. Is there any secretariat that's using this? Are there any efforts in this regard? Just for us to start off a quick round. Yes, thank you. I think it's good to just make an addendum. Curiously, I am from the Ministry of Health, but I work General Coordination for Climate Change, and I went through the Malaria program some time ago, and I continue to develop research. And so then this discussion, all these analyses, in fact, were done within an environment of research group exactly to be able to provide some oxygen for some analysis and prepare some alerts. So much that these research says in terms of the need for using the record gauge for perceptions they were able to see inside institutionally that are replicated in the states and municipalities. And then the result of these studies and these notifications that we identify that could improve the process for surveillance and also the process for research that's done. Whenever we work, we try to pass this along to the Ministry of Health because we have the whole network of research. It's very close to the Ministry of Health, especially the current manager. It's been quite open to these talks, but these perspectives then are very positive. And I never thought, in your question before, I thought about this together with the presentation by Patricia, this question of taking out the notification of how might this be interesting to follow this model that's already, where I was using to be able to identify all the information for notification and see how much you're able to notify automatically. So then I will even leave this for you to complement with this idea that we've been launching now. It's so good. I will answer the question from Danielle. We took a little bit more than a year and a half to have the system ready for the syndromes. It cost around $1.5 million in terms of the cloud and personnel and development. But part of the development was done by the internal team for those people there. And the prototype, I made the prototype myself at the beginning of the first year. In computational terms, we are migrating to the cloud for servers. So Patricia can tell us more about that. It's very expensive to have processed data in the cloud. It's expensive to transfer data to the clouds. So even this reverse movement to have local infrastructure. Now we need to have an average infrastructure. So we're able to have a server that I think have about 8 or 10 GPUs. When we stress the system, it seems like a drone wanting to take off. And so much heat that it generates, right? So we have all this to be considered. We have to adapt our infrastructure, physical infrastructure, to this new reality because it's a crazy temperature. So then a brief comment here, if you allow me, about what Claudia said. Nakai has a project which was funded by the Ministry of Ministry of Health. The objective was to train the model with photos of vaccine cards to fill in the automated vaccination system. It's a similar logic. I think notification maybe is even easier because the vaccine card is quite complex in terms of appearance because this little space has a lot of stickers, their letters are very bad sometimes. But I think a notification of compulsory diseases would be easy, peasy. Answer first questions. We also pay in this Hansen's disease project. When you have a diagnosis of Hansen's disease, there's a simplified neurological exam. It takes an hour and a half. An occupational therapist does it with the patient, and then it's all done by hand. It's a similar sheet film form that we have, and then today, in all of Brazil, it's done by hand. And so then the difficulty with this is we have a design of the hands and the feet, and we have to paint in with balls and with squares, with triangles, black, purple, red, which are the areas of insensitivity that we have. So today we have a project in a phase to digitalize this sheet, this form, and with a photo to scan it, it's a photo then, and we'll be able to automatically save it in a database and read the hand and the foot to save this information. So then I think once again, it's a very good form for us to use AI as you're presenting. And I said, wow, imagine if this boy who sits there typing away the CVEP sheets forms, it's for work for a robot. You don't need to have a human being doing this. So we have to think about, and so then with the application, it was the stream of the people. You see the apps, the information, the platforms out at the end, and the SUS, the single health system. We had angels who did all the follow-up, management follow-up. We did partnership with the program for many years. And when we implemented, the state government ended the program. So it was quite frustrating. And so the next month, we were supposed to go there to do training, get the system up and running. Now the program, we don't have it anymore. It's gone. So this Hansen disease program, we have a partnership with Otávio de Freitas, which is a reference hospital for Hansen's disease in the state of Pernambuco. We believe that we'll be able to get out to the end, and we have tried several partnerships so that in fact we can see if one day we have one of the solutions, then I'll be very happy. So I think we have any questions, so then we have time for questions. Congratulations to everyone for your innovations that you brought today, because This shows how much creative minds can save lives, each one in their space, in their niche. Patricia, I'd like to talk to you directly because you showed some platforms and that don't depend on heavy hardware and so on. So then I was curious to know how this happens. I don't know if it's through partnerships that you've begun in some way like that. No, because when I and Vanessa, when we talk about the computing power, we're talking about training the model. The model doesn't know anything. He has to have a bunch of examples. You have to have a million. And then we talk about this as training of the model. So this training spends a lot of time. And so then after the model learns, we generate an executable. It can run on your cell phone. And since our models use signals, signs, and symptoms, I didn't bring it here, but we have interfaces, graphic interfaces. And then we have in the tablet and the computer. So we're things that we're feeling a headache, pains, and fever, and high pressure, and comorbidities. So then they'll give us 92% of chikungunya, for example. It's a light model. The software that's going to run the cell phone is light because it's already been trained. But then other data have come in, new data. So we have to refine the model, then we'll go back through this infrastructure, this major infrastructure. So we only were able to do this in the presentation. We have a project for CNPW and the AWS, which is a cloud company, the largest cloud company we have today. We have millions of dollars in credits there, so I think all of our models run on AWS and are 5-6 months of training. So the model to be ready and for us to be able to do an interface. And so then in case of the tablet, as the cell phone is, stays in the health agent's hand. So then it goes to these difficult areas because there's a major problem here. Any question? Professor, your warmth sells IA very well. And those talking about AI talk about it as generous warmth. So let me tell you a story of when I was doing my master's thesis. No, I was doing a specialized course in São Paulo. And I went in and they took me to a sector that found a Professor Samuel Pessoa. Have you heard of him? A great Brazilian parasitologist. He was dissecting a mosquito and saying, you need, at that time he was saying, this was in the 70s, saying the entomologists, they say need to dissect mosquitoes to see how these oocysts and so on are. So then I have a doctor, I work on the point diagnosing. And so then until the 1980s, the entomologists dissected. Never been more. Since tomorrow, we're going to have a round table of entomology. It would be good for us to be talking about so the people who are doing this totemic. So tell me, Professor, what is the origin of this, of your mosquitoes? Where are your mosquitoes coming from? That you dissected? That's with you, Vanessa. I think she authorized me to do this. It's not mansplaining. She told me to do this. I'm not mansplaining. So he's the official, so I'd like to declare before I'm accused of this. So these are all from lab experience. They're raised in an insectarium in our Tropical Medical Foundation. And I forgot the name of it, Dr. Agostinho Max. So then all the labs, they were all the target of some sort of experiment. tests for drugs or things like that. I liked very much the roundtable. I learned a lot. Are you Dr. Norato? You're Eto Dorato. Presentation of the institution. So, because advanced hour, I'd like to thank the attention of everyone and all the speakers. Thank you very much. I'd like to thank the researchers, ladies and gentlemen, who participated in this panel, and our official photo. And with this, we close the activities for the conference and panels for our second day of the 17th RNPM. And remembering that we'll have beginning a poster session happening in the boulevard. There's Freitas outside in the external part of the auditorium. And remember also the program of RNPM begins until Saturday, 9th of November. Okay, for everyone, have a good night and a good